Welcome everyone to Container Day ECS edition. I'm Brent Langston, a developer advocate at AWS, and you may know me from Containers on the Couch, a Twitch show that I co-host with Adam Keller. Adam and I are going to be your hosts for the day, and we have a packed agenda of sessions, demos, and panels all about running your containers with Amazon ECS. As always, we're going to start with a keynote. And so I'm excited to introduce the keynote speaker, Nicholas Harteau. Nick is our general manager of Amazon ECS, and he's going to be walking you through his vision and priorities for ECS. So take it away, Nick.
Awesome. Thanks for the intro, Brent. Hi, folks. Welcome to the first ever Container Day focused on ECS. I am Nick. As Brent said, I'm the GM for ECS at AWS. For those of you unfamiliar with titles over at AWS, GMs own a line of business usually an AWS service, and lead across product, engineering, and the business. You might say I am the single wringable neck for ECS. The buck stops with me. And I want your feedback on the service, on the product, and on today. So there is a crack team of AWS engineers that are carefully monitoring the Twitch stream and will be answering questions. But in addition to that, if you have something longer that Twitch is not the right medium for, you have my contact information right here up on the slide. Please drop me an email, tweet, etc. Anywho, thanks so much for being here today. I am super excited to be here. I am especially happy to be here after a year of mostly pre-recorded events. Very happy to be here coming to you live from New York City. It is a beautiful morning in New York. I hope that in addition to spending the day in front of the computer watching everything about ECS, everybody is getting out and about and getting some fresh air in this beautiful spring. Okay. I also want to thank Docker for helping put all of this together. So at ECS and at AWS, we have been partnering with Docker for a long time, including things like building ECS support directly into Docker Compose. And if you haven't checked that out, please do. I think it's one of the easiest, most simple, and most straightforward ways to go from local development into the cloud. We are very proud of it. But of course, our collaboration with Docker doesn't end there. ECS itself is built around Docker. It's built around Dockerd and Containerd. And in addition to that, we are always looking for ways to improve our collaboration and build more with Docker. So thanks again to Docker for having us. As Brent mentioned, we have a packed agenda today. This, of course, is item number 1. We will cover some more welcome stuff in a bit. But after that, we are going to talk about some pretty exciting new pieces of container tech. Those are ECS Anywhere and AWS App Runner. ECS Anywhere is a new ECS product that really kind of blurs the lines between AWS and on-prem. And App Runner is a new no-ops application development experience we just launched this week. We're super excited to tell you about both. And we've got product and engineering leads from both of those areas joining us in a bit to run you through it. We also have some really fantastic panel discussions lined up. So developer experience is very near and dear to my heart, and I assume yours. I think that's one of the things that brought us all together here today. And we've got some great folks from AWS joining us to talk developer experience, including Uttara Sridhar, who leads engineering for developer experiences for containers on my team, and Jana Dogan, principal engineer for AWS. After that, we've got Containers Heroes, and Containers Heroes are actually AWS customers, but more importantly, they are practitioners with deep experience in containers, and they have helped us at AWS shape our products and our services. So Casey Lee of Gaggle, Mike Fielder from Warby Parker, which I'm sporting today and most days, and Philip Garb of Rio will join us to talk about their experiences building with AWS. Between those two, our good friend Massimo is going to do a little bit of a deep dive on the ECS data plane. After that, we get a little more hands-on and interactive with a Copilot lab and some whiteboarding with the gang from Containers on the Couch, who I'm sure you all know. And Nathan will come back and join us to talk a bit about ECS scalability. We will then wrap up the day with a bald-faced attempt to recruit you all to come help us shape the future of containers on at AWS. I hope you don't mind, but should be a fun day. We've got a lot of good stuff in the agenda. And I will take that opportunity to dive right into it. So I know that we have a pretty broad mix of people here today. There are some folks that are deep on cloud and deep on containers. and some that are just getting started and sort of everywhere in between. But wherever you are on your cloud journey, I think there are a couple of things that we have in common. And these are the same things that me and my colleagues, we hear from AWS customers every day. The resonant theme there is that engineering time is an incredibly scarce resource. It's very hard to get an engineering team spun up, focused, and delivering on on the right stuff. And we all need that time spent on things that move the business forward. And what I mean by that is we want engineers to spend less time configuring CI/CD. We want them to spend less time managing infrastructure. We want them to spend less time on OS upgrades. We want them to spend time solving problems for your customers and your businesses. However, we can only do that when certain requirements are met, right? So first and foremost, you need the infrastructure that meets your needs, whatever those needs may be. Maybe you need GPU acceleration. Maybe you need a certain price performance part of the equation to serve your business. We also need that infrastructure to scale pretty quickly and seamlessly. Part of the promise of the cloud is easy scale up and easy scale down and really paying for what you use. And so we need infrastructure that delivers that. And of course, we need our infrastructure to be reliable and secure. These are all table stakes. And the good news is it is 2021 and we do all that. AWS has market-leading infrastructure, scale, and security. I'm not going to spend time this morning trying to convince you of that. I think that's somebody in product marketing's job, and they'll do a better job of it than I will. But I do think it's important to spend a little time this morning talking about the how. We spend a lot of time talking about the what, like what we're building and what we're doing and so on and so forth. But I think the how is equally important. And I think it's important because really because choosing a platform is an important decision. And you really want to be able to look at not just where we are right now, what we have done, but also where we are going and what the values are that drive where we're going, what we're about. And for ECS, our values, our mission is very straightforward. So the mission of ECS is to bring the power of AWS to containers users in a simple, secure, and easy to use package. And how do we do that? Well, we do that in a couple of ways. We do that by moving your attention up the stack. We manage the control plane. We don't want you on an upgrade treadmill. On ECS Fargate, we even manage the compute infrastructure. You just tell us the memory and CPU requirements of your application, and Fargate handles the rest. We also do that by focusing on a great developer experience. So I hope you see that in our Docker integration and in tools like Copilot. I hope some of you are experimenting with a tool that we released recently called Proton, which is a really powerful way to keep your teams focused on applications rather than infrastructure. And we, of course, do that by focusing on reliability and security and scale so that you can spend less of your time focusing on those things. ECS launches over 1 billion containers for our customers every week, and those represent some of the world's largest and most critical workloads. ECS doesn't do that all on its own, of course, and I also don't do this presentation all on my own. The cats realize that I'm on cam, so this is Quincy. He's going to help out today. So AWS and containers at AWS have a really broad set of services to help you build a solution that is right for you. That is everything from the high-level application management to high-quality orchestration to really innovative compute, and as well as things like ECR, which is Amazon's highly available enterprise-ready container registry. We try to run the gamut, and if you have a piece of your puzzle that is not represented well by AWS today, we want to hear about that. But I also recognize that some of you are new to ECS, so I want to talk a little bit about how all this stuff works together. So ECS actually has many entry points, some of which you might be familiar with, some might be new. Most of our customers interact with ECS through CLIs, CLIs like Copilot, CLIs like Docker, or via our APIs, both directly and indirectly through libraries like CDK. We also have many services that build on top of ECS, such as App Runner, which you'll hear about later, or AWS Batch, amongst many others. We're a popular platform for AWS services to launch quickly. All of those tools work with the ECS control plane. So the ECS control plane manages each container from launching and placement to scaling up and down, to managing the networking environment or ensuring that logging and telemetry are collected all the way to making sure resources are cleaned up after the tasks are terminated. The ECS control plane is fully managed, and it is focused on ensuring the sort of health and readiness of all of the millions and billions of containers that ECS runs. So the ECS control plane, and I think you'll hear Massimo do a little bit more of a deep dive on this later, but the ECS control plane can launch containers on a number of data planes, including Amazon EC2. And EC2, of course, brings you all of the great technology of AWS, including things like Graviton2 and Nitro and Inferentia and the long list of great and innovative Amazon compute products. Most of our customers, however, choose to run on AWS Fargate. With Fargate, you get a fully managed compute environment, no AMIs to spec out, no interface type, instance types to pick, no interface types either. You really just tell us your workload, CPU, and memory requirements, and Fargate handles the rest. It is really a great solution for general purpose computing workloads. And as of today, we also support ECS Anywhere, but I won't steal Deepak's thunder. I'll let you learn about that in a bit. Tying things together are products like AWS Proton, which allows you to consistently manage your workloads across different teams and across different infrastructure types, and AWS App Mesh, which is very powerful service-oriented networking that allows your services to easily discover and communicate with each other securely. Excuse me. And of course, we have a ton of exciting customers doing really interesting things with the products and services. I'm not going to spend a ton of time on this slide. I think we're all familiar with it from a million keynotes. But I do want to spend a little time highlighting some particularly interesting customer stories that I think are illustrative of really the value that ECS brings to containers. And the first one I want to talk about is Ubisoft. So Ubisoft is a game developer based in France. You might be familiar with them. You might also be familiar with them based on the titles that they produce. So they work on games like Watch Dogs. They work on the Assassin's Creed franchise. They work on a personal favorite of mine, which is Prince of Persia, though I may be dating myself with that reference, but such is life. And I don't know how many of you are familiar with the game server sort of tech stack, but Ubisoft is really up against some tough requirements. So it's incredibly difficult to run a gaming backend efficiently and at scale. Popular games can easily swamp a service when a new game or feature is released, and there are really difficult requirements around latency, placement, inter-service communication, etc. And really, what I love about the story is that Ubisoft makes this all look really easy with ECS. So Ubisoft's implementation on ECS is 97% less expensive than their previous solution, which was, of course, something that was provisioned for peak capacity. ECS can't take full credit for that. Of course, you can achieve that sort of efficiency in AWS in many ways. But what ECS can take credit for is Ubisoft being able to achieve that with 3 engineers. And that I think is really what we're targeting with ECS. We really want you to have the vast majority of your time and attention focused on your application and solving your business problems, and as little of your time and attention as possible focused on infrastructure. So Ubisoft is a great example of people using ECS's power and simplicity to run efficiently and at scale. Another one that I like is Okta. Okta, security is obviously very critical to Okta. Okta builds single sign-on services for enterprises. And when Okta was approaching containerization of their applications, the Okta engineering team had already developed a deep understanding of AWS. And in particular, had gone really deep on AWS identity and access management, because they use those IAM permissions and roles to secure their application and their customers' data. And Okta was able to very easily use that knowledge and map their network policies and IAM policies that they had spent a lot of time investing in AWS into their ECS cluster. And so Okta created a whole application framework around ECS, and they were able to do that and get their development teams delivering new services to production in days rather than weeks, because if you know AWS, you know ECS. So this, to me, is a fantastic story of sort of the low cost of adoption of ECS and the ability to transfer your knowledge and your investments that you've made elsewhere in AWS into easy containerization. So, we spent a lot of time talking about powerful simplicity in ECS. And, I want to reinforce, and I think those stories do a good job of reinforcing as well. We all moved to the cloud because we wanted to do more with less. We wanted to not worry about building global infrastructure. We wanted to take advantages of services that were already built for global scale so that we didn't have to build them. And it doesn't stop there. Increasingly, we're moving to the cloud for more and more sophisticated capabilities, and more heavy lifting that's done for us rather than by us. And that is really ECS's mission. With ECS, We do allow you to move your attention up the stack. We manage the control plane. We manage the compute infrastructure with ECS Fargate. With ECS, we deliver a really fantastic developer experience. And if you know AWS, you know ECS. And with ECS, we deliver on reliability, security, and scale. As I said, we run some of the world's largest and most critical workloads. And that, in a nutshell, is what ECS is about. We continue to invest in those themes. Every product decision that we make, every new feature that we launch, those support the idea of removing that undifferentiated heavy lifting. Recent key releases for us have been things like AWS Fargate, which is serverless compute for containers, Copilot, which is a whole new application-focused developer experience in the CLI, and fully managed application deployment for containers and serverless applications. We have a pretty busy roadmap this year. Of course, it goes beyond that, but the thing I think I want to really focus on today, because I'm pretty excited about it, is ECS Anywhere. So, ECS has brought this power and simplicity to Amazon EC2 for a long time. First in regions and local zones, and later in wavelengths and outposts. And we were super excited to build AWS Fargate, which continues to deliver on our promise of having a fully managed container experience, getting folks out of the business of managing omnis. We are super excited to bring all of that power and simplicity to ECS Anywhere. So Deepak is going to talk a bit about ECS Anywhere later in the presentation, but I'm going to spend a minute to steal a little bit of his thunder, because I am super excited about ECS Anywhere. I'm excited about it for a couple of reasons, but first and foremost, I really think this is almost a brand new category of service. So, in the past, if you've wanted to make use of your infrastructure on-prem and your infrastructure in the cloud, you really had to support two different technology stacks. You had a cloud stack and an on-prem stack. And we've been getting a little bit better at that over time. Maybe today you have a self-managed Kubernetes stack on-prem and a managed Kubernetes stack in the cloud. But it's still hard to build applications that are truly portable between those environments. And it's still a lot of operational overhead and load to manage two distinct stacks. And that's really what we're targeting with ECS Anywhere. I think it's pretty magical to be able to do things like start a workload on-prem and seamlessly burst it into the cloud. That's pretty unprecedented capability. And we're super excited to bring that experience to ECS customers. But before I steal too much of Deepak's thunder with ECS, I am going to hand off to Deepak and let him take the reins from here. So thank you. Thank you for being here. I am super excited to spend the rest of the day watching presentations. Hope I'll get to rejoin a bit later. And I hope you have an excellent day.
Hello, everyone. I hope you're having a good day. Deepak Kalakuri, I lead product management for ECS. Thanks, Nick, for the setup for ECS Anywhere. Also joining me is Nathan Peck today, one of our senior developer advocates. You might already know him, actually. He's quite popular in the blogs I hear. All right, let me get started. Talking about ECS Anywhere, there are a few key use cases we hear from customers. There's a bunch of enterprises out there who want to have a consistent experience deploying container applications in AWS and on-premises in their own data centers. There are ISVs who we talk to, our partners who build products on top of ECS and need to be closer to their own customers to effectively compete for on-premises business as well. Secondly, there's a set of enterprises and customers who want to orchestrate on-premises container workloads as part of their modernization of legacy workloads journey. Some of these could be simple task or queue-based applications, or others more complicated web services. Finally, there's a set of customers out there who are running containerized data processing workloads at the edge. Some of the examples could be like factory floor machine data aggregation as an example. So when we talk to these customers, there's a bunch of challenges that they face. Some of the challenges that they really run into are around the complexity of the tools. Containers provide a standard way for developers to package and run their applications quickly and reliably, and improving cost and utilization. Over 100,000 customers use ECS for managing their containers in the cloud today. However, data residency, latency, regulatory compliance conditions, or preference to run on their own infrastructure leave few options for customers for running containers on premises. There are platform teams that want to unblock their developers or their development teams to deploy containers today, but they'd have to choose today between expensive support models or managing their own open source orchestration services, which can be quite expensive, and you would need a large platform team to do that. Other customers who have on-premises environments usually have a lot of unused capacity as well, and they want to make use of their on-premises investment as part of their modernization journey. Customers want to use and orchestrate a similar set of tools so that they don't have to relearn a whole bunch of tools for running on-premises differently from cloud. And there are customers in industries which are highly regulated, financial services especially, or regional regulations, and they need to control how their infrastructure is managed. Getter, for example, is a food delivery company, and it is a pioneer in ultra-fast delivery that revolutionized last-mile delivery in 2015. And it's based out of Europe. The challenges they have when they want to build applications that need to meet the local compliance, they need to run in their own data centers and need to meet compliance around all of that data residency. So they need a consistent way outside of running separate stack on their own data centers. They do not have one consistent way to do that across AWS and their data centers today. Finally, there are those customers who need to run containerized workloads at the edge for processing patient data or machine aggregation data from factory floors or image processing at the edge, and they need to stay on premises for the latency issues. So excited to talk about ECS Anywhere today. Customers have told us that they need to run containers on their own infrastructure, and while they still don't want to have the hassle of operating their own cluster management software. They want the simplicity of ECS and the fact that it just works to be brought on premises in their own data centers. They want the same reliability, scalability, and security of ECS Anywhere wherever they run their applications. As we thought about how we can redefine the experience for these customers, we narrowed down to 4 key tenets. We wanted to give customers a fully managed experience for managing containers. It stays in the cloud, it's invisible, you don't march the drumbeat of patches and upgrades every 3 months. Only information such as health checks and container infrastructure information that's needed absolutely to manage the containers on premises is sent back into the ECS management plane. Secondly, we want this capability to be available truly anywhere on most infrastructure. As long as we have a compatible OS, it can run on the VMs and the bare metal servers that you bring in. And finally, we wanted to differentiate against other options available to customers in the ability to tolerate disconnections. So ECS Anywhere opens up an entirely new category and a large segment of customers to the powerful simplicity of ECS that they did not have access to today before. Customers can run and manage container-based applications using the same APIs, cluster management, workload scheduling, monitoring and deployment pipelines, and the management plane they use with Amazon ECS in AWS today. It's a fully managed container orchestration service that comes up with an SLA and allows customers to easily run, scale, and secure Docker container applications on premises and in all AWS regions, local zones, the edge, and AWS hybrid infrastructure deployment models like Outposts or Wavelength. ECS now helps customers to standardize across one consistent management toolset and enables ability to add on-premises instances into ECS using the same tools and APIs for all container-based applications regardless of the operating environment. With this new feature set, developers can run containers and do not have to manage anything on the management plane. They can actually take the VMs or the servers that their central IT or platform teams in large enterprises have given them and get the agents loaded and easily make it container-ready infrastructure. And it'll actually fit quite easily into their existing tooling as well. So there's very little change that they'd have to do to get up and running with containers. ECS Anywhere simplifies and reduces the complexity for customers for migrating their workloads as well to the container workloads to the cloud as well. With a hybrid-ready footprint, you can run applications in on-premises environments and easily expand or burst into cloud when you're ready to do that, or you run out of capacity as you deploy more microservices. It's priced per instance hour, and the beauty of this pricing is that you do not have to worry about charges that come in because you'd be running more tasks or you'd have to have a larger instance. It's a fixed price, and it would be priced at less than a Starbucks mocha frappuccino per instance per month, so it shouldn't be a consideration. We really want to encourage container adoption, whether it's on premises, in a hybrid infrastructure model, or it's in the cloud with AWS. Central infrastructure and the platform teams do not have to worry about unexpected expenses or deal with expensive support models. There you go. Excited about the launch roadmap that we have planned and the future as well. We continue to invest in our roadmap not just for ECS, but for all container services. Every product decision we make supports the idea of removing undifferentiated heavy lifting, as Nick alluded to, and moving developer teams up the stack. Our key features at the GA launch that is planned imminently would include the ability to run tasks and services with service order scaling capabilities that you're used to with ECS. We'll support the bridge and the host networking modes. We support integrations to key AWS services such as the CloudWatch or the SQS. And we also support open source tools such as the OpenTelemetry that we've announced support for back in December. ECS clusters can now have heterogeneous instances, including external instances. And ECS Anywhere is available in all AWS regions and the GovCloud. We also have a busy roadmap for the remainder of the year. There are a few key areas, including support for load balancers, service discovery, troubleshooting with ECS exec, a popular functionality that we recently launched for ECS. Support for Windows OS for all of those running Windows applications on premises. And finally, the ability to burst into cloud or auto scale for the instance with capacity provider integrations. And to that end, we'll continue to work with partners as well. We have a lot of partners in the private beta going on, and they've tested their integrations. And at GA, we would announce a whole set of partners that have qualified and have integrations with ECS Anywhere. Let me talk about a couple of different examples that for customers who have been using ECS Anywhere in the beta today. Cyber Agent is a large internet services company with $4.5 billion in revenues and hundreds of employees, and they're based out of Japan. Cyber Agent focuses on advertising, gaming, and media services, and it's across a huge variety of verticals. They run a hybrid environment in the cloud and on their own data centers. Today, they have distinct tool sets to navigate the multiple tools, and it's not consistent between the cloud and the on-prem data centers. This results in a lot of overhead for them and lack of agility in terms of pushing new features out and unnecessary complexity. They had to manage a container orchestrator on premises with their own custom scripts and open source code. With ECS Anywhere, they can offload all of that work into the management plane, fully controlled with SLAs that works for both on-premises and the cloud. The team is now able to focus on the business problems and not worry about orchestration. Here's a different example. This is an example for a company that is doing innovations at the edge. Siemens has a lot of customers, and they run very insightful, real-time and rich insights for their own customers and customers running factory floors across many different countries and locations. Today, they'd have to run a local management plane for the containers at each factory floor, and this is expensive, cumbersome, and really hard to maintain. They do not have one single way to manage all of those factory floors or the applications running at the edge. With a fully managed control plane, which is ECS Anywhere, and governance-rich and policy-rich toolset that comes from AWS, their teams are now able to onboard their customers and deliver real-time insights. Over the next 1 to 2 years, they plan to roll this out across their factory floors. They can send processed data to the cloud for storage and retrieval or further insights and analytics. Let me take a couple of minutes to talk about, at a high level, how it works before we go into a demo. There's really only 2 steps. Step 1 of 2, bring your own infrastructure. And the way it would work with ECS Anywhere is that at a high level, customers will install the AWS Systems Manager agent on a supported operating system and securely connect that to their own customer managed infrastructure into the ECS and the AWS cloud. Customers can actually further leverage the power of Systems Manager to manage their own on-premises data center and infrastructure at scale, and that capability from patching and every other capability that the Systems Manager has an advanced tier functionality should you choose to. Once the SSM agent has made a connection and the keys have been authenticated, you're able to securely deploy the ECS agent as well and connect the open source ECS agent, by the way, and connect that to the new customer managed infrastructure into the ECS cluster as an external instance. You can do all of this with just one script. Step 2, now you take this ECS managed connected external instances that has been securely connected, and you can now run your control plane or the management plane to run your tasks and services and your containers just like any other capacity that you do today with ECS, the Fargate, or the EC2. ECS Anywhere is designed to deliver the same powerful simplicity you get at AWS in your own data centers or wherever you run. And this means you're easily able to connect and send data to any other AWS service like the CloudWatch and use consistent IAM roles and tooling. With that, let me turn it over to Nathan Peck to go through a demo.
Hey everyone, my name is Nathan Peck and I work as a developer advocate at AWS. Today I'm proud to be able to show you a demo of ECS Anywhere actually working right here in my home office. So to kick things off, the first thing I want to show you is the actual hardware that ECS Anywhere is running on right here on my desk. And so there is a Raspberry Pi cluster here built out of 4 Raspberry Pis connected to a switch. And this is actual hardware that is running an ECS agent and running ECS tasks right now. And I'm going to show you how this all looks in the console in a bit. But there's also a blog post coming up soon that where we'll go into more detail about how you can actually build your own home lab similar to this one with a parts list and instructions for how to set everything up. So that will come out in the near future. In the meantime, I want to show you how it looks in the console right now when I actually register capacity to my cluster and start using it as an ECS cluster. So here in the console, there's a new button called Register External Instances. And if I click on that button, it asks me a couple of questions like how long I want an activation key to be active for, like how long I want to be registering these instances, and the number of instances that I want to register. And when I click Next Step, it gives me a command that I can run to actually register the instance or the device into my ECS cluster. And I'm not actually going to run this command live because it does have a secret value in it. And if I was to run it live, somebody could potentially stream snipe that off of me and go ahead and register their hardware into my cluster, which would be non-optimal for my demo. But what I will show you is I've actually already registered some instances, these Raspberry Pis here on my desk, into an ECS cluster. And you see there's a new field here called external instance true. Another thing I see here is that this ECS instance ID, which would normally be I, starting with I for instance, is now MI, standing for managed instance. And normally when I would click this, it would go to the EC2 console. But let me show you where it goes now if I click on it. It goes to AWS Systems Manager, Fleet Manager. And here I can see some information about the Raspberry Pi, such as its local IP address in my home network, SSM agent version, the operating system, which is Ubuntu. And I can also see that it has an IAM role, which makes it an ECS external instance. So I want to show you one of the cool features that I really love about Fleet Manager and ECS Anywhere, and that's the ability to start a session. So if I click Start Session, what's going to happen is it's actually going to open a SSH connection connected over SSM and protected by AWS KMS, Key Management Service, to my Raspberry Pi, even though it's on my home network. So this device does not actually have a public IP address. I'm not manually port forwarding anything to my home IP address. Instead, it only exists here in my private network with a private IP, but I can connect to it from the cloud and I can actually run commands on it. I can list, I can go to a particular directory and look at the file system. And what I want to show is sudo docker ps. I can actually show that there is Docker running on this machine and it is running Docker tasks. And the way this works is AWS SSM has an agent which is running on my Raspberry Pis, which opens a control panel back to SSM. And that allows us to actually communicate back over that control channel down to the Raspberry Pi, even though it has no public IP address. So this is amazing. It already means that I can actually monitor these devices that are in my home network when I'm on the road or anywhere that basically that I can access the AWS console. I can go back over the control channel down into one of these instances and control it. But if I don't want to actually manage these instances basically via SSH, I do have another option, and that is using the Amazon ECS API to manage these instances and launch an application onto them. And I'll show you that I already have some services set up here. I have 3 demo services, and I actually have a Redis service that are running inside of my Raspberry Pi cluster right now. And what I'll do right now is I'll launch a new service. That way you can see how this works when using ECS Anywhere. So first I choose external launch type, and then I choose a task definition, which also needs to be a task definition that was created with the external launch type. I specify a name for it, and then I want it to be a replica, and I want there to be 3 tasks distributed across my 3 Raspberry Pis. And then I just click Next Up, Next, and Create Service. And what we'll see is after a few moments, it will start launching tasks onto my Raspberry Pis. And here you see they're showing up as pending. And I will refresh this a few times. Okay, so we got 1 of them running and 2 running. And let me just go into my session over here, and hopefully this is the right instance that has the Nginx running on it. Okay, is this the right one? Okay, I'll wait a little bit and see if it launches one onto this instance. I think I probably need to log into one of the other instances over here. So back to Fleet Manager, Let me check. I don't think I clicked this one last time. So I'll connect to this one. And once again, it's super convenient to just be able to connect to any one of my Raspberry Pis through the AWS console without having to actually SSH to it over my local network. Okay. Oh, this is the same one I was in last time, wasn't it? But yeah, so I do have some services running on here. So if I curl the localhost network and look at port 8080, I can see a response back. And one of the things I also want to show you before I end this demo is that I can send traffic from the cloud to my Raspberry Pi instance here in my home network. And the way that works is using the VPC feature of site-to-site VPN. So if I go into the VPC and I click on site-to-site VPN connections, and I have to go to US East 1, I actually created a VPC that was in the region that's closest to my home network. And you see that I have a VPN connection that's been created here called Raspberry Pi. And on the other end of that, if I actually open a terminal to my Raspberry Pi 1, you can see how that works on this Raspberry Pi 1. It is a IPsec VPN that bridges between my home network, which is 192.168.1.0, and my AWS VPC, which is 10.0.0. And so what that allows me to do is I can actually launch a load balancer within the AWS region and have it sending traffic to my Raspberry Pis here on my desk. So here I'm going to spin up a little machine and look at the Raspberry's DNS for my application load balancer here. And here you're actually seeing an HTML page that is being served by the task running here on the Raspberry Pis, and with the hit counter here actually being persisted into the Redis. And so you're actually seeing live traffic that is going to AWS region into a load balancer, and then from that load balancer down to the Raspberry Pi here in my desk. So it's really an amazing system. It works very well, and I'm always very impressed about how fast it is too. About 10 milliseconds latency between the AWS region and my Raspberry Pi cluster. So I don't actually see any delay or anything as I'm using a cloud-hosted load balancer against my local network. So with that, I will turn it back over now that I've shown all the interesting things with ECS Anywhere.
Nice. So I'm pretty excited about this because the fact that you don't have to run an orchestrator is, I think it's pretty great. I think it's fantastic. I've run maybe all the orchestrators, at least all the popular ones, and they're a pain to have to mess with and upgrade and manage. And that's one of the reasons that I love ECS so much, is all that's just taken care of for me. And now that gets to be extended out to the edge, out to my own data center where my legacy workloads are running. I mean, that's just fantastic. So we had some questions stream by in the chat, and I don't have the one that I wanted to ask available to pop up, but I vaguely remember it. It came up in a couple different forms. One of them, one of the questions was, what's the compatibility situation? You know, like how do you know if the hardware that you have in your data center is going to be compatible with running ECS Anywhere?
Yes, that's a good question. So the ECS Anywhere team has done a fantastic job making an install script that basically looks at the environment and determines the architecture, determines the operating system they're running, and it downloads the appropriate agent architecture, and then it even downloads from the appropriate package manager for your system. So in my case, I'm running Raspberry Pis, which are ARM architecture, and I'm running Ubuntu on them. And so it's pulling from the Ubuntu package manager system, and it's pulling the right architecture for ARM. And, you know, if I pulled in Intel, I've tried this with like just an old Intel laptop, works just fine. Basically, if it's a operating system that is fairly well known, I think there's a list of like 7 or 8. We'll publish those in the documentation, like the full list of ones we've actually tested on. And it has a architecture that is reasonable. There is an agent that works for that architecture, and the install script works on it. So we've tested it across a wide range of different devices and operating systems. And if there's one that it doesn't support and you want it to, let us know, and we'll definitely look into seeing what's necessary to make it work on your architecture and your system as well.
And that's where public roadmap comes in, right? Head to our
Exactly.
public roadmap. Tell us your use case. Let us know. So, can I ask a question, Brent? Do we have enough time for me to ask a question?
We have all the time in the world.
Oh, that's what I like to hear. So there was a couple folks asked this question, and again, it's hard to pop it up because I think it's already passed in our history. But so running this on-prem, do these ECS tasks have the same functionality that an ECS task running in your VPC would have? So some examples are IAM, attaching an IAM role, putting it behind an elastic load balancer, those types of resources. So
IAM role, absolutely yes. Attaching to a load balancer is a little bit more complicated. So I just demoed the fact that I can have a load balancer sending traffic to my on-premise device. However, I had to do a little bit of manual setup for this. Currently, I had to set up a VPN connection in between my AWS VPC and my local network. So that way the load balancer can actually address the private IP addresses of the Raspberry Pis on my home network. And I also had to manually register the IP addresses of these devices into the load balancer. So there is a little bit of extra setup compared to what you might be used to with ECS in cloud, where everything is fully automated. We'll work on this over time to make the experience easier. Currently, you do have to do a little bit of networking configuration, and you do have to do a little bit of manual management to actually point cloud resources at your on-premise devices.
So just to quickly add to that, yes, we do launch with a bunch of service integrations at GA roadmap plan, and following that, we'll add the other features like the load balancer. The beauty of ECS Anywhere is that you don't have to take a new package and install it every time we push a feature. It's a fully managed control plane. So you'll transparently get all the feature innovations we make. And that's the reason we decided to release features over time incrementally rather than make a package and release it.
And one thing, I'm not sure if my screen is still being shared, but
I'll pop it back up.
The CloudWatch and metrics and logs integration does in fact work for these on-premise instances on my desk as well. So I'm seeing the access logs here. Somebody's clearly trying to scrape my instance and hack it.
That's not me this time.
PHP my admin request coming through. Fortunately, it says pretty well protected, so I should be good there. But then also, I can see the metrics for my service. And so this works just as well for my on-premise instance of the Raspberry Pis here as it does for EC2. I can see the metrics and logs. So a lot of those integrations, yes, they do function on-premise.
That's pretty cool that you get to sort of hand off the responsibility of metrics and logs and all that stuff. And I mean, I know you've been able to do that kind of thing for a while, but it seems to always take running additional stuff. Even when you're just going to ship things off, you have to run all this additional stuff. But you're getting all of this just naturally when you install ECS Anywhere and let it just take over your machine. Not that I shouldn't have said take over. Let it just exist on your machine.
Yeah, it doesn't actually really take over your machine. So if my screen is being shared, you can actually see here that it doesn't actually require that much to run. So I have my most of the threads here are actually my application. The two things that actually run is there's a Docker agent, ECS agent, and there is an SSM agent. And so these I need to actually filter out the user threads here. I can actually press F4. No, I can't do that. That's F2. Display options, hide. There we go. And so now I should be able to see better all of the threads here. And so you can actually see there's an Amazon SSM agent. This is what's supplying an IAM role to the Raspberry Pi and allowing it to communicate to ECS. And then there's the ECS agent as well. And that's all I need. It's not actually like flooding my Raspberry Pi with a ton of different agents and sidecars and stuff like that in order for all of this to function.
That's so awesome. This is so cool. And yeah, this is cool. I'm just excited about this. I can't wait to dive into it. So on that note, we're going to take a quick break, but when we come back, we're going to be talking about App Runner, which is another service that is very new, and you may not have seen it yet. So we want to explore that and see what that's all about. So hang out. We're going to take a quick break. There'll be a countdown clock to let you know when we'll be back, and then join us to talk about App Runner.
I really like to start my morning going outside on the patio. The morning standard meetings very important for me because I can know what the team is doing. I think my job is mainly creating an effective team to deliver the most value to customers. I really like when I see my reports growing on their career and also when people are excited about the work that they deliver. We have sister teams also in Cupertino, Seattle, and San Francisco. AWS managed to get everybody on the same page, regardless of which team you are. End of day, learning how to play the guitar. That's one of the biggest challenge outside of my work. I'm Helbert Maish, a software development manager at AWS in Vancouver, British Columbia.
Today, more and more people are running their workloads in containers for better resource efficiency, workload portability, and flexibility. That's why AWS created BottleRocket, a Linux-based operating system that is purpose-built to run containers. BottleRocket updates in a single step, and updates can be rolled back if necessary, giving you fewer error rates for OS updates and increased uptime for containerized applications compared to general-purpose operating systems, which update package by package. You can easily automate updates to your operating system by using container orchestration services such as Amazon EKS, helping to reduce your management overhead and ultimately cutting down on your operational costs. And because BottleRocket includes only the essential components needed to run containers, it effectively boosts resource utilization and lowers security risks. By leveraging BottleRocket's open source development model, you can make your own code changes and produce custom builds that support your preferred orchestrators and build tools. You can also submit your changes for inclusion to the AWS BottleRocket builds. AWS provided builds come with 3 years of support, giving you a single point of contact for all your infrastructure support needs, including operating system support. Build with confidence and optimize your container infrastructure today using BottleRocket.
All right, we're back. Welcome, everyone. I want to introduce 2 new guests. We have Archana and Akshay. Also, Adam, I realized I popped him on the screen a minute ago, and we never told you who he is. So let's do a quick round. Who are you people? Tell us about yourselves. Let's start with Archana, and we'll go from there.
Yeah, hi everybody. My name is Archana Shrikanta, and I'm a principal engineer in the Container Services org. My main area of focus is serverless containers. I've been the founding engineer for Fargate, and most recently I've been involved with App Runner, our newest addition to the container suite.
Nice. Akshay, who are you?
Hey everyone. My name is Akshay Ram. I'm a product manager with this new service, AWS App Runner.
Cool. Adam.
Did I have to introduce myself? My name's Adam Keller. I'm a developer advocate on the Container Services team. You may see me on Twitch a lot. I co-host Containers from the Couch with Brent, and we talk all things containers.
Nice. All right. So let's talk App Runner. Who wants to go first?
So I'm just going to briefly go through a very quick presentation. And this talk is going to be more about the demo and the product itself. So Archana's I'll hand it over to Archana and she'll walk us through the demo. So I'll just get started.
I don't see your screen share, Deepak.
Yeah.
I mean, Akshay.
Yeah, just give me a second.
Reading the wrong name, sorry.
It's early.
More coffee, sorry.
There we go.
Can you see my screen?
I can, and now we all can. Thank you.
Okay, awesome. So let's get started. Today we're going to talk about AWS App Runner. As I said, the presentation is really, the presentation in terms of a PowerPoint is really small. I'm just going to walk through the problems we're solving, and we're going to spend a lot of time on a demo where you can actually see the product and the features it affords you.
Hey, Akshay, we're actually seeing your notes view. We're not seeing the slide view.
Okay, give me a second. Can you see it now?
It's the same. I think if you want, you can swap views, I believe, up top there.
Yeah, swap displays. It was right there. Sound effect helps too, usually.
We are way better at running containers than running PowerPoint. I'm just saying.
Just give me a second, sorry.
No problem.
I don't even have notes, to be honest.
I wish I was better at PowerPoint to tell you what to push.
You could just on the top hit swap displays there.
Okay. I see what you mean. Let me stop sharing my screen. Just give me a second.
But if not, you can just share it. It's okay if you have no notes.
Yeah, I don't have any notes, but let me just give me a second.
No problem. Doing the presenter view of PowerPoint with no notes is the way you impress everybody, because you're just proving that you aren't reading.
This was his plan from the beginning. Don't you know? Like, oops, I'm sharing my presenter view.
All right.
So let's try this time. Are we good?
No, we're still seeing the.
It's okay. I say we just go through it. We're here to have some fun. Let's do it.
Sounds good.
Yes, let's get started. So essentially, cloud infrastructure today is super flexible. And when you're running web applications, specifically container-based web applications, you have a lot of choices. There is AWS Fargate as a compute layer. There's also Amazon EC2, AWS Lambda. So customers have a lot of choices there. You can use a container orchestrators like Amazon ECS or Amazon EKS. These orchestrators are really powerful and allow you to schedule and run containers at scale. You can use elastic load balancers to route requests to your web applications. You can set up custom routing rules. You can use AWS application autoscaling to have custom metrics and scale based on the metrics you believe is the right for your web applications. And you can also use AWS Code Build to essentially build and run and deploy your web applications in a streamlined fashion. So we see plenty of customers use these services together and the power and flexibility it affords them and run at scale. However, there were some customers who told us that, hey, I really want to operate at the application level and not infrastructure level because I don't have much infrastructure expertise or container expertise. They also told us that, hey, I want something simple, but I also want something that scales, because there's plenty of solutions that actually scales there are plenty of solutions out there that's simple, but as customers grow, they hit a wall and they want to avoid replatforming. So that's something they told us. And finally, they want infrastructure fully managed. They don't want scaffolding. They'd rather have infrastructure fully managed for them, where they don't see or manage and operate infrastructure resources, but they just operate applications. And that's exactly where AWS App Runner comes. So we take all of these services and you just operate at the application level. So you come to us with web applications, and AWS App Runner manages the rest. So underneath the hood, if you see, we have what is in the green box here is what customers own and manage. It's basically their source code, which shows their web applications. It could be an ECR public, GitHub, or even ECR private. And in the orange blocks below is all AWS App Runner. And as you see, there's a lot App Runner does for you. You don't have to do it. It'll basically load balance your traffic. It'll encrypt your traffic when you build a new version of your source. It'll build and deploy it in a safe way. So you get a lot out of the box, so you can really focus on your applications. So just to summarize, there are 3 takeaways here with AWS App Runner. You just focus on your applications and not infrastructure. There are a lot of developer-focused features, and some of them are the Git push, where you can Git push to your source code repository or container registry, and we'll automatically deploy a new version. You'll see this in the demo later today. And there's finally a lot of customizations we built. In addition to managing a lot of infrastructure for you, there's a lot of customizations in terms of scaling that allows you to have a pricing that scales based on your request. So you pay for compute resources that scale based on incoming requests. So that's pretty much all I had with the presentation, because I wanted to spend more time on the demo. And over to you, Archana.
Yeah, all right, demo time. So let me share my screen here now.
I see it.
All right.
And there we go.
All right, so today we're going to not go through one demo, not 2 demos, but really 3 demos to show you all the key features of App Runner that we think are the differentiating features of App Runner. The first demo is really just going to be the service creation flow. So we're just going to walk through the steps to create the service, and you'll see how simple it is to just go from source code to a live running service on App Runner. And for the second and third demos, we're going to pop in here to some services that I've pre-created, and we're going to demo the auto-scaling functionality. We're going to throw some load at the service and see App Runner actually scale up the number of application containers behind the scenes. And for the third demo, we're going to do auto deployment demo. So we're going to actually go in and make a code change to our source code and watch App Runner automatically deploy that change out to the service live. So without much further ado, we're going to get started here. So this is my GitHub repo, and I have a very simple Python web application. It's listening on port 8080, and all it's doing here is it's looking for an environment variable called name, and when it gets an HTTP request, it just prints hello name on the screen. So we'll pop back over into the App Runner console and start the service creation workflow. Now, as you can see here on the left, there's really just 3 steps to get this up and running. In the first step, we're going to configure our source, so the starting point, and deployment settings. In the second step, we're going to configure build settings. And in the third step, we're going to configure all the runtime settings of your service. So with respect to source, you can either choose to start with a pre-built container that you've pushed to ECR, or you can choose to start with source code from GitHub, which is what we're going to do today. And either way, whether you start with a container image or source code, you need to give App Runner permissions to access those artifacts. If you're starting with an image in ECR, you provide an IAM role. So I'm going to show you that here. So this is where you'd provide an IAM role with access permissions to ECR. And if you're starting with GitHub source code, your first step here is to create a connection to GitHub, which is what gives AWS permissions to access your source artifacts. Now, I've already created some services against this repo, so I already have a connection set up. It's just a one-time setup step. But if you were going through this from scratch, then you wouldn't see these fields auto-populated, and you basically walk through this add new wizard. And what this will do is it'll basically pop up a new window, and it'll prompt you to log into your GitHub account. And once you're in your GitHub account, you install this AWS connector for GitHub application, through which you can then grant permissions to AWS to access your source code. Deployments-wise, you can either choose manual deployment, which means that any deployment trigger to your service, you're in control of it. You can make an API call to start the deployment. Or you can choose automated deployments, in which case, every time you make a commit to your GitHub repo or push to your ECR registry, App Runner will automatically detect that and start a deployment and roll that new code out to your service. And we have a demo for this specific functionality later on as well. And then over to step 2, the build settings. So if you noticed in the repo, there really isn't any need for me to add a Docker file or any kind of build file here in my repository. And that's because I can basically set up all the build commands in App Runner itself via API arguments and in the console here. So let's go ahead and do that. I'm going to select Python for my language runtime. And in the build command, we're going to install the dependencies here. And in the start
really
command,
cool.
we're just going to say Python, server.py. Now,
getting rid of the Docker file is, sorry, I'm just so fascinated by this because I've talked to so many customers about, worrying about optimizing their Docker file, and they make a change and stuff breaks and they don't fully get it. But these are the commands that a developer is just going to already know. These are the important things that they know. I have to pip install stuff. I then run Python in my app, and like those are the easy things. And if you just fill in the blanks, then it looks like App Runner is going to do the rest for us. This is so cool. I'm excited.
App Runner, I think the team has been very cognizant about removing all those additional kind of layers and barriers to entry. So this service creation experience is completely streamlined and as simple as it can be. So that's definitely one of the main goals of App Runner. But if you do choose to not put these settings in kind of this dynamic format in the API, you could actually encode this in code by adding an App Runner YAML file just to the root of your repository with the same settings, and App Runner will inspect your code and look at the App Runner YAML file and get all these same inputs from there. So that is another option.
Awesome.
And then over to the service runtime settings. So let's give this service a name. I'm not very creative with names, so we're just going to call it demo. And then you pick the CPU and memory resources. So this is the CPU and memory size for each application container that we're going to run behind the scenes for you. And then we're going to add the name environment variable here. What do we say? Hello. I'm just going to use my name. Autoscaling, there's autoscaling settings here, which we will talk more about when we get to the autoscaling demo. But for this application, we're just going to leave it at the default. You can configure health checks for your application. And these health checks are used both as the load balancer health check to make sure we're not routing traffic to unhealthy instances. And it's also used as the deployment health check. So when we perform a deployment of your service, we bring up the new application instances, and we run the health check to make sure they're completely healthy before we start shifting traffic over to the new version of your code. And security-wise, you can specify an instance role here. So this is very similar in concept to the EC2 instance role, for those of you that are familiar with it, or the Fargate task role. And the idea here is that if your application is trying to access other AWS resources, for example, let's say a DynamoDB table, then it needs AWS credentials to access the DynamoDB table. And rather than having you as the customer try to wire the credentials down to your application, you can just create an IAM role with the requisite access permissions and plug it in here. And App Runner will basically automatically wire the credentials for you, make it available at a local endpoint within your application environment. So any AWS calls that you make with the SDK or the CLI will automatically have access to those credentials. the other setting here is for encryption. So we do store copies of your source code or images. And in order to encrypt it, by default, we just use an AWS managed key. But if you so choose, you can provide your own KMS key, and we will use that to encrypt your artifacts. And that's really it. So we click next, we review all the settings that we just plugged in, and we create and deploy, and
Awesome.
off it goes.
Do you have time for a couple questions?
Yes, absolutely.
Well, I assume while that's deploying. So we've had a couple of questions around like what version of Node, what version of Python, but let me kind of zoom out from that for a second. Is it possible to run something that isn't Node or Python?
So at the moment, the language runtimes we support are only Node and Python, but that's definitely something that's up high on the roadmap to enable other language runtimes. So we definitely want to.
Can we bring our own container?
Yep.
Yes, absolutely. So that's what we talked about with regards to the source being, you can either start with the pre-built container image, or you can start with source code. So that's definitely true. So if you do want to use a different language runtime, what you can do is you can basically package it and build your own container, and then start with the pre-built container, and then you have the freedom to put whatever you want in it, whatever language you choose to use, until we support all these other languages that we want to support from at the source code level.
And then Delboy GG asks, and by the way, hey Delboy, good to see you again. What's the pricing compared to ECS? And he's guessing it's probably a bit more, right? So Akshay, could you talk to that a little bit? Because I know there's more that goes into the thinking than just, what container am I running?
Yeah, no, absolutely. I can talk about that. So when you think of pricing of App Runner, you get the compute, which is your Fargate task. You get the load balancer as well, which you pay separately. And you get the ACM, which you get the certificate management, which you have to pay independently. So if you look at the pricing, it may appear more expensive than Fargate, but you're actually getting more for what you pay for. And it is competitive in terms of pricing. If you actually deconstruct all the components and try to compare.
That's awesome. And then Delboy wants to know, is this in CDK yet? And I know it's in CloudFormation, but what about CDK? Have we? I know that team builds from CloudFormation, so I kind of expect that it's there or getting very close. Do we know yet?
So it's getting close. We have L1 support. We already have CloudFormation out, so you should see that soon. And we have an item on the GitHub roadmap, and I'll update it as soon as CDK build is there with that.
Awesome. All right, let's progress check. How are we doing?
Yeah, so this service is still spinning up. It may take a few more minutes, but what we can do here is kind of jump over here to the auto-scaling demo.
Okay.
So like I mentioned, I've pre-created this service. And auto-scaling wise, what we're going to do here is we're going to throw some load at this service and basically watch the service spin up additional copies of your application in order to handle that additional load. So before we get started, let's understand some of the auto-scaling settings here. So there's basically three settings that you can use, three knobs that you can use to kind of guide how we auto-scale behind the scenes. The first one is concurrency, and this is kind of the primary scaling axis behind the scenes. This number is basically the maximum number of simultaneous requests that a single copy of your application can handle, right? So as soon as we start to see that the existing application instances are starting to get hot with regards to the concurrency that they're handling, we will start to add more application instances behind the scenes. There is also a minimum and a maximum setting. The minimum is basically a minimum provisioned number of instances that we keep warm behind the scenes. Even if your application isn't actually receiving any traffic, we will keep these many copies of your application bootstrapped and warm. And the reason you may want to do this is to avoid that cold start latency when you get the next burst of requests. And there's a maximum size, which is basically a cap on the maximum number of application instances we launch behind the scenes. And this you can use to basically control the maximum cost that your service can incur. So for this application, we've set a concurrency of 30. I'm going to pop over here in my terminal and start to throw some load at this.
And can you blow up your font a bit?
Oh, sure. More? Is that good?
Let us know in chat if we need the font to be bigger. I think that's probably okay, but we'll see.
I can make it bigger.
More, they say, more.
Oh, more. All right.
Cool.
Is that better?
I think so.
Okay, I'll go one more. It looks ginormous to me, but all right. So Hey is it's just a local load generator tool that I'm running on my laptop. And the settings here, -C is concurrency. So we're setting concurrency to 75. So the tool is basically going to spin up 75 worker threads that are just going to constantly bombard the service endpoint with requests. And -Z is the duration. So we're going to actually run this load for 60 seconds. And we're going to copy the service URL here. And off it goes. So that's going to run for a minute, but while that's running, let's look at some of the metrics that we have available that's going to tell us what's happening behind the scenes. So the top one here is just the request count, the raw number of requests that are hitting your service endpoint. We do have some additional metrics here to show you the response code breakdown, the latency of your requests. And then this one is the interesting one from an auto-scaling perspective, the active instances. So this is the number of application instances that are actively receiving traffic at the moment. And I want to clarify here, we use the term instances here to mean a copy of your application, and it's not to be confused with EC2 instances. So this is really just a replica of your application. And so as you can see, at steady state, kind of when your application is not receiving any traffic, this number is at 0. And if we pop up here, there we go. So the load test completed, we basically fired about 35,000 requests. All of them received a 200 OK response. You can see that the latency of the requests here, as measured by the tool, was well below 0.3 seconds for the most part. And we can now pop over here and see what happens to this active instances metric as the load hit the service. The metric might take a few minutes to catch up.
And it's just, I think it's cool to point out that all the work you did to set up auto scaling was nothing.
Exactly.
It's just built in.
Right? All the work. Nothing.
So that that was a little joke, but really, like, you didn't have to do anything. All you did was just send load at your service, and it's going to auto scale.
Yeah, and it's not just auto scaling, right? You didn't have to stop at the EC2 console. You didn't have to stop at the load balancer console. You didn't even have to stop at like the Fargate or the ECS console to spin up your containers. All you did was point us to your code and a few clicks to set up your build and runtime settings, and then you have an HTTP endpoint against which you can make requests.
That's fantastic. And logs, metrics, all there out of the box. Really cool.
All out of the box. So there we go. We're starting to see that data point for requests. And there we go. So here you can see that App Runner basically scaled up your services, and we activated 2 copies of your application to handle that load that just came in. And from a pricing perspective, for the most part, during this kind of idle period of your service, you are paying a nominal fee for the minimum provisioned instances that we talked about. For the most part, the cost of your service is really just going to be the CPU hours or CPU minutes for these active instances, which you're only paying for when your application is actually processing requests.
So cool. So we have about 5 minutes left. Do you think you can, did you have another demo?
Yes, so that was the auto scaling. So I want to quickly do the deployment, auto deployment demo as well. I think 5 minutes is perfect to go through that. So this is another service that I have created, and I just want to show you here in the deployment configurations, we've set it up to receive automatic deployments. So I'm just going to pop over here in GitHub and make a edit to my web app. Let's see. So instead of hello, let's say good morning here. And we're going to commit this. And as you can see here, we go into the activity. Boom. Right, we have a deployment in progress, so it's automatically picked up that change and it's just going to deploy it out. We do a blue-green deployment behind the scenes. So as I mentioned before, we'll stand up new copies of your application against the new code, perform health checks against it, make sure that set of application instances are healthy, and then cut traffic over to the new version of your code.
And could you just quickly touch on, there was a question in the chat about what type of deployment configuration, how do we manage the deployments? Is it like a rolling deployment? What's that strategy?
Yeah, so it's a blue-green deployment, which means that all your traffic is going to hit the old version of your code. And let's say we're running 3 copies of your application originally. So the traffic will continue to hit the original 3 instances. Behind the scenes, we will bring up 3 more instances with the new version of your code. And like I said, run the health checks. And only after all 3 application instances are healthy, we will cut over all the traffic over to your new version of the code and then spin down the 3 original instances against the old version of the code.
Amazing.
So I saw a question in chat, and it's come up a few times, so I'm going to go ahead and put it out here. But is it possible to jump into the container or the running app like we do with, Copilot exec, for example?
We don't have exec functionality at the moment. This is really meant for long-running just web server applications that are just processing HTTP requests. The caveat here is that because it has this kind of automatic scale down, scale up functionality, when your service is not receiving any requests, basically the resources allocated to it are shrunk down and throttled down. It's only when the request response kicks in that we actually balloon up the resources allocated to your containers. So we don't expect that there's going to be a lot of kind of background work that can happen in these applications. So things like execing into your containers and trying to perform activities outside of the request response flow is not something that we envision for applications running on App Runner.
Awesome. This is so cool. We've had it on Containers from the Couch since it launched. We've of course done a blog post. We've seen it on What's New. But it's every time I see it, I just get so excited because I think through, running a web application at scale and what I used to have to go through. And especially when Akshay shows me the slide where all the stuff gets sandwiched down, like that's meaningful to me because I used to have to manage all the stuff. And so not having all that stuff anymore and just, here's my app. run it. Like, just make it work and make it scale and handle the logs and handle, you know, all that stuff, the metrics, all that stuff is just so nice to have it built in. So I'm pretty excited about the future of App Runner. So we're about out of time for this segment, but up next, we're going to be talking about the developer experience. So we're going to take another quick break, and then we'll be right back with a whole new set of people. So grab some coffee, and we'll be right back. Thanks.
I usually like to wake up in the wee hours of the morning to get some work done in my study. By the time the family wakes up, I help my wife with the morning routines. As a software engineer, the dream is to be right there at the bleeding edge. The solutions that we build change industries. My name is Odi Enaholo. I'm a senior software engineer at AWS.
Containers are changing the way that we develop, test, and deploy software, making it faster for us to test and deploy and experiment with these new features and capabilities.
We built AWS App Mesh that makes use of the Envoy sidecar capabilities to now give you a complete view of the network, where you can have one consistent mechanism between the communication for all of the different components that now live in your distributed system.
Today, I'm excited to announce AWS Fargate, which allows you to run containers without having to manage servers or clusters.
Because Fargate does it for us. Fargate helped us win customers.
A new service called the Amazon Elastic Container Service for Kubernetes, EKS. This makes running Kubernetes as a managed service on top of AWS much, much easier.
The Amazon EC2 Container Service. A highly scalable, high-performance container management service.
Moving to containers, if you have not done it, do it. It will simplify your life quite a bit.
Hey, it's Adam and Brent, and we wanted to let you know that if you're looking for more live or on-demand container content, you should subscribe to our YouTube channel.
Head on over to youtube.com/containersfromthecouch, and also check out our website at containersfromthecouch.com. Thanks.
Thank you.
All right, welcome everyone. This is the DevX Brain Trust. So I'm getting some background noise from someone, like a fan maybe. Anyone that has a fan on. Is it me? I'm the only one unmuted now. Wow. Okay. Well, we're gonna push forward.
Can you please leave? We need you to leave right now.
Right. Okay. I just want to make sure that everyone gets themselves introduced and that we get this thing off nicely. So I'm gonna hand it over to Matt, and you take it from here.
Awesome. Well, unfortunately, we probably have more than one fan that's whirring right now with the video. But thank you. Thanks for joining us. And thank you for your interest in listening to these wonderful people talk about developer experience. I want to make it clear from the start, though, that we want to make this as relevant and as useful for you as possible. So if you have questions, please post them, and we will make sure that we answer them. Let's have very quick introductions so that people know who they're hearing from. I'll start. Matt AC, I run open source strategy and marketing and developer marketing here at AWS. I'll go in reverse order. Emily, how about you next?
Hi, I'm Emily Freeman. I think about all things DevOps across the entire AWS ecosystem. I come from the advocacy world, so obviously developer experience is my big passion, and I have lots of opinions.
So next, I've been with them years, and experiences organized focus on client-side integrations at ECS.
Hi, there's a little bit like noise coming from you, Ultra. I don't know, but yeah, let's continue with the introductions. Hi, I'm Yana. I'm a principal engineer here. I work on observability, specifically actually for containers. So I'm also coming from a background where I worked on developer tooling and developer experience for a long time, and I think that my current field is just very connected to developer experience as a whole. And I'm so, happy to be here to kind of share that perspective.
Awesome. Thank you. For anyone who doesn't know these fine people, you're lost, but you will now. So I have a question. And I'm going to start with Emily. You're relatively new to AWS.
Very.
You came from another company located in a rainy place called Seattle. And I have a question. So we talk about developer experience. I'd love to know you coming into the company, your impressions prior to joining, and then how have those thoughts on developer experience in AWS changed, or are they still the same a few months in?
Yeah, I think it's evolved slightly. So when I came in, to be honest, I was a little overwhelmed by just the number of services and trying to sort out when to use what. I think you come onto that initial portal, it's like, oh, okay, it's a lot. And so I kind of dove in, and I get the privilege of being able to talk to these service owners and these PMs, and it clarified a lot of things for me in that I've started to look at all the services or complementary services. So I'm thinking, systems manager, CloudWatch, DevOps Guru, the sort of operations side of it. You can kind of conceptualize it as a glass box, and each of those services is sort of a side of that box. You're always going to have visibility into what's in the box, your system, your application, whatever it's watching. But you kind of choose the pane of glass you see it through. And that means that you can choose a service that serves your unique constraints, your situation, your background, your style, your technical opinions. And so I've started to appreciate it. Once you get kind of past that threshold of overwhelm, it becomes a lot smoother of an experience.
Got it. Thank you. And Yana, same question for you. You're also
Yeah,
relatively new.
I was able to, about to say the same, like the overwhelming number of services. So I think AWS is also, in a unique situation because, we have a lot of customers needs, different use cases and so on. And, we just want to be able to serve to all those use cases, which is one of the reasons that, we have many services and there's a lot of complexity because that's the reality of the world in the end of the day. But what I'm trying to say, is just I think building those building blocks is the key, right? Part of developer experience. I mean, a lot of people when they think about developer experience, it's just being maybe super opinionated and having some of these clear happy paths and enabling them. But I think that the reality of the world is much, much more complex. And that's why we have more complexity than those few happy paths. And AWS is doing a really good job, I think, capturing all of that. And I think one of the reasons that I'm trying to work, observability is trying to, surface the maybe a little bit of the internal details of these systems. So you're not kind of completely, interacting with black boxes, but can kind of understand what's going on. I think because the reality of the world is just a bit more complex, we need to do a better job in terms of surfacing the internal details of some of our services instead of trying to just enable a couple of happy paths.
Okay, well, we're going to come back to that complexity. But right now, I want to ask same question to Utra, because we're going to blame you for that complexity because you've been here longer than anyone else, and so it's your fault.
Yeah.
Talk about the design principles that go into something like, I don't know, Copilot or any other service that you're familiar with. How does AWS think about this?
Definitely. I've been here 8.5 years, and I've seen some of the things that you've talked about.
See, Emily, I told you, it's her fault. It's totally her fault.
Yeah. I'll take it. I mean, one thing that we do really is we work backwards from our customers. You hear this time and time again, but I think one thing that through the years we are trying to do more of is we are trying to be the customer ourselves, like try to empathize with the customers, fit ourselves in their shoes, and that's really helping change the developer experience. The other thing that we have shifted to do more is like we're open and transparent about our roadmap and our design choices with our customers. So you asked about Copilot. For those of you who don't know, Copilot is a container CLI that enables you to like build, release, and operate containerized applications on AWS, particularly ECS with Fargate and App Runner that we just talked about. So about 2 years, a year or two ago, when we got started, we knew that a lot of customers were using containers as their packaging solutions for their microservices, which was great. They were looking for something to deploy to AWS. At the same time, like we realized that these different containers needed to like talk to each other through service discovery. They needed like other peripherals like, oh, what do I do for storage in the cloud? I need to independently auto scale them. Like, how does observability work for all of this? And as Emily and Yana mentioned, there's just so many offerings in AWS. Like we needed to, customers needed to really like understand these different AWS services and then stitch them together. And that's when we introduced Copilot, because the user problem that we're going after is that users really think about architecture, less about infrastructure, right? So we started with some higher level abstractions with Copilot. We introduced a getting started experience called Copilot Init, where you get a prompt saying, what type of application pattern are you trying to run? Is it a load balance web service? Is it scheduled job? And so that really speaks to the customer. And we did some user research. We put up our proposal on GitHub, and like we really facilitated feedback. So I would say that it's mostly like working backwards from our customers, that we have introduced so many services, and now we are like getting closer to the customer problem, which is how do I stitch all of them together, and can you like simplify that for us? And that's when we introduced Copilot, and the tool that exists today is really because of the customer feedback we've received over the years.
Okay, I'm going to stick with you for a minute more, although if, actually, I'll stick with you because I have a follow-up question for Yana after, and for Emily. So you talked about happy paths, and Yana talked about something similar, this opinionated, or the ability to dive into complexity. But often we talk about a great developer experience in terms of, I don't know, limiting the amount of complexity that a developer will see. And so we talk about low code or other things, or a Twilio style API or things like this. Again, because you've been here for a while, talking about how AWS thinks about marrying or balancing this complexity on one hand and simplicity on the other. Can you walk us through? You addressed it a little bit before, but maybe go a little deeper.
Yeah, definitely. I would say that there's one tenet that we have in the team, and that's really make the easy easy and make the difficult possible. And I think AWS really embraces that. By that, what I mean is like we want to make sure that the day one experience of getting started is as simple as possible, but the day two operations of like adding I don't know, like, you know, another load balancer or like whatever you want to evolve your application, like is also possible with ease, right? And that comes with what Yana mentioned earlier about building blocks, right? So AWS, when we design something, we really start from thinking about what are the building blocks that can eventually be composed and like, you know, plug and play as what customers want. So that's really the key. The key is like identifying those building blocks. With Copilot, we did something very similar, right? So we just say you can do Copilot Init with just getting started, and you get a load balancer automatically. But if you want to evolve that to like add, let's say a secret, you can just do secret init and then like attach it to your application. But if you have your own custom like templates in Copilot land, we have something called add-ons. So you could just like bring your own CloudFormation with custom resources in there, and you know, add the add-on to Copilot. So really, like Nick at the keynote today mentioned a term at ECS that we use is powerful simplicity, which is you want to keep day one experiences super simple, that's easier to get started. But eventually, as you add more things, you just want to make it as configurable, as simple to like add more building blocks to go towards your powerful needs. So powerful simplicity is what I'll leave you with.
Awesome, thank you. And a follow-up question for Jana. So you are the god of observability. How does you acted kind of surprised, like you didn't know that that's what we call you behind your back.
Okay. I have some pressure on my shoulders now.
No. You're a god, so you don't need to worry about it. How does observability play into that? So Gene Yang, CEO of Akita, talks about complexity enhancing software, and Uttara was just talking about how we try to give an easy or straightforward day one experience and then allow developers to get deeper as they become more comfortable. Observability has a key role to play in this. Can you talk about that and maybe go into like how you see the AWS strategy on this? Like, how do we think about it?
Yeah, like as we, a couple of times mentioned that we are really good in terms of like figuring out what are the building blocks. I came from the programming language. I'll actually give you another analogy because I'm coming from the programming languages world before coming to observability. And in programming languages, there are like two concepts that people often confuse. The first one is simplicity and the other one is being concise. In some languages, you can be very concise, right? Like you can just write 1 or 2 lines of code and get a lot of things done. But simple languages just kind of like really good in terms of like servicing those building blocks and like making people be able to compose them. I see AWS is like this, like, building blocks, composable building blocks type of, environment. So you just can pick and choose. This create, in the end of the day, if you think about everyday services that we have, everyday architectures, there are so many components, like 3 to 4. On top of that, you go and rely on a lot of like different managed services. You have this like huge complexity coming from networking and like your operating system and everything. So like stitching those 4 to 5, fundamental things together is sometimes very, very difficult. I think in the past, we used to see developer experience is just mainly about like developer tooling. It's kind of like was this like, localized independent environment where we used to just use the developer tools and so on. But the reality of today is just like you're operating in this like big chain of different services and dependencies. So you can't really like unlink yourself from that whole chain. And I think observability today, especially like with end-to-end signals like distributed tracing, is just giving you a lot of insights. And you look at your systems not from the perspective of like, hey, I have 1 service or 2 services, whatever. It's just more of like, what is happening in the critical path of my user's request. So it's just kind of like, hey, this is what my user is experiencing, and I want to see and understand what's going on. If there's an issue or like problems, latency, whatever, I just want to see it from the user's perspective and be able to diagnose and so on. Observability is used as a learning tool most of the time. Like companies especially have like distributed tracing. Like they often tell it's just so much easier to onboard people because they come in, see this bird's eye view of what's going on end to end, and they understand their like particular service and like its dependencies and everything. So it's just kind of observability is making the big black boxes a bit more like understandable and kind of like giving you a bit better insight like where you are. Most of the time developers just work on 1 or 2 services, but it gives you in the bigger picture where you are and what are your constraints, limitations, issues are. So it's really a tool to learn about systems.
Emily, I sense
that I might have an opinion.
That you have something to say. It might have been that you put it in the chat room that no one else can see.
I was like, I have an opinion. Let me talk. No, I was just going to say, I think so many aspects of this. I agree so much with what Uttara and Jana had said. I think there's a way of allowing for complexity, but revealing or exposing the minimum amount required to get started. So for me, it's, yes, we have a full iceberg. There's incredible amounts of possibilities underneath the water. You can configure to your heart's content. But there is a happy path. And I think AWS is starting to move in a direction where, I was talking to a service owner the other day, and it's what is the minimum number of clicks required to launch the service? And they were like, I'd have to go check. And I was like, make it 3. As the least possible you can do, having a easy, get started guide, that type of thing, where it's like, this is what we've configured for you, but you have all these other options. And that provides scalability and flexibility. So you don't have this gap. I think a lot of times when you're getting started on something, you just have that really simple idea and it's like, oh, easy peasy, right? It's just a CRUD app. Awesome. And then as you expand and you scale and you get successful, you have to really change. And I would rather have customers be able to expand and scale on our service than have to re-architect, re-platform, rethink. So yeah, I think that's where our advantage is and what I'm excited about.
Yeah, good defaults is really a good thing to have. Like, sometimes you kind of get frustrated because there are no good defaults, and like it's just asking my opinion on 20 different things. So good defaults is the key.
All right, I see some questions coming in, although I also see answers. So I'm going to hold off on that for a second, but I just want to remind people who are watching, if you have questions, please ask them. These are 3 amazing people and 1 sort of mediocre moderator, but like to ask, I'm reasonably good at channeling your questions to them. So please ask them. I have a follow-up question, or not a follow-up question, but a new question for Emily. So in the early days of DevOps, and we've talked a lot about the individual developer experience, but of course developers don't operate in a vacuum. Or in complete isolation. And early DevOps you're the one who, actually, I'm the dummy. You wrote a book, DevOps for Dummies, so it's kind of for me, and I have read it. But let's assume that I'm even dumber than your book.
Stop with this deprecation.
than your book envisioned. So early DevOps more focused on kind of the pre-cloud world, and now teams are distributed. Cloud is becoming the norm, if not already the norm. How do you apply traditional DevOps in this distributed world that we live in?
Yeah, this is the thing I'm thinking about a lot right now. So DevOps was created 2008, 2009. It was an answer to Agile, sort of building on top of Agile, but addressing the conflict that still existed between developers who write the code and operations engineers who traditionally deployed and maintained. And they're the ones who are on call, right? So when things break, they wake up and fix it. And so there was this natural friction because to be a developer, the most successful developers deploy frequently. The biggest threat to stability is a deployment. So it's like you have this natural push and pull. And I think we got better, right? We have I think excelled in understanding the benefits and constraints of different approaches. I think developers have more insight into operations. I think the cloud has helped with that because it's not a server room that they don't have access to. You can actually look at least logs or see how things are configured. But you're right. We live in an entirely different ecosystem. When DevOps was created, AWS was 2 years old, I think. Azure and GCP were just launching. So it's, the cloud is new. Distributed systems are new. Back then, a monolithic architecture is the default. Who cares? Now it's microservices. And more teams are distributed. So how do you make all that work? I think there's a way to inject DevOps into a distributed system and be creative, but I believe DevOps is overdue for a refresh, So I'm really thinking about, okay, how do we rethink this and allow for that complexity? Because our systems are more complex than they ever have before. You cannot conceptualize it from a single point of view. You just can't. You can't hold it all in your head. And so how do you prioritize speed, observability, reliability, all of that in one grouping? So I don't know. I'm really excited about the next few years. I think it's going to be interesting.
Cool. I would be remiss if I didn't mention that we're actually here for Container Day, and we haven't really mentioned much by way of containers. So let's I don't want to make it sound like we're doing a token mention, but Tara, we're here for Container Day, and I see Scott Sanchez and others from our containers teams chatting in the box, and I don't want them to go away disappointed. But we haven't really talked about the role containers play in DevOps that Emily was just talking about. So we know containers solve problems, application conflicts between different environments, but how does a container service like ECS help to bridge the dev and ops worlds? Like how do containers play in there, and specifically AWS services here?
Yeah, good question. And I think we alluded to the fact that customers are moving towards a more distributed architecture. Like each team is like splitting into smaller microservices, and containers are really good tooling for that, right? Like you can have these independent services pre-packaged with your own dependencies and deploy to cloud, but that magnifies like how much like the DevOps impact is. How do you deploy safely? How all of these like are stitched together. And I would say like one answer for that is really infrastructure as code, like repeatability, like so much like every time you package your solution, make sure you have infrastructure as code around it. Make sure you have a pipeline that like gets you through. But at ECS, like, again, it comes down to building blocks, right? Like we have, as a developer, like you can quickly get started with like something called a run task, which is a grouping of containers, or a create service, which is a grouping of tasks. And so as a developer, your view is more around like getting the application microservices up and running. And as an operator, like you get to configure the cluster with a group of container instances that are running. And we have good permission models that like make the developers focus on their service and app, and make the operator focus and like have resource permissions for the environment where these containers are running. So I think coming down to building blocks is really like what it comes down to. So yeah, with ECS, we have those concepts. Another thing that we launched at reInvent last year is called AWS Proton, which actually streamlines like the responsibilities between developers and operators, and that enables operator teams to actually build application patterns for the dev teams to run. We're going to talk about Proton later today at Container Day, so I highly encourage people to check out that talk as well. But yeah, that's really been the answer with ECS, Matt. Like it's really, you have different resources for different personas, and that's how we tackle it.
So I have a follow-up question for Yana, but I see a question that came in, and so I'll ask it. Well, actually, I'll ask two questions of you, Tara. The first is, and I'm going to channel my inner Corey Quinn. How should a customer think about? I'm going to ask a very polite version of Corey Quinn. How should a customer think about ECS versus EKS? Like, how do you decide? The Corey voice would say, and among the other 15 ways to deploy containers at AWS. But for you, I'm just going to say EKS and ECS, and then answer that. And then I have a follow-up question from Volek, the FN dwarf.
Sounds good. I'm going to echo what Corey Quinn has in his newsletter today, but it really depends on customers' app requirements and like their operational preferences, right? So if a customer just loves the flexibility of Kubernetes, like EKS is the answer for them, because EKS manages the control plane, sprinkles it with like AWS security and like operational best practices, and customers get the Kubernetes API that they are used to, right? So if you love Kubernetes, like EKS is the answer. If you're looking for an AWS opinionated solution, like ECS, like offers that powerful simplicity. It really is designed with like seamless integrations with like other AWS services. And you can use like tools like Copilot to like, manage, release, and operate the ECS services on top. So it's really like operational preferences. It's not a binary solution. We have seen like users have both in their larger organization. It's really like you have different ways, and it depends on like what your preferences are.
Can you flip between them? Like if you start on ECS, can you go to EKS?
Yeah, that's a good question. So the root of all of it is a Docker file and a container, right? That's what makes it flexible and portable to whatever solutions you'd want. There's definitely learning curve in like one option versus the other, but the answer is obviously yes. Like containers are powerful for that very reason.
So a very quick follow-up, and I think the answer is similar, but this is from one of our fine listeners. They're struggling to decide between ECS Fargate and introducing Kubernetes. So he says, how do you think about these two different container orchestration systems, pros and cons, and why you might switch from one to the other? Similar, yeah. I think similar sort of question as before.
Yeah, it's definitely like the same answer there. Like I would say like getting started, if you're not familiar with Kubernetes, like getting started with ECS is like really simple. Like it goes from like container or even code in terms of like App Runner. So like if you have just a container that you want to get started with, like Copilot is a really like journey. It takes you through a journey like of getting your application up to containers. So I would highly encourage checking out that source. But if you are familiar with Kubernetes, like EKS is where you should go first, like no questions asked. So I think it's really familiarity. But if you're just starting from a container from scratch, like hit Copilot. It's open source.
Thanks. So a follow-up question, going back a little bit to this question of distributed systems and the difficulty of applying DevOps there, but the same is true of observability. And so, Jan, I'm looking at you on this one. As production environments become more ephemeral and distributed, how does observability play into making developers more productive in these distributed systems?
Yeah, like,
teams?
Just kind of like, recap like what I've been talking about, like observability is really a tool to learn how the systems behave nowadays. Like we sometimes, talk about observability in the context of like, our operational excellence, or like, being able to, troubleshoot outages, but people start to rely on telemetry data in order to understand the basic principles and the coordination and like what's going on all over the all across the system. It's kind of like providing you this bird's eye view. In my previous job, when I joined a very large team, which had like 200 dependencies, other services, and so on. And on my first day, I just was like, hey, there's a bug. I'll take this as a challenge. This is a very, complicated, project, but I'll try to kind of go and dig in. My mentor immediately showed me like the distributed, the tracing tool. So it took me like 2 minutes to figure out where the bug was, and I was able to patch it and like just kind of test it, by looking at the distributed tracing tool when I was running things locally and so on. So it just kind of like made my entire experience of building, figuring out something, building and deploying. Like, I mean, it would take probably like a couple of days otherwise, but with the right tools, with observability data, it took me a couple of hours instead. So, people see this as kind of like a way to, hey, there's this complex or non-complex. I mean, everything is complex. We talked a lot about complexity, but it's just not like, it's the reality of the world. Like there's nothing that is not complex. It's just kind of making you be able to see what's going on, and, just contributing to your productivity, because you can, take decisions and take actions much, much faster. And, I think it's production excellence is one of the areas we usually try to affiliate observability with, but I think it's just kind of like a very strong tool in the development environment as well, and it's not like being utilized as much as it should. So I'm like kind of like really, I think, passionate about like making it more of like an everyday developer tool to be able to take a look at this type of data and to be able to utilize it.
Okay, and coming back again, a follow-up question for you, Yana. I asked you before about AWS's strategy around observability and how it plays into this this question of developer experience. But I'm going to ask you to indulge my open source fetish for a second. So there are a lot of ways, similar to what we just talked about with containers. There are different ways that you can manage containers at AWS. We seem to have chosen with observability to take an open source path where we're contributing and using OpenTelemetry, Prometheus, and other tools. Why open source here? Like why didn't we just build proprietary observability tools and be done with it?
Yeah, one of the main reasons is like people really don't want us to have a lot of opinions about the tools that they're going to use. Like telemetry data is such a core thing, and they want to be able to generate. They want us to be able to generate some vendor agnostic, product agnostic data, so they can take it to any other tool that they already use, or they can store it, and process it, as raw data. So it's just very, very critical for us to, be able to produce vendor agnostic data that they can just reutilize again and again and repurpose. The other thing is a lot of companies, like when you think about their observability strategy, they need to like invest sometimes like 3 to 4 years, like, especially if the company is large, it takes a very long time. So they don't really want to invest themselves into, a specific tool, because that specific tool may not be able to, meet their requirements in the long term. What they want to just, their goal is, I want to be able to, produce well-defined data. I want to be able to repurpose it if I want to. I want to build my, pipelines if I want to. That's why we decided to go with like, open standards and open source projects.
Okay. I see some questions that have come in, but again, the moderators are answering the questions faster than I can read them almost. So I'm going to leave it for a second. I'm going to ask a follow-up for Emily. So we've been talking about containers. We've been talking about observability and how they play into the developer experience. Again, you wrote the book DevOps for Dummies.
You can buy it at Amazon.
Yes, you can, and I have.
You've mentioned it 4 times. I might as well.
As you're listening to us talk about this, are we in dummy land anymore? Like, has it become too complicated? Can a newbie get into this, or is this just too hard?
Oh, no way. So my opinion is we should always stay in dummy land. I call it IaaS, idiot as a service. And I think it's really, important to ask the dumb questions. And I put this onus on the most senior, principal, staff engineers of any kind of team or company. It is really important to establish baselines. And that comes down to defining things, right? We throw around terms all the time. Even, we've talked about observability, and that word lends itself to a little bit more like, okay, we're observing something. But when you get into things like AI ops, ML ops, data ops, DevSecOps, what is the difference? And I think when you just really state that explicitly, you avoid the situation where you start a conversation, you automatically miss each other. And that's sort of solving for the human issue of it. But no, I think, making sure that everyone's on the same page, that we, build the foundation of that, and be open to new people coming into the industry. Like, I remember being a junior engineer. I remember before that not knowing anything. Like, I didn't grow up playing video games and building compilers in my mom's basement. Like, that didn't happen for me. So I showed up and I had to learn everything. And I really depended on people who were willing to take the time to invest in me. And so, yeah, I don't think that this is there are certainly barriers to entry. Harkening back to what Yana said earlier about different languages, there are languages that reduce simplicity through concise, right? When I looked at Go for the first time, I was like, C, a variable named C. What is C? I don't understand. Rails is like, this is the thing, this is what it returns. And so, I think, I'm a big fan of dummy land and staying there and making sure that this is an industry where everyone is welcome.
Awesome. First of all, I saw somebody said they're looking forward to returning to Vegas. I kind of wonder about them. Like, I don't ever get excited about going to Vegas, but someone else asked questions that look like they're for Yana. Vision beyond the current observability tool chain, something like GPT-3, kind of telling you what's broken. Is that something you can comment on? And another question related to kind of roadmap updates for X-ray and OpenTelemetry compatibility.
Yeah, I can talk. So I'm not sure if the question is more about providing out of the box, data. That's like our top priority right now. Like if you take a look at AWS, we are launching a lot of new services every year. So one of the biggest, I think, critical things is we don't provide a lot of out of the box telemetry data. We have metrics through CloudWatch. But we want to be able to, just kind of participate in the distributed trace, be able to, provide some internal spans from all these different services and so on in the long term. So that's definitely one of the goals. The other thing is just we are not very context aware in terms of the telemetry data we collect. I, as a developer, don't have a lot of understanding of what's going on, and I produce all this telemetry data that I need to navigate and narrow down and figure out when there's something is wrong. Think about the cases where, hey, I have this log, but is there a distributed trace, or is there any metrics that I collected at that particular point? There's no answers to that type of question. So we want to kind of make correlations better in terms of the data we are collecting, and be able to provide more metadata in the data that we are collecting, so you can just narrow down things much faster, see things end to end, and get enough data out of the box. So those are the top three things, and I think that's what the question was about. The other question about X-ray compatibility. So X-ray wants to move to OpenTelemetry in terms of SDKs. We want to use we're kind of actually already supporting certain languages. And we want to be able to deprecate X-rays, SDKs, and switch to OpenTelemetry in the long term. The other difficulty we have is right now is before OpenTelemetry or other projects, there's been a couple of different, distributed tracing headers, and X-ray has a proprietary header as well. So we have some initiatives to kind of accept other headers. So that's also coming up. Maybe the question was related to those type of headers, but we will probably have better compatibility in a year or so. So regardless of where you started your distributed trace, if you're using W3C trace context header or B3, you will be able to participate into that with X-ray and be able to send those traces to X-ray.
Perfect, thank you. And we have about 2 minutes left before Massimo, who, by the way, is the only Italian on the planet who likes pineapple on his pizza. So whatever he may say about Kubernetes or about containers,
we can just ignore, right?
Exactly. Anything that he says, you should just ignore. You can skip his session. No, I'm just kidding. He's fantastic. But let me ask this, and no one got a prompt on this, but so in 30 seconds or less, and I will time you. What do you think? Look out, not 5 years, but say a year or 2 years out. What's going to have the biggest impact on developer experience, on improving the developer experience? And if you want to put it in the AWS context of what will AWS do in the next year or two to most improve the developer experience? Utara, go. 30 seconds or less.
Feedback. So let us know your feedback. But with AWS, I think the direction we're going towards is getting you closer to the code, because we want you to have an idea and take it to execution, right? A lot of startups are coming up, and we want to be able to help you like do those weekend projects and like actually get rolling. So we are going towards like more patterns, more like closer to the code as much as possible. So that's where I see at least the next 2 years us trending. And so if you have feedback on the container, I want to finish by saying containers roadmap is public. So if you have feedback, please let us know there.
Awesome. Thanks, Utara. Emily.
I yield.
Yana.
Good defaults, easier composability, observability is the 3 things that I think we will be working on.
Okay.
I was muted. Sorry.
Emily, you were muted, so that's why I
Emily?
switched. That's why I switched you off. So Emily, next.
Classic 2021. No, I think we've gone through an incredibly hard year, and I think we deserve some time to ramp up and get back into the groove of things. I think this impacted us way more than we even realized. So I'm excited to see productivity and creativity just sort of skyrocket.
Awesome. And now we're at an end. Thank you so much. Fantastic panel. And we're going to give it up for Massimo, who goes to Olive Garden. He's Italian, but he goes to Olive Garden and has pineapple on his pizza.
They have
You don't have to listen to anything he says.
I know this is how you lose friends. Okay, Matt, I'm just saying. I've asked Massimo about Olive Garden and he gets very hated. Y'all are amazing. That was so good. Thank you so much. As Matt was saying, up next, we're going to have Massimo talking about choosing your Amazon ECS data plane. Every talk Massimo gives is always super enlightening. So stick with us. We're going to take a quick break and we'll be back after these messages.
I like to wake up early in the morning because I do my best thinking. It is super important that we have diversity in our business. I meet with my interns daily, and it is important to us that they are more than technically strong. We need them to be people strong as well. The key is actually predicting what a customer is going to need and then work backward from there. True joy to work with passionate people. You can see people multiplying each other's productivity. Around 2 or 3 o'clock, we'll often go to the deck and have a bowl of ice cream. I'm Ridley Huang. I'm a principal software engineer at AWS.
Skyscanner is a global travel search company. We have over 100 million users a month relying on us to find their travel needs.
Customers cannot accept that our site is offline for anything more than a few seconds. So it's super critical that we are available all the time. And this was one of the main driving forces for moving to AWS. We were always playing catch up. The data centers were getting close to capacity constantly, and we were constantly having to add new hardware and play catch up with our ever increasing growth.
Skyscanner engaged with AWS from day one. We got support from our account team, the solution architects, and they provide us with some great support to kickstart our migration. This wasn't a basic lift and shift. We spent 3 years doing re-architecting, and then the last year doing lift and shift and re-platforming.
At Skyscanner, our container environment is spread across Amazon ECS and Kubernetes. We have over 700 services deployed onto these clusters, and on any given day, we'll be running sort of 8,000 to 9,000 different tasks and pods on the clusters. There's some really innovative services that are available on AWS, and they certainly help Skyscanner to power their business.
Skyscanner initially used on-demand instances. We quickly moved to reserved instances for 70% of our workload, but then to drive down costs further, we use Spot. Skyscanner's entire online platform uses Amazon EC2 Spot instances. Amazon EC2 Spot instances saved us 70% per core and also provided us the flexibility to move our workloads globally.
Kubernetes as a Spot is a great fit, especially if you're running stateless microservices. The fact that the scheduler is designed inside of Kubernetes to move instances of services about, you can deal with the issues that you have with capacity. Using a traditional data center, it used to take us 6 to 7 weeks to launch a new service. On AWS, it can take us 15 minutes. We have thousands of services running in AWS versus a few hundred in data center, and that means more products and new features for travelers.
Migrating to AWS has enabled Skyscanner to focus on innovating for the traveler rather than managing IT infrastructure.
Okay, and so now we have Massimo, this is your chance to defend yourself against all the Olive Garden accusations and the pineapple pizza.
I would need half of this time to go through all the inaccuracies that has been discussed in the last session, but I'm going to take the high road here.
All right. So Massimo, why don't you go ahead and take over, and I'll jump off.
Okay, cool. Thank you very much. Thanks everyone for joining this session. In these next 30 minutes or so, we're going to discuss ECS data plane options. Let's get started. So some naming convention as we go through this session. So control plane and data plane, many of you may be familiar with this, but just as a way of introduction, any container system orchestrator has this notion of a control plane and a data plane. Think of the data plane as the endpoint that you talk to say, can you please run a container for me, right? For example, an ECS task, which includes a container. The data plane is where actually that container gets spins up. So basically the control plane will talk to the data plane and it will tell the data plane, bring up this container that this user has asked me to spin up. Okay, some example of these are, of course, Amazon ECS for the control plane. So Amazon ECS is a container orchestrator control plane. Data plane, we are going to explode in more details about what this means, but think about Amazon EC2 and Fargate. As I said, this session is going to focus on the data plane aspect of this. Up until a few years ago, the data plane was not really like a topic for discussion, right? In the sense that when you were to deploy a container or a task from ECS, you usually use an EC2 cluster or a cluster comprised of EC2 container instances. So no big deal. It's kind of standard way to deploy container. Fast forward to 2021, the innovation in the data plane is blooming, as I have here on this slide. Some of you may talk about the complexity of the data plane. I like to say and talk about the richness of the data plane. In the last few days, we have been talking and joking about these 17 ways to deploy containers on AWS, and we typically refer to the control plane, your entry point. Which service do you use to deploy your containers? As we go through the options of the data plane for ECS, you will see this richness blooming even farther. So at the very top of this slide, there is Amazon ECS, the control plane that we're going to focus on. At the bottom, we're going to fill that big rectangle with all the options that you have when you think about where and how do I want to deploy my container. In order to make this a little bit easier to grok and easier to understand, you need to think about these as different dimensions that you can pick from, right? We're going to dive a little bit deeper on each of these dimensions, but think about dimensions being like, for example, the purchase options, the type of extensions, the location, the operating system that you want to use, the CPU architecture, but more important, the technology, and we're going to talk about these in a second. So this is what we're going to talk about in this session. We're going to try to make sense of the richness, I like to say richness and not complexity, that you see in this slide. And we're going to start with the technology, right? Think about these as different dimensions where the index of this dimension is the technology. The technology is going to be, what determines what you can do and what you cannot do. As you have heard at the beginning of this day, container day, we reminded people that we are releasing ECS Anywhere. We are making ECS Anywhere available in preview for you to play. So this has expanded. It's particularly the technology piece has expanded because now we have an additional option to run your container. And this obviously has some ramifications into some of the other dimensions. like the purchase option, for example, now you can bring your own hardware. So as I said, the technology is the very important piece here, and what it is going to drive the options that you have. So we will start talking about this technology piece, right? And we're going to focus more on these options in this dimension, which is the technology. We're not going to talk about EC2 because we assume that it's kind of the standard way to deploy containers, and specifically ECS containers on ECS using an EC2 cluster. So we're not going to talk about this option. We're going to focus more on the Fargate option and the Anywhere option. Let's start with Fargate first. When I talk about Fargate, I like to talk about Fargate in the context of how this maps into the shared responsibility model that we have on the AWS cloud. This slide shows a rectangle with a number of services on it, with a demarcation line that demarcates our responsibility on the part underneath that line, and your responsibility, the part that is above that line. Basically, the idea here is that when you come to AWS, you pick your abstraction, right? Some customers want to pick the EC2 abstraction, the virtual machine abstraction. Some customers want to pick the container abstraction that you see in the middle. Some other customers want to pick a serverless or function as a service abstraction, and they typically pick Lambda. The key thing here is that when you pick an abstraction, you're basically telling AWS, manage everything that is underneath that abstraction. Let's take Lambda, for example. We all know that there are servers in Lambda, right? As the people joke about this, we all know that there are servers in Lambda. The key point about serverless, Lambda serverless, is that you don't have to deal with those servers. We don't actually have to deal with any of the Lambda orchestration that happens underneath that line. You just bring your code and we run your code, as easy as it is. So we basically abstract everything that is underneath. Similar thing for EC2. When you pick EC2 or a virtual machine abstraction, we're not asking you to manage a bunch of physical machines for you to start a virtual machine, right? However, think about the container abstraction. In the container abstraction, that line is not really honored, because up until before Fargate, what happened is that the real line is like this. In order to be able to run a container on ECS, for example, you have to own the EC2 abstraction. You have to have a cluster of EC2 instances that allows you to provide capacity to run that container. I like to think about Fargate as that compute engine that fixes that leaking. Basically, Fargate reestablished that line and says, if you pick the container abstraction, if you come to AWS and you pick the container abstraction, we're going to manage the part underneath it. Let's switch to ECS Anywhere. Nathan has already talked about this. Deepak has already talked about this. But as a recap, let's talk about ECS Anywhere. When we introduced ECS back in 2015, I think it was 6 years ago, this was the option for deploying containers on ECS, using ECS as your container orchestrator. Basically, you could deploy ECS containers inside the region on EC2 virtual machine across availability zones and the usual regional construct. If you think about how we evolved these over time, I'm not going to spend a huge amount of time talking about new services that we released throughout the years, but AWS Wavelength, AWS Local Zones, these are all AWS managed infrastructure whose goal is to come closer and closer to the customer from a latency perspective, for example. We have also released a way to deploy containers, ECS containers, inside your data center with AWS Outpost. AWS Outpost is AWS managed infrastructure that we build, and instead of shipping it into an availability zone, we ship it into your data center. But this is still AWS managed infrastructure. Lots of customers have been very vocal in saying, I do want to run ECS containers in my data center, but I do have other needs, like I have capacity that I need to reuse, or I have policies or constraints for which I need to run that infrastructure. That is where ECS Anywhere comes in. With ECS Anywhere, you can run the very same task inside your data center on what we refer to as customer managed infrastructure. And Nathan has shown you already what these look like. One thing that it is important to understand about ECS Anywhere, and one of the peculiarity of ECS Anywhere, is that we took a very radically different approach to provide that capability to customers that want to run containers on-prem. Traditionally, regardless of the container orchestrator that you take, usually the deployment looks like this. When you deploy in the AWS infrastructure, the control plane is in the AWS infrastructure and the data plane is in the AWS infrastructure. If you want to deploy in the data center, you replicate that setup. So you bring both the control plane and the data plane in your data center. This obviously has a lot of advantages in terms of, for example, being able to work completely disconnected, stuff like that. But it increases a little bit the complexity of the setup, because now you have to manage the control plane in your data center. ECS Anywhere took a very radically different approach, as I said. Now with ECS Anywhere, you can run ECS tasks and services in your data center without having to have an infrastructure, a control plane that you need to manage. The control plane with ECS Anywhere runs in the cloud. As I said, we made available ECS Anywhere for you to play with it today. And this is the demo that we did at reInvent in December. At the bottom of this slide, you will see a GitHub repo that you can point to that will allow you to replicate that demo and test this out in your own data center. The other thing that I use this slide for, but Nathan has already covered this, so I'm just going to mention it very quickly, is that lots of customers are asking us, where do you run ECS Anywhere? What type of devices can you use to run ECS Anywhere? Well, at reInvent, we demonstrated, and Nathan has already demonstrated, that you could use, Raspberry Pis to run your ECS task, all the way to bare metal server or VMs or whatever you need. What we care about is the operating system that is running on this device, on these devices. So now that we got the technology out of the way, so the index of the choice that you need to make, EC2 in the region or on AWS managed infrastructure, ECS Anywhere for outside of the AWS managed infrastructure domain, or Fargate if you want to run in the region, but you want AWS to own everything for you, the operation of the infrastructure for you. Let's go very quickly in the remaining of the time through all of the options that you have for these dimensions. So why is it rich, and why are customers asking us to have even more richness here? Because basically you can tune what you deploy on those technologies that we have discussed based on different dimensions. Let's take the purchase option, for example. When you deploy your AWS, ECS containers or ECS task on one of those options that we discussed, you have the ability to different type of purchases, right? Bring your own hardware is obvious, right? We just covered this with Amazon ECS Anywhere. Saving plan, on demand, and spot are all options that you have when you deploy your task, typically inside the region. On demand is the typical way. You pay for what you use, nothing more. Saving plans allows you to say, I'm going to commit to a certain amount of capacity that I'm going to use, and I'm going to get a discount for that because I'm going to commit to pay a certain amount of money at least to be able to use that capacity. Spot is another interesting mechanism that allows you to get access to even more discounts if you agree with a quote-to-quote contract that we have, in the sense that we can give you spare capacity for a very low price, up to 70+% discount. But the contract says that if we need that capacity because we have other customers asking for example, on-demand capacity, we're going to reclaim that capacity, right? We're going to signal, and in a few minutes, we will remove that capacity from you. This is great for workloads that do not need like to be serving like online transaction or stuff like that. You compromise availability if you can deal with that for getting access to very low prices. Extension is another interesting thing. Think about extensions as a way to be able to configure your infrastructure to be able to do certain things. Like, for example, configuring logs, right? Or attaching to data sets or to storage, to volumes. You want to deploy your containers and you want to be able to connect to, say, EFS. In order to be able to do this, any container orchestrator has a bunch of different technologies and mechanisms that allows you to create this extension on the cluster that you're deploying to. So these varies, daemon sets are pieces of extension that need to run on each node. Sidecars is another extension that you would couple with the container that you are deploying. Sidecars is interesting because this additional piece of extension that you need to have to ship log, to connect to storage, is hidden from you, right? So instead of you as an administrator to be able to say, I want to deploy this driver to be able to connect to EFS, we ship this for you. We manage this for you. That's why it's sidecar and not a sidecar in that case. Location is another interesting dimension. Not going to spend too much time on this because we have already touched upon these when we discuss about ECS Anywhere. But as a reminder, you may need, because of the use case that you need to deal with or because of other reasons, to choose between deploying in AWS region, in a local zone, in a wavelength capacity, or inside your data center. And inside your data center may mean either Outpost, if you want AWS to manage your infrastructure, or it could be ECS Anywhere if you want to use your own infrastructure. The other important dimension that people that are using ECS usually need to look into, and where lots of people are asking us for more flexibility, is the operating system. As you know, containers are not a virtualization technology like virtual machines. So it's not like you can run a Windows container on top of a Linux VM, for example, or a Linux environment. So choosing the operating system in your data plane is very key, depending on the workload that you need to run. There are still lots of Windows shops out there that are containerizing their Windows application, and they need to use Windows to be able to run their application in the data plane. There are lots of other customers. I would argue the majority of the customers that want to use and need to use a general purpose Linux to be able to run their Linux containers. This could be Amazon Linux too, but it could also be Linux from our partners like Red Hat or Canonical, for example, for Ubuntu. Customers has also the option of using a brand new, brand new, so to speak, relatively new, I would say, operating system that we built called BottleRocket, that we open source, that has been purposely built to run containers. So this is the difference between general purpose Linux and BottleRocket. BottleRocket is specifically built to run containers. You do not run generic Linux application on top of BottleRocket. CPU architecture is another interesting thing that is happening right now. Usually, customers are running their containers, either Windows or Linux, on standard x86 CPUs. That is where we see the majority of the containers that we run being deployed to on the data plane. But there is a growing demand for GPU instances, for example. Not only that, one of the things that is growing very strong is demand for Graviton processors or ARM-based instances. Graviton is our own ARM-based CPUs that we build and we make available with a number of compute options, namely EC2, as of today, that allows you to optimize for performance and price. Obviously, there is a compromise when when you configure Graviton, that you need to recompile your software to run on an ARM-based system, or if you're using off-the-shelf software, you need to make sure that your software can run on a Graviton or ARM-based CPU. If it does, or if you can recompile your application, there are customers that are showing huge amount of savings by switching from x86 onto Graviton type of CPUs because of higher performance and lower price for that capacity. Now, this is where it starts to get interesting, because we have laid out the technology options that we have, right? So either EC2 or Fargate or ECS Anywhere. And then we moved on to discussing the other dimension that you see on this slide, right? The purchase option, location, operating system. Now, the key thing to understand here, and where it gets interesting, is which of these dimensions or which of these options per each dimension is available for the technology that we have discussed. And that is how we start making compromises, or that is how you start making decisions on which technology you want to use to deploy your application. For example, let's say that you want to use Windows instances because you have Windows containers that you need to run on your data plane, or you need to get access to ARM-based CPUs or Graviton-based CPUs. EC2 is the best option in this case, or for example, GPU instances is another good example, because if you use the EC2 technology, so you're limited to deploy in a region or in one of the AWS managed infrastructure that we discussed so far, you get access to all of these options. Also, from a purchase perspective, you get access to spot, on-demand, saving plans, very flexible, very rich experience if you choose EC2. Now, let's say that you want to choose Fargate because you like the fact that we take ownership for running the infrastructure on your behalf. So you do not have EC2 instances in your account. You don't have to scale your cluster, scale out, scale in, adding new instances, removing existing instances, for example. You don't have to deal with the fact that your cluster is underutilized, so you end up paying more, for example. If you choose to use Fargate as the technology, you need to work within the boundaries that Fargate allows you to do or to work with. For example, one of the examples that we usually use is that as of today, we do not allow you to use GPUs in Fargate, or we do not have the ability to provide Windows instances for Fargate. So if you have Windows containers, you cannot use Fargate. Now, obviously, the fact that we missed this option in Fargate is one of the reasons for which customers are telling us we need GPUs in Fargate, we need Windows in Fargate. And these are all roadmap items that we're working on. But it is important that you understand that based on the framework that we discussed so far, you need to make sure that the technology that you choose is able to deliver for what you need or for what you want to compromise on or optimize on. Let's go through the last one, anywhere. Obviously here, the options that you have are even more reduced, right? Because with anywhere, you can basically support only Linux. It can only run inside your data center. It doesn't really make sense to run inside the region with ECS anywhere. There is no sidecar, for example, right? Because you have to manage those extensions because unlike with Fargate, where we manage that part of the infrastructure so that we can use those sidecars to manage those extensions for you, here you have to manage those on your own. Also, the purchase option at the very top of this framework, there isn't much that you can do in terms of spot or saving plans because that's your hardware, right? So you're bringing your hardware onto the table to be able to run this. So in conclusion, as we tail down here a little bit, we have explored the data plane options that go beyond the usual, I need a cluster of EC2 virtual machines. And basically what this means is that it allows you as a user to put a little bit more effort into basically what you need to pick and choose. So going back to that joke about the 17 ways to run containers on AWS, it gives you a lot more options, but it forces you to pick those options. And the good thing about this is that you can pick based on the compromises that you want to make, right? I want to compromise on availability because I care a lot about pricing. Maybe you want to pick a spot and you want to deploy in the region to be able to leverage that option. The key thing here is basically that you can pick the data plane option that best suits your requirements. What option do you need? That is what we want to hear. So all the combinations that you have seen, we want to hear, I want to use anywhere, but I want that option. I want to use Fargate, but I want to be able to use a Graviton processor, for example. That is what we need to hear to be able to adapt our roadmap to provide what you need to satisfy your use cases. With that being said, thank you very much. I'm not sure if Adam is still around. Is there any question from the chat? I've been pretty head down going through the slide. I'm not even sure what time is it.
You did an amazing job, Massimo. You're like right on time. It's like you practiced this.
I was looking for the time somewhere. I couldn't find it. So
I put it in the one place you didn't look in our private chat.
It's okay.
Definitely, I didn't.
So there were quite a few, a lot of conversation. There was one question just about choosing the AMI and what's the difference between Bottle Rocket and just an ECS optimized AMI. I answered that question in chat, but I mean, I guess if there's anything you want to add to that, Massimo, and then we can wrap.
I didn't know what you said, but one of the key points about Bottle Rocket is the way that we manage updates, right? So it's these on-off kind of thing that you upgrade the operating system using techniques that are a little bit more, I would say, advanced compared to how you would update an AMI on an EC2 instance. What did you say?
I think I think the container customer is going to especially appreciate that because one of the things we love about containers is that we get to treat them as an artifact, a single artifact, and you're going from this version with whatever hash to that version with whatever hash, and those are whole units. And BottleRocket is the same. Like when you upgrade, you aren't patching one library and then later you might be patching a different binary. No, you're taking an entire artifact that is a version of the operating system and replacing it with another artifact that is another version of the operating system. And if things go wrong and you have to go backwards, you can go backwards without having to figure out which RPMs that you need to unroll or which debs you need to uninstall.
That's exactly the on-off thing that I was referring to. The other thing that I would add is that BottleRocket has a much smaller footprint than a traditional general purpose Linux. So for security conscious customers, and every customer should be security conscious to start with, they appreciate the fact that with the smaller footprint comes less options to do, damages, so to speak, or to receive damages. Or
yes, and it's a container-based, focused operating system, right? This operating system was built to run containers. So,
exactly.
On that note, we're going to jump to a break. Massimo, as always, you're amazing. Thank you so much. Up next, we're going to have some of our AWS heroes, and we're going to have a panel, and we're just going to chat with them. And if you think we're opinionated, wait till you hear from them. They're amazing. So we'll be back in just a couple moments.
Thank you. Bye.
I am a technical person, so we drink tons and tons and tons of coffee. I act as a liaison between my technical team and my business partners to help drive the team to deliver results. I was a little STEM girl. I've always been nerdy. I just want to see more women and more women of all colors enter the industry. I try to end the day at the same time every day. I'm Lynn Lucas. I'm a senior technical program manager at AWS.
From achieving your business goals to advancing your career, building your cloud skills can make every day a new opportunity for success. That's where AWS Virtual Classroom Training can help.
Highly available environment.
We bring live online classes to you so you can keep up with the pace of innovation and learn in-demand AWS cloud skills wherever you are. Engage with peers and AWS accredited instructors.
We'll have traffic coming into our private subnet.
Gain insights as complex topics are broken down in real time through hands-on labs, demonstrations, whiteboarding, and presentations. Get your questions answered and learn best practices that can be used right away. Every AWS training classroom course is offered virtually. Choose a public class delivered by AWS or an APN training partner that's convenient for you. Or schedule a private engagement with a dedicated AWS instructor to develop your team.
Thank you very much.
Go from learning to doing and keep on innovating with virtual classroom training straight from the source. AWS.
Hi, my name is Dakota, and I'm a solutions architect covering the Central Midwest territory. Towards the end of my enlistment as a cryptologic linguist in the Marine Corps, I was connected to an AWS recruiter who suggested the TechU program. It was a great fit for me because of my lifelong interest in tech, and actually since graduating from TechU last September, I've been working with customers in delivering results in the form of well-architected reviews, immersion days, and workshops. The most impactful thing that I've had a chance to be a part of to date would be the Fred Hutch Hackathons, where I was part of a team helping to find innovative ways to process data and develop applications to help make the lives of those dealing with cancer easier and will ultimately contribute to the annihilation of cancer.
Whoa, look at this crew. All right, welcome everyone. So I don't know, we're trucking along now. This has been a great session so far. Adam, I'm going to start with you. What have we seen so far that we like? And then after that, let's introduce the rest of the gang.
Absolutely. So first and foremost, I think the kind of exciting thing we talked about was ECS Anywhere. And so ECS Anywhere was announced in public preview today. So ECS Anywhere is a way to deploy your ECS tasks in the data center. You're not managing an orchestrator. You're not managing all the complexities that go with all of that. You just can run your containers in the data center with ECS Anywhere. So super exciting. Any questions you have, we have moderators in the chat. We have the product managers there. They want to talk to you about it. But also, I think, we'd love to see a poll of people in the chat. Just how are you feeling on ECS Anywhere? What are going to be your use cases? Give us an idea of what you're looking to do with it. We'd love to hear that from you. So that was what I was excited about, Brent. What about you?
100%. Yeah, I want to hear from Twitch and our YouTube chat. Sound off. Let us know. Do you think ECS Anywhere is something that you plan to use? And then what do you think you're going to do with it? What kind of work are you going to be running on it? So we have some new guests. Welcome, everyone. Let's real quick, let's run left to right and introduce yourselves. Let's start with Mike.
Hi, I'm Mike Fiedler, at Mike Fiedler. Glad to be here. I'm an AWS Container Hero, which is we're here to talk about containers on Container Day. I'm out of New York City, and I'm really happy to share this time with you all today.
Cool. Casey?
How's it going? Casey Lee. I am on the other coast. I'm in Northern California, a town called Folsom, the same Folsom that Johnny Cash made famous. Container hero as well, and looking forward to talk about all the exciting stuff that's going on with containers at AWS.
Cool. And Philip?
Hi, I'm Philip Garbe. I'm from Germany, from Munich area, Bavaria. And I'm also a container hero. I'm looking forward to the show now.
Nice.
So Brent, do you think we should first just let's talk about what heroes are and kind of how that works, Good
idea.
So we have this AWS Heroes program. This is a way for, just people who are close to the AWS community, who are out there talking about how to run services on AWS, how to run your applications, how to do things, in the AWS native way. But they're here to just talk about all things AWS and their experiences. And frankly, these folks are the experts that are in the field doing this day to day, right? Brett and I just talk a lot, but
sometimes too much. Yes. But you're all customers, and that's what's so great about it. People, Utra referred to it earlier. We love getting feedback from customers, and heroes are customers, and they're never shy about giving us feedback. So, in fact, Casey, I think, weren't you in on the beta for ECS Anywhere?
I was. We've been using ECS Anywhere for some test workloads, and been a great experience. I would love to show a little bit more about what we've been doing there. But yeah, it's been a great experience. We had a specific problem we're trying to solve. Maybe that'd be cool to talk about the problem.
Yeah.
So we have a lot of our workloads running in AWS on ECS, ECS EC2, and works great for us. But we also have a data center, and we have workloads also running in that data center. And the deployment model, the model in which we run these applications is very different, right? So containerizing an app and deploying, we use CDK for packaging and deploying our apps, code pipeline. That model works great in region, but in the data center, it's very different. We're looking at building RPMs and using tools like Ansible for deploying on hosts. So the problem we were trying to solve was, let's come up with a standard mechanism for deploying. And we started looking down the code deploy path, but code deploy on-prem. But with the opportunity to try out ECS Anywhere, it provides the ability to define the container once. We can use the same tooling, CDK and CloudFormation and code pipeline for orchestrating, and deploy those containers into our data center, just like we would in region.
That's really cool. And you've been doing it, and that's, more than most of us can say. So that's really cool.
I have some stuff I could share if you wanted to see.
Share your screen. Yeah,
Please
that's great.
do.
Show us the goodies.
That one highlight of using the same tooling, like that's another huge thing, right? You're using the same tool to deploy to the cloud and to your data center. That's really neat.
Yep.
All right.
As Casey's pulling that up, I think like to pile on to Adam's point, the ability to traverse, like that's been one of those big questions of how do you modernize your data center? How do you lift and shift? How do you move? And being able to bridge the gap with the same tools between environments, I think is just going to differentiate it for a lot of people.
Absolutely.
For sure. It looks like your monitor is pretty wide, so you're probably going to have to zoom in.
Okay. Let's see how this works. Let me just try with this one picture first, if I could. Oh, I'm zooming the wrong way. So this is just a quick view of what it is that we got going. So we've got our data center, we've got this host in the data center, and what's really cool about the way this works is you're using SSM, the SSM agent, to handle the registration of that host with the control plane in region. And so that agent also not only does it take care of registering the host, but it takes care of credentials. And that was one thing that is always painful with these hybrid environments is when you have to create an IAM user. That never feels right, creating an IAM user and using the access key and secret key in your data center. So in this case, what happens is the SSM agent is grabbing a temporary credential from as it's assuming a role, and it's using temporary creds and managing the temporary creds for you on your host in your data center.
And Casey, can you zoom in a little bit more? We got the audience is asking for a little more zoomage. Thank you.
For sure. Yeah, that's going.
Technical term.
Right.
Zoomage. Cool. So once you've got the agent hooked up, then you're just using Docker at that point. The Amazon ECS agent that you'd normally run in EC2 is now running on your host. It connects up to the ECS cluster. And then it's also sending telemetry data to CloudWatch. CloudWatch logs and metrics are available to you at that point.
And Casey, in this example that you're showing us, you have a Lambda function calling an application load balancer, but there's nothing saying that it couldn't be user-facing traffic either, right?
That's right. Yeah. Whoa. Yes. In our case, we were using a Lambda to talk to a load balancer over the direct connect back in.
Nice.
Now, what I wanted to show real quick is if I could just, how's that coming through? These are just a quick overview of what your steps would look like to get your host set up. So you create your cluster like normal, no real change there. You need to create a role. This is the role that the host will now be able to assume through that SSM agent. You can attach some policies. So in this case, we needed the SSM managed instance policy and the ECS container service for EC2. Both of those policies get attached to the role. And then here's where it gets a little different. So you've got this command. I wasn't familiar with this, but you create an activation using SSM. And when you create the activation, you get back an activation ID and an activation code. And these are only good for a short amount of time, and they're only good for one registration. So you generate these per host that you want to register. Then you take the activation ID and the activation code, and there's an install script that AWS makes available for you in a bucket that they manage. So we curl down the script, we make the script executable, and then run the script passing in the activation ID and code in the cluster that we want to hook up to. And once you're done with that, your host in your data center is now registered up with a cluster that's in region. And so if we were to just take a quick peek here. So this is, I'm secure shelled into that host. I can now run Docker PS, and I see that I've got this ECS agent running on my host here. And if we were to jump back over here, we can see this is my cluster, and I can see that I don't have any services running yet, but I have an ECS instance that looks.
Oh, it's outdated.
Yeah, well,
gotta get that update.
Yep,
Doing it
but
live,
it looks a little different.
folks.
See this? See the instance ID? It starts with an MI. That's the manage instance that's running in the data center.
That's
It's
awesome.
a little different.
Yeah.
So Deft408 asks, any latency challenges with this model?
So we've seen no latency issues with the communication between the control plane and the data plane as far as launching tasks and so forth. And as far as the load balancer, so we've got ALBs in region talking to tasks on hosts in the data center. No difference with the latency that's on the DX that's already there. So
Yeah.
we've had no issues with it.
So you just take whatever your direct connect latency might be, or VPN, or whatever it is that's connecting you, and you just add that into the equation. You would probably, if you're architecting something, you would probably want to avoid, multiple round trips across that connection as much as possible. But in a way, this is a solution that can help you avoid that. So anyway,
I'm going to go ahead and launch a service here.
Yeah.
This is an Nginx service. Now, really no difference here when you create the task definition. The only difference is that launch type needs to be external. So we're used to seeing EC2 and Fargate as launch types. You can now specify external as your launch type. And just for fun, let's launch sudo docker ps. Let's see those tasks start to come up over here. And also in my cluster here, I can see I've got my service and it's up. Yeah, there you go. It's up. So, and you see the launch type shows up as external.
That's so cool. So we have another question. Tricellum says, what happens to a data center container if the network connection goes down between AWS and the data center for ECS Anywhere? Does the service go down?
It's a great question.
No. No. So that's the good news. So your container's running, Docker is running your container. So if somehow the control plane loses communication with your virtual machine running in your data center, your containers are going to run. The difference is if you wanted to update that service or do something with the orchestrator, it wouldn't be able to communicate and make any changes.
Yeah, and there is a timing element to this where, if your agent isn't able to communicate back to the control plane after a certain amount of time, then, things start to behave differently. And you'll want to experiment with that and, add that into your chaos potentially and see how your app behaves. But if it's just a brief interruption, no problem.
So I guess the question I would ask there is if the application load balancer is using the ECS availability as a health check, and there is that network interruption, will the ALB then start to issue a command to say, ECS tear down that and replace it, so you get some application churn once the network connection is reestablished?
I don't know. That's worth checking on. Tricellum laughs and he says, my internal network is my chaos. So Deepak is actually in chat answering some of these questions. And it's interesting. He points out to also pay attention to the IAM role and that potentially expiring and having a 6-hour limit. So you'd want to watch out for that because the agent helps refresh that.
Yeah, I guess an important aspect here is it's anywhere, but it's not intended to be air gapped.
Correct. And I think that is a really good distinction because the alternative would have you running the control plane yourself. And we don't want you to have to manage control planes. That's one of the best benefits of ECS is that you don't have to manage an orchestrator. We do it for you. So you get to keep that benefit while still adding in the ability to mix in compute that you've probably already paid for, you already own, and it's just, as someone earlier in chat said, collecting dust.
I love that. And, Brent, I wanted to ask the heroes, and it's so cheesy. This is my usual question. When was the last time y'all upgraded your ECS control plane? Sorry, it's never, right? The answer is never.
I did it twice this morning.
I don't.
Yeah.
You don't, and that's just the whole point, right? You don't have to manage that aspect or even think about that. I had to do it, Brent. I'm sorry.
It's totally good. I think, the question is, what version of ECS are you running?
That's the one. Yeah.
That way,
1.3.0 or 1.4.0.
Oh, that's
There is
just
a version.
That's a platform
version.
choice.
Yeah, that is a good point. But I think that kind of distinction of the control plane being something 100% not my problem is one of the best attractive parts of ECS, because Massimo spoke about it in the previous version, previous session around, whether it's Bottle Rocket or are there EC2 AMIs. And the best part about ECS and Fargate is it could be Bottle Rocket, it could be Firecracker, it could be a combination of those, it could be something else entirely that hasn't been announced. And I don't care, right? As a consumer, I don't have to worry about any of that as long as my service continues to provide me with the expected behaviors of latency, performance, CPU shares, memory, and disk. Like, that's the contract that I'm very comfortable with, and saying all that other stuff underneath, that's y'all's problem. I really don't want to deal with that.
Amen.
You're so true. You're so right. And, when I think about what work would I shift to using ECS Anywhere? I mean, you guys tell me, do you have, every time I'm talking to a customer, they tell me about some app, some workload that needs to be very closely located to their data, to the database, because they need super fast response time from the database. And oh, by the way, their database runs in their data center because it's so painful to move it. So, do you have something like that? Is that a potential target for managing that with ECS Anywhere?
So I think one of the options that I'm looking for that I don't think we have a great story yet for is the ability to run that same service or set of services in my physical data center, a little bit similar to Outpost. Where there's physical, again, ECS Anywhere and Outpost are very similar to me in that regard, because they live in my infrastructure and they're controlled on AWS. But the value I'm looking for is being able to communicate with those services in that data center, so that way I can still manage everything from the same comfortable control plane, but have those services co-located with, for instance, in a manufacturing facility, I have physical machines that need to talk to other physical devices and web services in that facility. Network latency is just a little too high to make it all the way back to a region. Even with accelerations, and the reliability of the local ISP can come into question as well. So having the ability to run something like ECS Anywhere on hardware that I already have, on applications that I already have, but manage that at the comfort of the control plane is very attractive.
It does bring up a good point, which is just making me think. So when we talk about running those containers in the data center, now, there is the idea of I need my containers to talk to one another. So right now there was a question, what about service discovery? So, Casey, with your experience of deploying ECS Anywhere, how did you have to think about that? And, is that something that you had to look at?
Yeah, that's a great question. So there's a couple different use cases that we need to be clear on. So if we're going from region back to data center, then the ALB option works fine. So I can register those with ALB and get through that way. But if I've got services in the data center that need to talk to containers that were deployed in the data center, it doesn't make any sense to go back to the region for the load balancer at that point. And so this has been something that we don't have a lot of use cases like that. So fortunately, we're not trying to solve that right now, but it is something that we do have some edge cases on, and we're looking at, well, can we register those tasks then just with an F5 device in the data center? So we've got these hosts in, and so nothing like that exists right now, at least not that I'm familiar with. So we're actually looking at, can we or should we create a small open source project that would handle the detection of new tasks running on these hosts and automatically register them for us with an F5, and that way we'd be able to load balance inside the data center.
That would be cool. So I feel like I want to point out, I do this every time we launch something in preview, but it's day one, right? So we just opened this up. And what we want is to be able to gather feedback from everybody. So sound off in Twitch. You know, we have Deepak in there right now. He's gathering all kinds of information. Tell us what it is you're looking for, how you think you're going to use ECS Anywhere, and what kind of work that you're really hoping to be able to move over to be managed by ECS Anywhere. And then for the things that you have discovered that you still want us to tackle, like load balancing or service discovery or other things like that, let us know that too, and do it right here in chat. We're collecting all this information, and we'd love to hear it directly from our customers. So we also, of course, talk about App Runner. That's another subject that service that we just released. So I don't know. What do you guys think of App Runner, and how do you decide what you're going to use for which purpose? The 17 question, right?
Yeah.
So what's your thought process on you have something brand new, greenfield? What do you do?
I think I would always, it depends a bit, and I think if you looked at the slides what Massimo showed before, I think that's a good starting point. What are your requirements? So normally I would say if you run in the cloud, I would start with ECS and Fargate and see if that fits your use case. And then you can maybe think about other options if you have some issues with that setup. But that would be my first choice.
So ECS and Fargate you'd call it maybe your first go-to, and then if there's exceptions, then start to branch out from there. That's kind of mine too. So I'm just confirming that I'm not crazy.
So for me, I think it follows along the exact same lines, and my reasoning is it's the simplest option, right? Pick the simplest option until you have a better sense of where your boundaries are going to be, right? If you try to start on day zero planning and day one deployment of, okay, I need this scaled out architecture, and you have no customers, then you've probably done the wrong thing. Mm-hmm. Whereas if you start with that simple approach of I've got some containers, ECS, slap an ALB on it, and it'll run on Fargate, and I don't have to worry about all the operations. It'll scale, set your scaling policies very simply, and just observe how it behaves. Will give you so much more insight on what the next step you should take. And in 80% of the cases, the next step is I'm done.
Yes,
That's great.
I love that. Yes.
I agree with these guys. I think ECS Fargate is the right starting spot. I think the 17 question comes down to how you get the Fargate service deployed, whether that's Copilot or Amplify or CloudFormation or CDK or App Runner. And I think that the point there is where's your current skill set and your current momentum as an organization. If you guys are already doing CloudFormation, then probably best to continue using CloudFormation to configure your services. If you already have a large investment in CDK, I'd continue deploying services. I'd run those containers with CDK. If you're not doing any of that and you just want to get started and you don't want to learn CDK and you don't want to learn Cloud, then absolutely App Runner would be a fantastic way to get started, get your pipeline in place, get all the right batteries included, and get going.
Nice.
I'll differ with you a little bit, Casey, there on that last point. I think App Runner is great. I think it's also brand new and a little opaque to the user as to where those rough edges are, whereas Copilot CLI is being developed 100% in the public view. So as an avid open source reader and contributor, I want to be able to see what am I going to hit? What is my expectation? What is the team's roadmap? More and more teams are publishing their roadmap, so it's not a ding on anybody there. But I've been using Copilot for one of my newer projects to sample what does it feel like. The team has been incredibly responsive through their feedback channels because, again, they want to collect that feedback from customers and real users. So my go-to right now, if you just have a new idea and you want to start out, the Copilot CLI gives you that IAM permissioning that is chaos to do it by hand. And they've kind of made all of that really slimmed down and strict, so that way you can have that security and comfort blanket of being ready. To the point where it's multiple environments, multiple services, and getting all of that deployed to play with was really comfortable. And then taking that to a matured pipeline deployment was an extra 2 commands. So it gave me that real confidence that I can take this simple idea that I'm playing with, and 80% I'm done, and saying now it's a real production level workload where I can continue to commit my code, push it, and get it auto deployed through the pipeline. So it was a really great experience of going all the way through. So big kudos to the Copilot CLI team.
Totally. And I love that because you said 2 commands, and I was thinking back to in my past, it was 2 sprints to build the pipeline, right? And now it's just oh yeah, okay, done. Thanks.
And don't get me wrong, right? It's highly opinionated, right? It's we're going to do this and this is how it's going to work. So if you do have strict requirements, you should audit those against what Copilot is going to do. But it does set up a really good framework to say, I bought the thing, I got the thing.
Yeah. It's for me, it's I can buy a car and the car is opinionated. There's a right way to drive it and a wrong way to drive it. Or I can be a Formula One race car driver and I have my own pit crew and we can huddle together and we can tweak all the knobs and everything and change absolutely everything. So what is better for me? For me, I just need a car to take me someplace, right? I care about getting there, not about the race. So if you're in the other camp, if there is a business justification for you to tweak all of those knobs and dials and tune absolutely everything, then we have choices for that too. So it's really
cool. Were you going to say something?
I think what is missing a bit is a similar thing like Massimo showed, because there are different levels of abstraction what these services covers or these tooling covers. So they in CloudFormation, it's on very low level. What you can do, CDK is already a bit on another level or the next level, and tools like App Runner but also the Copilot are on a higher level, and because of that also very opinionated.
Yeah. So how do you decide? If your choices are Terraform, CloudFormation, I put those on one level, and then I put CDK on another level, and then I kind of put Copilot on yet another level because it's different, and then Proton. What do you pick for your project?
Well, there's I think either Casey or Philip or both said it depends, right? Everything depends. There's a trade-off to be made with every decision we make. But I think the more we go after this is an easy choice to get started with that doesn't lock you into something that you can't change that decision if your requirements change, then that's the best possible solution. That's, again, why I like to choose ECS and Fargate. If I need more compute, I can always go back to EC2. But that's more on my management, and I'd rather not do that. So I'm going to start with Fargate. I could go Kubernetes. That's more management for me and overhead. I don't want to do that. I'm going to stick with ECS to begin with. And when I start with tooling, I'm going to choose either Copilot CLI because I have a good idea of how my application works today, or I'm going to try a even simpler version that doesn't give me all of those controls, which is the Docker ECS extension.
Oh, right.
Where I can, which we have failed to mention right now, where if you're super familiar and comfortable with Docker command line and Docker Compose, using that as an extension to build out some things in AWS immediately with that, it treats it as another backend, is another way to do it, but it lacks some of those other features that Copilot is going to introduce, such as automation of the deployment pipeline and kind of building that into the flow. So if you're very comfortable with Docker command line, use Docker ECS. If you're starting out and you're like, I'm not really sure about Docker command line, try Copilot first.
So there was a question in chat, any link or video showing how to use Copilot? And oh my gosh, I feel like you're teeing me up, because you can go to our Containers from the Couch channel at containersfromthecouch.com, and we have several Copilot videos that you can run through. But on top of that, I actually see backstage we have FA waiting. The very next segment after this, FA is going to be deploying using Copilot. So get ready, hang around, and that'll be up next. So I want to shift gears just a little bit and just talk about, have any of you explored Proton? Because I feel like there are a couple of different target audiences that we've been speaking to. And one target audience is the one, the developers, the maybe small operator teams. They're the ones that are writing CloudFormation, writing CDK, et cetera. But then there's the really big enterprise customers, and those customers, what I hear from them all the time is, we're building a platform. Mm-hmm. And that they are trying to solve problems for their developers by putting a team of people on it. And the team of people wants to abstract away. They want to build in the opinion themselves about how best to operate within their company, within their enterprise. So I was just curious, have any of you all explored Proton for doing something like that?
I'll be honest, I have yet to really dig into Proton because that story that you've described, which is having a common pattern or a method for more teams to use the same behaviors or compute or deployments is a little bit more easily solved for us by using templates. So if I can create a template repository that says, here's the greatest Copilot configs, and you can check out this one, copy it, clone it, and add your special sauce, then that's where we're 80% and we're done.
Well, let me introduce you to Proton then, because that's exactly what it does. So we were hearing this from a lot of our customers. We're building a platform. Customers, they were telling us that they start seeing repeatable patterns. We want to deploy a web service, for example, and it's the same for these 9 different development teams or 9 different service teams. So we just need a template, and we want to just stamp out exactly what needs to be in the template, but change a few variables here and there based on the team. And so that's what Proton lets you do. It lets a platform team provide a set of templates that developers can just show up, fill in their specific information, and then get infrastructure deployed for them. So all this stuff is really starting to come together and fit together, and it's all about choices, right? You have so many choices. When I walk into a hardware store, I don't want to go to the hardware store that only has one kind of hammer. I want to go to the hardware store that gives me a choice of a lot of different kinds of hammers, because I might need different ones for different jobs. So Anyway, choices. ...
So I agree that choices are great, right? But we can also have too many hammers where the uneducated doesn't know which hammer they want. So
That's
having
fair.
an expert there at the hardware store, using your analogy, to ask you, hey, I understand you're looking for a hammer. What is the job you're trying to do? Like, are you trying to build a miniature model, or are you trying to build a house, right? Like, there's different hammers for each use case. So being able to show those distinctions or those different use cases between each of these, and having an expert to guide you, I think that's where we can all lean on our AWS solutions architects. Shout out to that crew, who are, very knowledgeable about all the hammers that are available and can guide us towards better selection.
I think we need to make it easier for people to help with that selection part. I think that's part of where a lot of the confusion is AWS is doing a great job of identifying that there's a lot of different types of users that have very different needs, whether that's the enterprise platform model or the, hey, I just want to get started with Copilot model. There's an option for all folks at all different spots. Just need to make it easier for folks to figure out, well, which spot is mine? And I heard about this cool new thing. Who's this for? And how does it fit into everything else? And I think that's where a lot of the confusion comes.
I think it needs some guidance here as well to help you what kind of abstraction is the right one for you, because also the docs are usually always per service and don't have these overall view on that, and I think that's the part that is missing a bit.
Yeah, and we do have a container, another hero in chat, Vlad, and he's another very opinionated container hero, and he has a good point though. Very similar to the cars analogy, right? It can be overwhelming, and I agree with you guys. It's a good point. We need to be giving guidance as to what tool to choose and when. But I'll tell you this: I'm going to tell right now. If you're new to ECS, you're new to containers, you want to get something deployed, look at Copilot. If you don't fit in the App Runner use case, which is a web app, I want to expose a web app and I want to auto scale. And then from there, one thing I also want to clear up is Copilot is a tool that you can start with and you can finish with. Like, this takes you from start to end, and then day 2 comes around and Copilot's still with you. So it's a tool that will build a scalable, production-ready environment for you with auto scaling, with DNS, all the CI/CD pipelines, all these things that you would normally have to build on your own. And if you were to do it in CloudFormation, right, it does that for you. It's automatic, handles that. So I get it. It's hard, and we'll continue to get better and work on improving the messaging there. But it's very good points.
What I think would be very interesting is to see how some of these services start to tie into each other. So, like, when AWS started out, we had, SQS, we had SNS, S3, some really low-level primitives, and then more things got built on top of those. New services were launched. Where we have something like Proton, which is a helpful templater, and Copilot CLI, which is another kind of helpful thing, having Copilot call for the latest Proton template, or those kinds of service interactions that help the end user make the right choice and reduce that cognitive overhead of having to choose, right? Like, if day 1 at a new team is read the README, install Copilot, connect it to this existing repository of templates, and you're off to the races, what could be smoother than that?
Yeah, and feedback's important there. And again, we do have FA here, backstage, and he had just mentioned, we're looking at that, as we grow with these services, what relationships make sense? Copilot, Proton, those two make a lot of sense together, right? So how do we grow those two together, going forward? So yeah, great point. So, okay, we talked about tools. We talked about quite a bit there. What about, just putting it out there, to you guys? What has been your experience? Let's just talk about, your experience with ECS in general. Like, how has that been? What are you deploying out there? What are you doing with ECS? I know it's a loaded question. I know. So
I think that different dimensions. So I started my journey on ECS with EC2, but I think since I guess 2 years or so, I didn't touch any EC2 instance anymore because everything now runs on Fargate, and I think that part is quite good. What I would like to see is a bit make the networking part more easier, or to hide the complexity. If you compare them with EC2, you had security groups and you could connect them, which was worked quite well and out of the box and was easy to understand. And I think if we could hide that complexity of the networking, would be then also like a new abstraction. I think AppMesh is going into that direction, but still, that at the moment it's another complexity I have to add on top. So, yeah, I think that's what should be the next steps.
Makes sense.
I'll agree with Philip. Anything that takes a common pattern or this is the standard that we're looking for and hides it, right? There's always going to be complexity. There's always going to be servers, even a serverless world, right? Like there's always going to be something, but because it's not something that the end user has to deal with, I just want to get into a car and drive, right? I just want to start, I want to run. I don't want to have to concern myself with VPC IDs, security IDs, NACLs, all of the different primitives. I want to say, I want this thing to talk to this thing, right? And like being able to express those business value problems in a simpler sense gets us to an end state a lot faster than dealing with all of the low-level stuff that is not really going to get us there faster.
So I took an interesting journey. I started on ECS EC2 back when it first came out, back before AWS VPC even networking. So you're struggling with running. You couldn't run the same task, the same application with the same port on the same host. That was a nightmare. Saw that evolve and loved working with ECS. Took a detour with Kubernetes though. Spent a few years running. So workloads on Kubernetes. Mike, Philip, and I had some interesting debates in Vegas at reInvent about the merits of EKS versus ECS. But find myself back with ECS, and it comes down to the simplicity of the management. All the problems that I don't want to solve are solved in the orchestration layer, and just we can get back to writing apps and running apps now. Excited about also running those on-prem in a similar way with ECS Anywhere.
And there's one underlying theme here that I'm seeing, and Mike pointed it out, Philip pointed it out, Casey pointed it out, is we want to continue to move up the stack and manage less, but we want to do it in a way where it's going to have enough power to support us as we grow, and as our application profile grows and so on. So the networking use case, it again brings me back to Copilot. I think the users want more opinionated experiences with the opportunities to grow outside of the opinion when they need to, right? And Copilot does that. CDK does that with the higher level constructs. So you can take this high level construct, you can use it, but if you need more, you can extend beyond that. And I think that's where our customers, that's what they're asking for. And we're building it. So it's, the networking theme, I think, I feel like that's next on the journey, right? Simplifying that, all the networking complexity, because frankly, I think working with a service mesh, there's a lot of power with service meshes, service mesh, service mesh. Someone said mesh. I think it was Corey Quinn, actually. It was brilliant. But there's complexity with that and understanding that. So AppMesh does solve a lot of those problems, but I think we're still evolving in that field.
Mm-hmm. To kind of layer on to what you said, Adam, like we all want to move up the stack, and the analogies I'll pull are from both, the React world, where you have a create React app templater that gives you all of the things that you would probably have to build yourself. And they give you an eject command, so you can get out of that and start to customize the environment, and it's kind of a one-way street, right? Like once you've ejected, you're on your own because you said you know what you're doing, right? And like that same analogy applies to, like, again, our car, where if I buy a car and I've got a manufacturer warranty, and the minute I pop the hood and start to swap out new components, that's on me. I'm now becoming a race car pit crew because that's my choice. So as long as these tools like Copilot and others are going to give us that ability to have that really high level abstraction, but still pop the hood, get into the internals if we need to, and then understand why would we need to do that. Hopefully that's where the teams are listening and saying, why would you need to pop the hood? You can pop the hood, but really we're going to give you something at that level in a few months on our roadmap, so that way you won't need to pop that hood.
Yeah, and deleting code is okay too, right? Like, look, sometimes, look, I've been working prior to working at AWS. I was a customer of AWS, and I wrote a lot of code to patch holes for features that weren't there yet. And when those features came, the most exciting thing for me was submitting a pull request, deleting, 100, 200 lines of code. That was wonderful. So I think at this point, I mean, we've had a lot of really good conversation. I think maybe we can we're at the tail end here, maybe some parting words. So, it's time to be the thought leaders and get those thoughts out there. We could start with Mike. Let's start with you. What are your parting words? What do you have to say?
I think the best message I can send to anyone is keep it simple, right? Keep it simple, silly.
You stole mine.
Sorry, Brent. But the simplistic approach, and which is incredibly complex behind the scenes, but it's simple for me as an end user of ECS and Fargate, is going to solve so many things right out of the gate that don't go looking for other complex things until you've experienced that and felt if there are pain points that you can't solve with that scenario.
Love that.
I can second that, but want to add that you should also not only have a look on the container and the service itself, but the whole you have to see the whole picture. You need a CI/CD pipeline. You need your infrastructure as code. You need some monitoring in place for that service, and I think the tooling should support that. And we see some good movements into that direction. That some new tools like Copilot or so, they add the pipeline, they add some monitoring automatically for us, because that's the whole thing and not just the service itself.
Absolutely.
I would add, don't stress out. Like, there's so much stress about all of these. Oh my gosh, there's too many options. I mean, look at the upside of that. AWS is invested heavily in identifying what people need and building the right solutions for folks. And the investments continue. It's not like things get started and then abandoned. These things are continue to be invested in and involved in. So don't stress out about the number of options. Know that there's a right option for you, and talk to folks. Ask other people, how are you deploying things? And don't feel like you need to use the newest, shiniest. Use the simplest that can get you started, that leverages the experience and knowledge that your team already has.
I got one. Can I go?
Absolutely, Brent. Please
I love
do.
this. And I think the one that I would add to, I completely agree with everything so far. And the one that I would add is, what was I going to say? No, the one I was going to add is there's not one right answer for every situation. So it's not always simply an or, like you might for one situation pick ECS and Fargate, and for a different situation you might pick a different orchestrator and a different data plane. You might want to be on-prem, you might want to be in the cloud. And so just look at it from your requirements, from your situation, from the team that's going to be managing it, and pick the best solution from there.
Honestly, and the analogies were wonderful, so well said, everybody. I'll just add, if you need to dig a hole, don't get a crane if you don't need it. right? Just get a shovel. Like, you don't need a crane to dig a small hole. So use the right tool for the job. You do what makes sense. And I love that. Keep it simple if you can. You know, as folks who have lived in the world of managing and supporting these environments in production, being woken up at 2, 3 a.m., I think the idea is I just want to sleep at night, and I want my developer's code to run, and I want it to be stable. And let me sleep, please.
Nice.
So anyways,
right.
Brent, what do we got next?
All right. So up next, we have FA waiting backstage. He's actually going to walk us through how to deploy an app using Copilot. And what's cool is he's an engineer on the Copilot team. So all your Copilot questions, he knows the answers. So he and Adam are actually going to be here. They're going to be out front and center, and they're just going to be deploying away, and we get to see them in action. So we'll be right back.
And thank you, heroes. You guys are awesome. Thank you so much.
Bye.
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 Today starts with a workout. My husband and I do triathlons. Here's 10 years worth of races. I manage critical systems for 11 data centers. In my job, the only constant is that no 2 days are the same. The amount of thought and redundancy that we put into our systems is incredible. There is no place else to work on systems of this scale. I'm Frances Baldwin, Data Center Engineering Operations Cluster Manager at AWS.
Building and managing a startup can be challenging. Our goal at Amazon Web Services is to help guide startups like yours on a successful journey. That's why we created AWS Activate. It's free to join and gives you access to a bundle of resources and tools, including AWS credits to help you get started on AWS support credits for expert assistance when you need it, and technical training and hands-on labs to get you up to speed and proficient with AWS services. Startups in some programs also receive special promotional offers, including discounts, free trials, and other startup-friendly perks that can add valuable tools to your startup. Plus, with Activate, you'll be able to access the AWS Activate console, built by the experts at AWS, which delivers recommended content personalized for your startup. The Activate console also makes it easier for you to track and monitor your AWS credits and costs, and get real-time updates on the health of your AWS environment. By joining AWS Activate, you'll gain access to a global network of developers and entrepreneurs who are achieving success on AWS. And you'll have opportunities to showcase your startup at AWS events, including summits and reInvent, and on the Startups blog, helping you reach potential customers. Ready to get started? Sign up for AWS Activate today.
Well, things are different these days, but we're figuring it out. We're doing school online now, learning a lot. Finding cool stuff to watch. Dad's got some new workout buddies. And I still get to spend time with you.
Okay, now we're gonna put in the sugar.
Okay, and now we are here with FA. So, FA, what are we going to talk about right now?
Hey, Adam. So we're going to talk about, can you hear me first of all?
Yes, you sound wonderful.
Okay. Perfect, cool. So we're going to talk about AWS Copilot. We'll be doing a hands-on demo on how to build and containerize application with Copilot. But today I really wanted to focus not just on the getting started experience. You know, like in the previous segment, you talked with Brent about how we've done already so many videos on containers from the couch, on how to get started and individual features of Copilot. I wanted to focus specifically on how to grow an application, right? So the getting started experience will make it very easy for you to deploy a single microservice on Amazon ECS and AWS Fargate, or recently AWS App Runner. But today we're going to take a look at what it takes to grow. So how do you go from one microservice to multiple microservices? How you might add, secrets, databases, that sort of stuff.
Fantastic. So the day 2 style, I like this. We're scaling today.
Yep,
we're building all the way. All right, cool. So let's get right into it. And maybe before we start, FA, why don't you just do a quick introduction? Tell everybody who you are and what you do at AWS.
Sure. Yeah. So I'm FA. Hi, everyone. I'm an engineer on the Amazon ECS Developer Experience team. And with the team, we've been working on AWS Copilot for the past 2 years or so. yeah, I mean, that's pretty much all about me. And if that sounds good, we can just jump in and start explaining what is Copilot first.
Let's do it. Okay.
Cool. So can you see my screen, Adam?
Yep, we're looking
Okay.
good.
Cool. Okay, perfect. So here I am on the Copilot website. So you can find us on aws.github.io/copilot-CLI. And Copilot is an open source command line interface that makes it very easy for developers to build, release, and operate production-ready containerized applications on ECS, Fargate, and as of recently, AWS App Runner. So just diving a little bit deeper into these pillars, in the previous segment, we already talked about most of these. So today we'll get to see exactly like how they work. But the first thing that Copilot does is that it makes building containerized apps easy with ECS, right? So what you do with Copilot, you give as an input your Docker file, as well as a service type, some sort of architecture you'd like to satisfy, right? Like, so this might be, if I want an internet-facing service, I would choose, hey, Copilot, deploy, a load balance web service for me. If I want a service that's not internet facing, that's only accessible within my VPC, a private service, then I would choose a backend service. Or if I want a task that's scheduled, periodically, that's running at a particular rate, then I would choose scheduled jobs, right? So this way, Copilot makes it very easy to just get started with ECS. You don't have to worry about the underlying infrastructure, the VPC, subnets, security groups, load balancers, listener rules, ECS service, task efficient. All these like individual resources are abstracted away by Copilot. We still provide infrastructure as code for you, but it's a lot simplified and stripped down. And then, like mentioned previously, if you ever want to dive deeper into these resources and gain control of it, everything that Copilot does is through CloudFormation. So we'll see exactly that, how to customize these individual fields. Once you got started, the next thing that you might want to do is really release your application. Deploying to a test environment once, it's one thing, but then eventually you would like to get production traffic. So you want to create, a test environment first for me to just test stuff out. And then afterwards, a production environment where I can actually have my live traffic. And Copilot and Vinit allows you to specify a particular, AWS profile that points to a specific AWS account and region, and just quickly deploy your services over there. And then to tie everything together, we provide pipeline commands. So with Copilot pipeline init, Copilot pipeline update, you get a continuous delivery pipeline that deploys your services in your application into these environments that you previously created. And the last piece, okay, so we have our application live and running in a production environment. We have to figure out how to operate our service. How do we troubleshoot stuff when something goes wrong? So this is what we mean by Copilot being like a toolkit for containerized applications. It's not just infrastructure as code, right? It helps you both with releasing as well as monitoring and troubleshooting your services. So we provide, for example, Copilot service logs that help you tail your logs, right? Or you can write Copilot service exec, which uses ECS exec to get a shell into your running container. Or finally, you can view your health of your service, for example, with Copilot service status. Yeah, so that's an overview of Copilot. I won't get too much into it exactly over here. Instead, I want to focus on the demo. But if you'd like to learn more about Copilot, you can press on the Getting Started button. Here, there's some instructions on how to install the CLI, as well as a tutorial on just getting started with a basic Docker file, with a basic image. And if you'd like to reach out to us, the CLI is open source. So you can see exactly what we're working on, how we do things under the hood. We're really trying to also teach about AWS and ECS. So you can see exactly all the resources that are being created. And you can find the CLI at github.com/AWS/copilot-CLI. If you like the tool, please give a star. Our teammates would love it. And if you want to reach out to us, feel free to create an issue. We try to be really responsive over there, as well as a discussion post. And at the bottom over here, we have a chat button for Gitter. So if you'd like to just send us messages and talk with other people that are building on Copilot, feel free to reach out to us on Gitter. Cool. Okay. Should we switch over to the demo? What do you think, Adam?
Let's do it. I mean, so just to quickly recap, you went from, you have your your container, you have your application. Copilot's going to get you from that local container, that local application, all the way to a CI/CD pipeline using Git as your entry point, as your review source, and as your deployment mechanism. So pull request, merge that pull request. Copilot built the pipeline. That's going to deploy your code.
Yep,
so
that's exactly right.
Pretty amazing. So yeah, let's get in the demo. Looking forward to it.
Cool. Okay. So, just like Adam said, today we're going to focus on the day 2 stuff with Copilot. So at first, we're of course going to just get started with an application, right? So here I have a GitHub repository. If anyone would like to follow along live, maybe check out the code, see what's going on, feel free to do that. So it's on github.com, my name, Efekarkas, and then day 2 with Copilot. And here I've created several Git branches. So I have several branches that we're going to walk through. First, how to get started with Copilot. And then we're going to take a look at the alias field. So I'm going to preview a new feature that was merged into mainline that I think is delightful, and I hope you like it. Then we're going to take a look at how to decouple microservices. So not just a single microservice in my application. We'll see how Copilot makes it easy to go from one microservice to multiple microservices. Then, as part of evolving your architecture, we'll inject secrets and environment variables into our service. And then finally, with add-ons, we're going to see how you can truly take control of your infrastructure. Like add databases, customize, maybe add an event bus, add any other AWS infrastructure that's not provided by Copilot by default. Cool. Okay, so I'm going to click over to the first branch over here, getting started. So let's take a look at what we're building today. We're going to build a very simple REST API for my coffee shop, right? So over here, as you can see, I have several endpoints. So if you hit /products, you'll be able to get all the available drinks that I serve in my coffee shop. With /inventory, you'll get the quantity of each one of the coffees. And then with orders, you might be able to place an order so you can order, a drink. And the infrastructure that Copilot will help us get started with is going to be like in the diagram here, right? So I want to have my API be internet facing so that anybody that's joining the stream can actually hit that endpoint, take a look at it themselves. So what we're going to have is an ECS. Copilot is going to help me create this architecture. So we'll have an ECS service, a single ECS service that's going to place tasks on my subnets. And then we're going to have an application load balancer that's in front of it that's going to distribute traffic. And then with Route 53, I'm going to provide a domain name to my service so that we have an endpoint that's nice, that's an HTTPS endpoint. And Copilot is going to create all this infrastructure for me.
So, okay. Efe, a question came in, and I thought maybe it's just a good time to ask. So how, if I have an existing environment, how does Copilot integrate or interface with existing resources in my environments? And maybe I jumped ahead here, but
no, that's a great question. So let's just quickly do that. This is a hands-on demo. Let me type the Copilot command. You'll see in the help menu that we have several different subcategories. I'll dive into this just in a second. But the question was about environments. And if you have an existing VPC or an existing cluster, how do you, if you have existing infrastructure, how do we bring that over? So if I go to Copilot env, I can initialize an environment. So let me type that. So I'll type Copilot env in it. And I'm going to say, for example, I'll give a name to my environment. I'll give a particular profile. I'll explain this in a second. But if you have existing resources, such as your existing VPC or existing subnets, with Copilot, you can just bring that over. So I'll choose this option, and then maybe it's going to
zoom in a little bit. Sorry.
Oh, sorry. Yeah, let's do that. Cool. Is that better?
Perfect. Yeah, thanks.
Cool. Yeah. So if Copilot will scan, it will pick up the VPCs that's available for you, and then you'll be able to import your resources this way.
Nice. Oh, that's fantastic. And there on that same topic, someone had mentioned, secrets, and yes. I think you're going to get into that right in the demo here.
Yep. So I'll get into it in the demo. Just in case, if we run out of time or anything like it, feel free to go to the repository and check out the 4th branch, secrets and MVARs, and as well as our documentation. So in the developing section over here, if you click on secrets, we explain exactly how it works, and Copilot provides a command for secrets, which makes it super easy for you to be able to create secrets with the CLI.
Nice, very good.
Cool. Okay, so let me just type Copilot again to just to view the CLI, what it helps me do. So the first thing that Copilot will print is that it helps me launch and manage containerized applications on AWS. And if you're brand new to Copilot, you've never heard of it before, and you would like to go from a Docker file to running an application on ECS and Fargate or AWS App Runner, the easiest way to do that is just typing Copilot init. This top command will walk you through the different, it's going to ask you questions. Is this the location of your Docker file? What is the name of your service? And then it will create all the necessary infrastructure for you. But this is more of a deep dive session. So what Copilot init does under the hood is really call these individual commands. And it's just like, calls them one by one and glues them all together. So the first thing that it's going to do is call under the hood Copilot app init. And an application is just a name for your product, right? It's just a collection of services and environments. So in this situation, I'm trying to build a coffee shop. So I would name my application coffee shop, right? So I would recommend just naming your application something like the name of your product. Then we have Copilot env, right? We just saw like how to import an environment. So what Copilot does under the hood is call a Copilot environment init. So this will create just a deployment stage for your services to be hosted on, right? So first we're going to create a test environment. So this will hold all the shared infrastructure between your microservices, your VPC, your load balancer, all that stuff. And then finally, it's going to call Copilot service init. So this will be to initialize your microservice so that you have something that's running on ECS and or App Runner. Okay, so I'm going to run these commands individually, so we get to see like exactly how it works.
And just a little more zoom. So sorry to interrupt. Just audience asking for more zoom.
Sorry. Is this
Thank
better?
you. Let's go one more.
All right.
I think that's good.
Cool. Okay.
Thank you.
Let me type Copilot app init help. And you can see that for application init, with Copilot, you don't need to provide these flags. We'll prompt it for you if you don't provide them. But I'm just showing like how to use it at the moment. So I'll just name my application. So let me type this command. So I'll create an application first. I'll name it coffee shop. And then I'm going to provide a domain. So let me switch over to the browser really quick. In Route 53, I bought a domain, facoffeeshop.com. And I can use this domain to initialize my application with Copilot. So we get an HTTPS endpoint using this particular domain. I'm going to type, facoffeeshop.com. And then you can see that I'm getting an error because I already have, I might have, did I mistype it? Okay, sorry. So let me do this. So I ran this command before. That's why it threw me an error earlier. But I just fixed the typo in my domain. And then it tells me that, okay, it's all good to go. Over here, the only thing that we do with app init is just registering a logical namespace for your services. And then we'll create some basic roles for us to be able to manage your infrastructure. The next step that we'll want to do after Copilot app init is running Copilot env init. So I want to deploy a test environment. And right now, I'm close to Ohio. So I'm going to choose US East 2 as an option that I want to deploy to. So I'm going to name it Test Ohio as the name of my deployment stage. I'm going to choose my profile over here. So you can see that I have many different options in my AWS profile. So if I want to deploy, maybe I'll create a production environment that's in US East 1, right? Like in that situation, I might choose my profile that's called IAD that will help me launch into a different AWS account in a different region. In this situation, I want to launch into Ohio, so I'm going to choose my Ohio profile. US East 2. And then I'm going to go with the default configuration for my environment. So you can see that over here, we'll give you an overview of what we'll be creating, a VPC with 2 availability zones, a new ECS cluster, and some IAM roles to manage your services and jobs in your environment. So I'm going to choose yes, I would like to use the default. It's going to share some DNS permissions from my account where I had bought my domain to the new account where I'm using to deploy my environment, where my environment will be locating in. So right now it's creating these IAM roles and basic resources. And since I've already run this command, it finished pretty quickly. But normally, the first time that you would run this, you'll see all these resources being created. And that will give you a breakdown of the status as we're deploying and launching these, provisioning these resources. Okay, so far we ran Copilot app init, then we ran Copilot env init, and then the last command that we need to run to really initialize our microservice is Copilot service init. So I'm going to type Copilot service init. And the first question that Copilot asks me is, which service type best represents my architecture, right? So we have 3 different options here for services. A request-driven web service is a brand new option that was added recently for AWS App Runner. Right now, I'm interested in the load balance web service option. So this is going to be a service that's launching, that's from the internet to my ECS on Fargate service. So it's going to launch a load balancer for me, as well as provisioning an ECS service, right? The third option is a backend service, and we'll see that. So this will be a service that's not internet-facing. It's only available within my VPC that can only be accessed from other services in my application. So I'm going to choose the load balance web service option. I'm going to give a name, front end. Okay, so I should show this first. So I'll go back to GitHub over here, and let's take a look at the source code. So in the source code over here, you have the README, but the code for my service is under this directory called front end, and you can see that I have a simple node service, right? And these are the endpoints that was listed in the README, right? Like I can get products, I can get the inventory, I can get orders or post new orders. So it's a very simple application right now, a very simple microservice. And this was the Docker file that helps me build this, package this service into a container image. So the reason why I'm naming this front end is that because my source code is in a directory called front end. I'll name my service front end. Copilot is going to scan the Git repository, and it's going to pick up all the Docker files that's available. And I choose this Docker file. I have a single one in the repo at the moment. So I'm going to choose front end Docker file. And then Copilot writes that, hey, it created something called a manifest file at this particular location. And then it created ECR repositories for my service. So let's take a look at what this manifest file is. So when running Copilot service init, Copilot creates a Copilot directory in my repository. And underneath it, we have a front-end directory. And then finally, our manifest file. So the manifest is just infrastructure as code for a particular architecture type, right? So, normally you would have CloudFormation or any other infrastructure as code solution, which gives you a lot of control over the individual knobs that you might want to set, right? Instead, this view is really like stripping down all these individual resources and showing you all the knobs, or we try to show you all the knobs that we think would be interesting for a load balance web service. So a service that's internet facing, that's fronted by a load balancer, right? So some of the examples over here is that, again, we have the name of our service, and then we have HTTP. So this was the path from the load balancer to your service. We're going to listen en route. Now we have some health check settings that you can control, for example. This is the image, how it's built. One thing that we do with Copilot is that, let me switch over to my IDE, and if I open up my Docker file, in the Docker file, we expose port 3000. So Copilot will scan your Docker file and fill that information for you, right? So it automatically filled 3000 for me, and then it's going to create a Fargate task with the minimal settings possible, 256 CPU, 512 MB of memory, a single task count of 1, and then to enable ECS exec, we're going to set this to true by default, so you can run commands and troubleshoot your container. Okay, so now that we have our manifest file created, we have the infrastructure as code. Copilot can actually parse this file and then launch your service using CloudFormation. So the way to do that with Copilot is running Copilot deploy or Copilot service deploy. So I can run individually command over here. So let's do that. I'll run Copilot deploy. You'll see that Copilot detected only a single service in your application front end, and then in one environment, test Ohio. And then it's going to build the container image for me. It's going to push that onto ECR. And it's going to propose infrastructure changes for my application. So like mentioned earlier, you can see that Copilot manages everything through CloudFormation. This is the name of my stack over here, Coffee Shop, Test Ohio front end. And then Copilot is going to create a new revision, a new deployment for my ECS service with the code changes that I have locally. All right.
So
yep.
FA, thus far, you've initialized an application, an environment.
Yep.
And now a service, which it spit out a manifest, which that manifest, I could take each line in that manifest and translate that to lots of lines of CloudFormation.
That's right.
Or as we call like the assembly code, right? Like this is stuff that is abstracted from you. So, you know, the environment's built, the VPC, all the networking components, you know, you talk about the load balancer, target groups, connecting all of these things together on your own requires you to be an expert, right? You have to be deeply familiar with all of these resources, whereas Copilot is the expert. And you, FA, are, I mean, you're the expert in both, but in the, you know, this example world, you're the expert in your application and you're letting Copilot be your DevOps team, so to speak.
That's exactly right. And I want to like hammer something out like that. This is the part that I like about Copilot is that it doesn't just transpile into a CloudFormation template. Here I switched over to the console and you can see the stacks that are being created and being updated. And the thing that Copilot does is that by being an opinionated tool with how to launch applications on containerized applications on AWS, you know, we'll create a CloudFormation, we'll organize the CloudFormation stacks for you, right? So we'll create one CloudFormation stack that will hold all the shared infrastructure for your microservices. So this will be, let's take a look at some of these resources, right? So this will be your ECS cluster, for example, that will belong in one CloudFormation stack. And it will belong in the same CloudFormation stack as, let's scroll down really quick, as your VPC, right? Service discovery will be set up for you by default. You know, we'll create one application load balancer for your application, right? So what this means is that if you decide to create more than one load balanced web services, you know, we'll use the same application load balancer for all your microservices, right? So each microservice will get a different path, and this will help you save costs. So we'll first organize these shared resources into one CloudFormation stack, and then in your service stack, you know, we'll put minimal configuration over here, just like what's needed to really host your ECS service, right? So if I scroll down over here, the ECS service is being created. It's an update in progress. The task definition, task role. From the load balancer, we have the listener rule and the target group that's being created in this stack. Does that make sense?
Yeah, and a question just came in. Can Copilot reuse an existing VPC? We had showed that just a few minutes ago. You may have missed it, but yes, you can't import.
Yep, and that's true. Just to like reiterate really quick, let me zoom in this other tab as well. Over here. Sorry, let me try to readjust. If you type Copilot -init -help, you see that we don't have to worry about these flags because Copilot also provides a guided experience. If you don't provide anything, we'll prompt for the necessary information for you, but we do provide ways of importing existing resources into an environment. So this way you can import an existing VPC, for example, as well as your public subnets or private subnets.
Perfect.
Cool. So let's go back into the deployment over here, and you can see that from the CLI, from my terminal, I can track the progress of my deployment. So you can see that my previous, the new revision, it's in progress. It went from pending one to running one, and we're waiting for the health checks to be completed at the moment. The previous deployment was taken down. There are no more tasks that are running with the previous version of the task definition. And hopefully pretty soon, since now that the desired count is equal to the running count, once the health check passes, deployment for the primary will be written as completed. And then, so it looks like it's doing it. And then the CloudFormation stack will be done. The cool thing is that in case there are any issues with your code, or maybe like some sort of health check configuration that's not right, Copilot over here during the deployment will show those errors for you. So we'll go to the necessary deployment information, grab that from ECS, and then show that in your terminal. Okay, so if you can see at the bottom over here, there is a URL that was generated from Copilot for me, right? And you can see that it's an HTTPS endpoint. So the pattern that's followed by Copilot over here is that it's going to be HTTPS, and then your service name, front end, dot the environment name to where we deployed our service to, Test Ohio, dot the application name, and then finally with the domain that we bought, right? So this will be the default pattern that Copilot uses to when it's generating a domain name for your service. Okay, so let's quickly go over to Postman. Hopefully this is visible. The font is a little bit small, I think. Oh, I can zoom in. Perfect.
Perfect. Yeah. Every time, just the more zoomage, the better.
Okay, got it. Okay, cool. So let me readjust this, hopefully. So you can see that I've copy-pasted the endpoint that was given by Copilot for me. And in case you forget this, let me just quickly go back to the terminal. We provide commands under service, so you can type Copilot service show, and that should give me like information about the configuration of my ECS service. So let me see. It's scanning it, and I think in just a second. Okay, here we go. Under routes for my environment, it gives me the URL. So you can always find back that URL over here. And if I go back to Postman and I, make a request, hopefully all is good. And you can see that I get a response over here. And I have, 3 different coffees that I'm serving in my coffee shop: an Americano, a latte, and a cappuccino. I can get details about the individual products, so I can enter the product ID over here, make a GET request, and then it shows that, okay, this is how a latte is made. I can get the inventory of the coffees that I serve, right? So for each product ID, I get the quantity, and I can create an order. So for example, Adam is requesting an Americano for me. I'm creating an order. So
I was going to say a cappuccino, but okay.
Okay. I'll switch to cappuccino. So I'll create this request. Perfect. So Adam created a request. The response was successful. And you can see, by the way, how quick this is. So I'm making a request to my service that's hosted in US East 2. And I'm right now in Illinois. So it's 41 milliseconds to get a response back. And if I go back to the inventory, so for a cappuccino, it looks like I had only 2 coffees in my inventory. So if I make a GET request to the inventory again, you can see that for product ID 2, the quantity decremented to 1, right? So my inventory decreased. That's what I would expect. Okay, so that's the getting started with Copilot. Hopefully that helped, showcase how you can go from a single and really, to just reiterate, you don't have to run these commands individually. You can just run Copilot init, and that will help you get started with exactly the same steps that I just took. And that's how you go from a Docker file and an architecture type, a load balanced web service in my case, to ECS and AWS on Fargate.
That's fantastic. And literally the amount of work you did was just following the guided experience and just answering a couple questions.
Yep, that's pretty much it. That's all I do. So, let's move on to the second phase. Getting started, of course, it's important. We want an easy way of getting started on AWS and Fargate, on AWS Fargate, and as well as ECS. But what we're really trying to build is a product, right? And we'll have more than one ECS service running. We'll have to have a proper domain name that's associated with my service. We'll have to have databases, right? So in the second phase, I'm going to show this feature that we just added recently into Copilot. It's in mainline, and it will go out in the next release, that allows you to customize this default pattern that's generated with Copilot, right? So we saw the pattern of service, that environment, that application, that domain. And with this new alias field, you can just use, you can just say, hey, under HTTP alias, I want to just use my domain name, facoffeeshop.com, or I want to have I want to use a subdomain, right? Like in my situation, I want to surface this to the web as api.facoffeeshop.com. So that's what I'm going to do. I'm going to switch over to the next branch in my repository. So git branch, git checkout, do alias. So let me see what I have over here.
And
yep.
FH, there was a question that came in. If I were to modify the manifest and then push that manifest into Git, would Copilot automatically deploy that?
That's correct. So if you set up a pipeline with Copilot, so you have two ways of releasing your services with Copilot. You can run Copilot deploy, like the way I've been showing so far, to create manual deployments, and that will pick up your manifest changes or local code changes and deploy them. Or if you set up a pipeline and continuous delivery pipeline, which is the recommended route once you have you're done testing your service and want to create a production environment, then exactly like you said, you just create a pull request, git commit, git push this, get it reviewed by your teammates. If all looks good, merge it to your main branch, and then Copilot will pick that up and then release it.
Perfect. Thank you.
Cool. So in this second phase, all I did is just add this field into my manifest. So I have an alias field, and instead of using the default pattern over here, I'm going to name my service. I want to take control over the DNS name, and I want to name it api.facoffeeshop.com. So all I need to do is, like, once I modify this manifest file, is run Copilot deploy again. And it picked up that I have, again, a single microservice front end. I have a single environment, test Ohio, and it's going to, again, propose infrastructure changes, and it's going to make a trigger a deployment. So let's take a look at some of the stuff that Copilot does over here while to get that nice domain name for you. So now we have a new entry point in the progress tracker. It says that it's updating my environment's shared resources, and just in a second, we'll see that it's going to request a new certificate for me, as well as validate the ACM certificate for me. So let's hold on, hopefully, in a second. Okay, here we go. So it's requesting and validating an ACM certificate for my domain. Yeah.
So again, so in this instance, you have a domain in Route, and it's in Route 53. But again, we're handing off the work at this point to Copilot to create that certificate, associate it with the the proper records, validate it.
Yes.
and then that's it.
Yep, that's it. So Copilot takes away all this complexity of requesting an ACM certificate, validating the ACM certificate. Now making sure that the A records point, my domain name points to the load balancer. So Copilot handles that for me. And then afterwards, if it needs to update the task definition or the service, in this situation, it shouldn't, because I didn't change anything in my code. We're just like changing the URL where the service is accessible. It should update those, and then we'll get hopefully our new endpoint, and the service will be reachable at a much nicer URL, which you can use for production now, api.facoffeeshop.com. And honestly, to me as an engineer, like, this was the most, before I joined this team, this was the most confusing part, right? Like, it was like, okay, cool, I can just get started and I get a nice, an HTTP endpoint or some random URL, but how do I get my nice, api.domainname.com? And with the alias field, we create the necessary infrastructure for you.
Which is fantastic. And, by using ACM, that's Amazon Certificate Manager.
Yep.
So like you don't, so we're using that managed service, as a part of the opinion that's built into Copilot. So certificate rotation, that's all handled by ACM. So again, Brett and I oftentimes we joke about this is, I don't have to deal with, my certificate's not, it's expired, on the domain.
Yep.
I don't have to think about that anymore.
Yeah. It's great. I love the fact that the expiration problem is completely gone through ACM. Okay, so while this deployment is happening, maybe we can take a look at some of the commands that we didn't touch so far with Copilot. I'm going to switch over to this other tab. And one thing that I'll do is take a look at some of our operational commands, right? So earlier with Postman, I was making requests into the previous endpoint. So one thing that I can do with Copilot is that I can type Copilot service logs to view the logs of my service. So I'll type -H to see quickly the help menu. And you can see that we provide several ways of slicing and dicing your data, right? Like you can set the limit, how many log statements you'd like to view from the terminal. You can narrow down on particular task IDs if you know those task IDs. You can, my favorite is of course --follow just to tail my logs. And that's what I'm going to do over here. So I'll type Copilot service logs --follow. And then we should get, yep. So we'll see the log statements from my service, right? So here I have my task ID, and with Postman, I made requests to get all the products, get details about cappuccino. We created an order, and we see these logs appearing in my terminal. So if I go back to Postman, for example, hopefully, I don't know if the endpoint switched already. Oh, looks like it's actually doing it. So maybe it won't appear now if I make a get request. Yep, okay, so it failed. So that means that now I should be able to do API.facoffeeshop.com. Yep, nice. And now I get this, right? So now through this, and you can see that the log statement just trickled in, right? So if I go back over here, I try to get the product. Oops, I need to update this as well. I need to update all my endpoints to be API. I see that the log statement should just come in a second from the terminal. Nice. Oh, get all products. Here we go. Cool. Okay, and looks like the deployment was done. And you can see again that at the end of the deployment, it tells me that I can access now my service at api.facoffeeshop.com. So really, like, with just getting started and then setting the alias field, I can have a product hosted on Amazon ECS and AWS Fargate that anyone can use. That's a valid productionized application. So the next thing that we're going to take a look from here is really decoupling our microservice. So let me switch over again to the browser, and I'm going to go to the third branch for backend services. Okay, so in the previous steps, we saw how to deploy an ECS service on AWS Fargate behind an application load balancer. We updated our endpoint to be a nice URL with api.facoffeeshop.com. But the entire logic for our application lived in a single microservice. And over time, you'll want, you might need to actually decouple these microservices so that independent teams can work on them. And maybe if they don't need to be deployed together, these two resources, right? Like you will want to separate them out to reduce your blast radius. So this is exactly what we're going to do right now. And we're going to create a brand new microservice named the backend microservice. So let me take a look at the code, what we have over here. And you can see it's very similar to before. The one thing that I did is that I took away all the products as well as the inventory endpoints, those logics, and I moved it to the backend service. And instead, right, the front-end service, all it does now is handle the order logic. It doesn't do anything regarding inventory or products. So you can see that orders stayed the same, but products and inventory change for the front-end service, our load balance web service. And all we do, you might ask, well, how do these two services communicate with each other? And that's through service discovery. So in our environment stack, we created, let me scroll to the bottom, we created a service discovery namespace for all of our services in the same environment to be able to talk to each other privately, only within the VPC. And Copilot does that for you by default. It also injects the necessary environment variables into your containers so that you can actually write your application, your code accordingly, right? So let me quickly run Copilot service show again.
That's a great point to bring up those. Yep. Copilot doesn't just build the resources for you. it's thoughtful in your development process. And we understand that you're going to use environment variables to use these reusable components, and we fill in some of those for you. So super cool.
Yeah, and soon in the 5th step, we will see how to create databases for you. And again, just like before, Copilot will inject those, the table name, for example, for your database for you, right? It will make sure that the secret and the task role, everything is updated for you so you can access that database. So Copilot shines in this like wiring of these different AWS resources together. And this is the service discovery namespace that was created for me for Copilot, right? So each service will get a separate namespace that they'll be accessible to within the VPC at this endpoint. So this is for the front-end service. Once we create the back-end service, this will be updated to backend.coffeeshop.local. Okay, so let's go ahead and start the 3rd step. Let me go back over here to the README. And what I'm going to do is check out just like before. I'm going to stash, git checkout, 3rd branch, backend service, and we're going to create a brand new service. So in this situation, I want my backend service to not be accessible from the internet. Only my front-end service should be able to access this particular service. I'm going to choose the backend service option. I'll choose backend. I'm going to name my service backend. And again, Copilot scans my repository, picks up the 2 Docker files that's available in the repo. I'm going to choose the one under the backend directory, so backend/Docker file. And then just like before, it's going to create the manifest file as well as the necessary ECR repository for the backend service. So just taking a look really quickly at the manifest file for a backend service, this was for a load balance web service. And you could see that over there, for a load balance web service, we have an HTTP section, right? This is configurations for your application load balancer. But for a backend service, we don't have that. Your service is accessible through service discovery, and it is not public. Just like before, Copilot is going to scan the Docker file for the backend service, and you can see that I expose port 3000, and as I have also container health checks written in my Docker file. So Copilot will fill those out for me under the image section. I will fill out the container health check. It will also fill out the exposed port. And just like before, it's going to set minimal settings for Fargate. Okay, so going back over here, now I'm going to type Copilot deploy again. And this time, Copilot detected 2 different microservices that were initialized in the application, and it's asking me which service do you want to deploy. I want to deploy backend, but there is only a single environment that it can be deployed to, so it's going to deploy to test Ohio. Okay, so now it's again just building my container, and then it's going to push that into the ECR repository that was created with Copilot. So this might take a while, just because I'm building a node, a node image, and it's trying to push that. But while this is happening, actually, it's not too bad. One thing that we can do is then take a look at some of the other commands that we did not touch on for Copilot services.
And can I just interrupt? We got a couple of questions that came in.
Of course.
So one, and I believe this is also in your demo repo as well, can Copilot use custom CloudFormation resources? So I'm assuming this question is, I have additional CloudFormation. Can I use Copilot to deploy that?
Yep, you can definitely do that. And let me show first where in the documentation you can find this information. So if I go to the Copilot website, aws.github.io/copilot-cli, in our docs, under developing, you'll find the additional AWS resources section. So this dives deeply into, explains like how you can bring your own CloudFormation template and your own resources into Copilot. And then if I go into this particular branch for add-ons, which we're going to take a look at soon. So if I go to Copilot, then the backend directory, if you create an add-ons directory and then drag and drop any CloudFormation template that you want, which is what I did over here for Redis, you can see that I'm creating a Redis cluster. The Copilot will just pick that up for you. So it will create a CloudFormation stack on your behalf with these additional resources.
Nice. And there was another question that came in around if I wanted to see like my resources. So without having to go into the CloudFormation console, is there a way with Copilot that I can just see what resources were deployed?
Yes, you can definitely do that. The way to do that with Copilot is, I'll type Copilot service show, and then we have a flag named -- resources. So if I type Copilot service show -- all the resources that were deployed part of my service, that's listed first for the front end service, it's going to write, hey, these are the resources that were created on my behalf.
Nice. Awesome.
Okay. One thing that I realized I should have done is that while the backend service is deploying, I should have deployed the front end service as well, so that the new code that's using service discovery is also deployed onto ECS on Fargate. So that's what I just ran now. So the front end service is deploying at the same time as the backend service is being deployed.
Nice.
Cool. Okay, so maybe while this is happening, let's take a look at like how things look like in the console for us with Copilot. We try hard so that hopefully you don't have to go to the console and you can stay in the comfort of your terminal. But of course, the console is a much richer UX where you can find additional information that we might not be surfacing. So here, if I went to ECS, to the ECS console, on the clusters, you can see that I have 2 services that are running, and each one of them have 2 tasks. Well, sorry, each service has 1 task, and in total, I have 2 running tasks. And under services, I have both my backend service as well as my front-end service. So it looks like the backend service was created, and I have my task that's running. That means that my deployment should be done. And then once the backend service is done deploying, it gives me an endpoint. So this is the service discovery endpoint. So it's not an endpoint that that you can use to access the service online. There's no way to hit this. It's only accessible at this particular endpoint within my VPC. So only the front-end service can access the back-end service. Okay, so let's take a look at what's happening with my front-end service. Looks like the deployment is continuing over there, and I'm creating a new revision with the code that I showed in the front-end service, where we're now swapped the /products and then the /inventory endpoints to just forward request to our backend service using service discovery, and it's moving it from desired to now running one, and then it's waiting for the health checks again for that to work.
That's awesome. So if I get this right, you deployed a monolith, so to speak. You're right. It was your front end monolith, and now you've broken it up into a back end and a front end service, and now we're just deploying those changes.
Yep, that's right. That's all I did. Yeah, and this way, you can really decouple your services. And I would recommend following kind of like similar steps, right? Like you should deploy first your back end microservice where no one is, the front end service was not using yet the back end microservice. And then, once the backend service is up and running, the container health checks have passed. So I can run, for example, Copilot service status over here. You should ask me which service you want to show. I want to see the health of my backend service. If I tap over here, you can see that it launched. It started 3 minutes ago. The health status, the container health checks are healthy for my service. Once the backend service is up, then I can swap the front-end service from the old code where it was a monolith, like you were saying, to using now forwarding requests to the backend service instead.
That's fantastic. And there was a question about just understanding in the console what resources are built and managed through Copilot, and Dave had answered that Copilot does tag all the resources it creates.
That's exactly right. Copilot tags all these resources. So if I go, for example, to CloudFormation, we can see that. Okay. Oh yeah. So now I have, a CloudFormation stack for my backend service as well as my front-end service. But if I press this and scroll down to tags, you can see that we'll create a Copilot application and a Copilot environment tag. So you can find all the resources that were created by Copilot, by searching, for example, your your application name with the tag key Copilot-application.
Fantastic.
And that will help you like find the granularity. And we try really hard to not create, unnecessary resources if you don't need to, if you won't need it, and provide ways for you to, extend your template or through the manifest, create these additional resources to make your scaling needs or your compliance needs. So one example of this that Copilot does is that Copilot will launch your task by default on public subnets, but no one from the internet through security groups will block access from the internet to your tasks, right? So only the load balancer can actually reach these tasks, although it's in public subnets. But because we're launching in public subnets, we won't create a NAT gateway for you by default, right? Which saves you a decent amount of money. But if you need a NAT gateway, for either security needs, maybe your work environment requires it, or maybe for scaling needs, if you want only private IP addresses to be associated with your tasks. Oops, sorry. Close application.
That's a strongly agree.
The Copilot is going to, we provide ways with the manifest to create these NAT gateways for you.
And while we're just waiting, I saw it just finished really quick. Question came in, can I use multiple accounts? And Dave answered, not only can you use multiple accounts, but you can use multiple regions. So to me, that is something that I think that is a pretty complex thing that we easily overlook because Copilot handles so much of, and it simplifies so much that, but yeah, Copilot manages all that for you.
Yep, you can definitely do that. Okay, so my services are deployed. You can see that the front-end service gave me back the exact same endpoint. Nothing changed over there, but I got a new task now. There should be forwarding requests. So if I hit products, if you can recall, the products, the source code, the logic now is hosted in my backend service instead of my front-end service. So if I query this and if all is good, yep. So we get back a response. So this is happening now. The front-end service is forwarding the backend to the backend service these requests. It's getting a response through service discovery and then replying back to us.
So FA, we have about maybe about 15, 20 more minutes. Just to give you a time check, but let's run through whatever else you want to run through.
Okay, yeah, sure. I'll wrap this up in 10 minutes. We're like almost done over here. But the next step that you might be interested in is one of the questions from the audience was how to inject secrets and environment variables. And in the manifest, let me switch over to the code really quick. We have sections over here for variables as well as secrets. So you can just use an SSM parameter store secret or a secrets manager secret, inject those as environment variables into your containers, or just write directly environment variables under the variables section. One thing that Copilot does, so let me switch over to the branch really quick. Check out 04, secrets and envars, is that under the help menu of Copilot, you'll see in extend, we have a category called secrets, right? So I can type Copilot secret in it to quickly create a secret that my ECS service can actually access. So it's first going to ask me the name of my secret, and I can give, for example, if I have a secret for my RDS database or something like that, or an API token, right? Like I'll write my API token. So that will be the name of my secret. And then it's going to ask me for the value of my API token. I'm typing 1234. It's very secret. And it's going to create the secret in the environment test Ohio for me, right? So if you had more than one environment, secret in it is going to prompt you each time. It's like, what is the value for your production environment? And then at the end, it tells you how to modify your manifest file. So you can just copy this section and then put it into your manifest and get it working. That's it for secrets and environment variables. And I think that's what I've done in my manifest file over here. If I, let's go to GitHub. If I open up backend, and if I see my manifest file, you can see that I added one environment variable named log level with a value of info. And then I'm injecting a secret to access an existing Aurora database. So I called it, the environment variable name is my RDS password. Then I created over here in this path with Copilot secret in it. Okay. So the last piece is add-ons with Copilot. So with Copilot, you can add any other platform, any other AWS resources which associated with your services, right? So for example, a storage component or an event spots component, you can do that through add-ons. And to learn more about this, if you'd like to read on your own, check out the documentation. So under developing additional AWS resources, we have a guide on how to set that up on your own. But Copilot provides some easy ways of adding storage resources, right? More specifically, we make it easy for you to associate an Aura serverless database with your microservice, or add the DynamoDB table, or an S3 bucket, right? So let's take a look at quickly like how to set that up with Copilot. So I'm gonna go quickly to my last branch over here, add-ons, and I'm going to type Copilot storage in it. So it's going to prompt me, hey, which service would you like to create, this storage resource for, right? I'll choose my backend service. Ideally, my front-end service will be just an API gateway kind of thing that's going to route requests to my other microservices, and I can choose which storage type that I want to create. So let's say that I want to create an Aura serverless database. I would choose Aura serverless. What is the name of my cluster? I'll just use the default that Copilot provides to me, backend cluster. I can choose between MySQL or PostgreSQL. I'll choose Postgres, and then I'll name, for example, my first, since I have inventory and products, let's say that I'll put like inventory in there. So that will be my first database. And Copilot is going to create a CloudFormation template for me for this Aura serverless database. It tells me exactly how to use it in my source code. So you can see that it gave me a source snippet on this is the environment variable that Copilot will inject for me by default, backend cluster secret. I can parse the JSON and grab the username, host, database name, password, and port so that I can connect to the database. So let's take a look at some of the stuff that we have under backend. Let me refresh. Okay, so Copilot. So under backend, I have 3 different CloudFormation templates over here. So products was one that I ran earlier that was for a DynamoDB table. The cool thing with add-ons is that we'll write the CloudFormation template for you for DynamoDB, for example, and then we'll scope it to the minimal set of necessary to be able to access this database from your service. And the way it works is that in the output section of your CloudFormation template, anything that you have with add-ons, this is the way for you to associate this CloudFormation template, these resources, with your ECS service. So for example, one of the outputs that I have in my CloudFormation template over here is referring to the access policy. So here I defined an IAM managed policy for my database, and the fact that I'm outputting an IAM managed policy is going to augment my task's role with this particular permission. So now my service can automatically access this DynamoDB table, right? And then if I take a look at, for example, the backend cluster, I'm going to, this one is big because it's an Aura serverless database, but I'm going to scroll down again to the output. And you can see, for example, we have a comment over here that says that this output is injected as backend cluster secret environment variable by Copilot. And for example, if you decide to output a security group, this is how you can write a security group, in your CloudFormation template and automatically associate it with your ECS service. And I do the exact same thing with my Redis database over here. Does that make sense?
Yep. Yeah. So not only are you creating your additional resources, using add-ons, but then when you want to sync them, and when we talk about talking with other resources in AWS, unless, obviously a database, relational database, you can use a SQL command to talk, but if you want to talk over IAM, like to S3 or Dynamo, you need that policy attached to your ECS task, right?
Yes.
This manages that for you. So again, we're greatly simplifying. You have your complexity built into your CloudFormation stuff, but then we simplify how to sync your existing tasks to that.
That's exactly right. And
amazing.
The only thing that I need to do at this point is just, once these templates are created for me, I just type Copilot deploy again, and this time it's going to create these additional stacks for my these add-ons, right, for these templates.
That's amazing. And so there was a question that came in, and there was an answer that was so perfect. It was just, if you could describe, Copilot. Let me find that question in one sentence. Describe what is the best target user group for Copilot. And I just want to throw this out there, and I believe this is actually Mike, a container hero from earlier. His response was, my take is people who want to run containers in production with less ceremony and hassle. And I want to second that. This is, if you want to run containers, you can, whether you're beginner or the most advanced expert in AWS, but you don't want to have to think about and manage all of these components and offload that to, frankly, a tool that is managed by people who most likely know it a little better than I do, right? And that are going to continually update it with best practices. That's the target market. It's everyone.
Yeah. I would say on top of it, I completely agree with everything that you guys have said. And I would say that kind of demographic that we're targeting for is like small independent, two pizza teams that we have like at Amazon, right? Like if you're in a large company and you are an independent team that can manage your own infrastructure, Copilot will make it very easy to not only just getting started, that's one piece of the equation, but then also grow your application as well as troubleshoot your service and release your services, right? The other piece, or maybe you are a startup, you are again small and independent, you're a completely independent team. For a startup, this will be also very ideal, I think.
Absolutely.
Cool.
So what do you think? I think we're getting towards the end here. Was there, I guess, FA, let's wrap it up with what are your parting words? And
sure.
Yeah.
Okay. Thanks, Adam. So again, Copilot is open source. It's available on GitHub. So please find us on github.com/AWS/Copilot-CLI. Please try out the tool if you can and give us feedback on issues, discussions. We try to be as responsive as possible. And yeah, that's all I have. And you can find our documentation in the README over here. So that's it.
Awesome. Yeah, Fa, that was really amazing. We went in 1 hour. We deployed a monolithic app, broke it up into microservices, deployed a database, deployed a record to Route 53, load balancer, all these things in an hour.
Yep.
So again, Fa, that was amazing. Thank you so much. So coming up next, we're going to have myself, Brent, and I believe Nathan Peck, depending. Yep, I think so, Nathan Peck. And we're going to actually do some Q&A. So if you have questions, bring them in the chat. And also, we're going to do some whiteboarding where we'll whiteboard all of this stuff that FA just did. We're going to draw it out on a whiteboard and see what that actually looks like if you were to build this yourself. So we're going to take another break, and then we'll be back shortly. So thanks again, FA.
Thanks. Bye.
Companies are rapidly adopting the cloud for agility and lower costs. However, some workloads need to remain on-premises due to low latency or local data processing needs. Instead of using different development and operating models for on-premises and cloud workloads, what if developers can use the same services and APIs they use in the cloud to develop applications on-premises? And what if IT can use the same tools to manage and operate IT resources across on-premises and cloud? AWS Outposts bring AWS infrastructure, services, APIs, and tools to any on-premises facility with reliable network connectivity for a truly consistent hybrid experience. Customers have told us they would use Outposts for a range of use cases. To get started with AWS Outposts, you order from a range of fully integrated and pre-validated Outpost configurations best suited for your use case and facilities. You can choose from a variety of EC2 instance types with and without local storage options, as well as EBS SSD general purpose volumes. AWS certified personnel deliver and install your Outpost rack in your facility, and connect it to power and network you provide. Connect your Outpost to the nearest AWS region using AWS Direct Connect or VPN. For low latency access to on-premises resources, you can create a local gateway to connect your Outpost to your local networks. Seamlessly extend your VPC by creating a subnet and associating it with your Outpost. Instances in your Outpost can securely talk to other instances in your VPC through private IP addresses. Launch EC2 instances and run your applications on Outposts using the same AWS console, CLI, or SDKs as in the cloud. You can also run a range of AWS services locally on Outposts. You can access regional AWS services using public service endpoints or by using Private Link to connect your VPC to these services via private endpoints. Outposts are fully managed and supported by AWS, removing the overhead of updating and patching software, maintaining hardware, or calling multiple vendors for support. You can leverage a broad range of AWS partner network partners to support installation and maintenance, cloud migration scenarios, or for networking, storage, and security solutions for your Outpost. AWS secures your Outpost just as it secures infrastructure in the cloud today. Customers are responsible for the security of their applications running on the Outpost and for the physical security of the Outpost wrap. With AWS Outposts, customers can extend the AWS experience on premises for a truly consistent hybrid cloud experience.
Okay, welcome back.
All right. I changed up my audio. Can you hear me okay?
Yeah, you sound great.
Fantastic.
Even better, you sound perfect, Brent.
No one's perfect. Welcome, Nathan Peck, back to the stream. If you weren't here earlier, Nathan joined us. And what did you show us earlier today?
Yeah, so I showed off my Raspberry Pi ECS Anywhere cluster and did a little demo of deploying a ECS service onto the Raspberry Pi cluster. For anybody who didn't see, I can actually take my camera and put it over here so you all can see what this Raspberry Pi cluster looks like here.
I love this thing. It's so
Yeah.
production grade. Like
I was going to say, it's Nathan's data center.
Well, to be honest, like when I got started with programming for the cloud, I'm definitely, you could call me a child of the cloud. Like I basically started out with cloud from the beginning. Like before that, I was using like VPS servers, the virtual private servers, which were like shared hosting. And I went straight from that to AWS. So basically, I never actually deployed things in my own physical data center other than like running a build server inside the office and stuff like that. So this is my first chance kind of building my own little server racks and essentially my own data center in my office. It's kind of cool.
Nice. Very cool. So I guess, Brent, what do you think? So we have a whiteboard. It's actually black in the background, so but we have a board and we're going to draw on it. Did we want to just jump into that? Did we want to maybe talk through were there any questions we wanted to run through? What do you think?
There were a couple of questions, and one of them I want to definitely throw at you for sure, but we're going to start with an easy one. It came in earlier. I don't know where it went in the chat, so I can't pop it up on the screen, but I took note of it, and it was, can you migrate existing ECS set into Copilot?
So I think does that mean like an existing service or a cluster?
So I think it's a good opportunity to just talk about like the word import is, I think, kind of overloaded here, because let's face it, as at its lowest level, these are containers, right? So the answer is yes. The question is, how much work do you want to put into this? And frankly, it's not a lot of work. So if what you're asking about is, can I tell Copilot, look, there's my service and task and everything, just start managing it? Today, no. However, what you can do is take that container, take that task, and all of the unique information that, that you've already figured out, and just go and tell Copilot about it. And Copilot will then deploy a new copy of it and start managing it that way. And then if you just want to shift traffic, over to sending the traffic to that new copy of the app, then that's all you have to do. So import, by some definition, yes. But as far as like what you mean, can I just start managing what's already there? Currently, no. So, but I don't know that it's even worth the effort to add that feature, because it's just so easy to shift things around. That's something that I think gets lost a little bit, because the hard step is to go from 0 to containerized. But once you've done that, like moving stuff around and executing it the way you want and managing it the way you want and switching from one way to another way, it's not that hard. So I think that's really cool.
Yeah, and what's your source of truth here? It's your application code, it's your Docker file, right? That's telling the orchestrator, here's my code, here's what I expect, here's how I expect it to run. You just got to fill in some blanks in the manifest file, and then you're up and running.
And one of the things, whenever somebody asks about migration in specific, and is it hard to migrate from this tool to that tool, one of the things that I always like to talk about is how much setup is involved. So if you were creating everything by hand, manually clicking all the buttons in the console, and that took you 2 or 3 weeks to set everything up, then maybe you would be like, well, that's a lot of work to migrate from this to that, because I'm gonna have to click all these things, have to enter all these values by hand to get it set up properly. On the other hand, with a tool like Copilot, I can spin up that same thing that maybe took a day or 2, or maybe even took me a week to get all the settings right. I can spin that up and it'll work properly in less than 5 minutes, 10 minutes. And so it's almost like if I had spent multiple weeks setting up my infrastructure and get everything to work right, and then I switch over to Copilot and it only takes me 10 minutes to replicate all of that. Yes, technically I am recreating everything from scratch rather than technically importing it, but it feels almost like an import because the amount of work is so small and it recreates everything.
I think the one case where an import makes sense is the VPC. Sometimes you have to work within the constraints of what you're given. There's security teams, enterprise teams that are managing accounts, or even in smaller companies, whatever that is. So that's the one case where,
point.
Yeah, you can just import that VPC.
Yep, it's a touch point where like you have to coordinate with other teams, and the fewer handoffs that you have to manage there, the faster you'll be able to move.
Yes,
so there was, go ahead.
Was it the question? I don't know. A question just came in.
It's the question. I'll let you go for the one that just came in because it's the freshest, but I'm not letting this one go.
Okay. Well, okay. All right. So the question came in, can we set up CloudWatch alarms for Copilot actions? So I'm going to take this in the direction of if I want to auto scale my service. And I'll let you guys, if there's more you want to add to this, maybe I'm missing some from the question, but absolutely. So Copilot has service auto scaling built in. All it takes is for you to enable it. So if you gave FA another hour, he would have gone through, like we would have been done going through everything that Copilot does because it's so powerful yet so easy to use. So service auto scaling, if you want to scale off of requests, response time for your front end service, if you want to scale off of CPU memory, you can do that. It's literally just in your manifest. You define what that value is that you want to use to scale, and your minimum maximum tasks. Copilot will set all that up for you. And then when you run a Copilot service status, I believe it's service status, you can see the health checks. You can see the alarms, and you'll know if your service is scaling or not. So you have that insight, and it's just all built into the tool. Was there anything else you guys wanted to add?
No, I completely agree. That's one of the cool things, not just about using Copilot, it is certainly cool about using Copilot, but also just using ECS for, which is what Copilot is using on your behalf. Like getting integrated into CloudWatch and CloudWatch alarms and having, that capability is just automatic. So I think it's really cool to be able to do that. So there was this question. I want to hear Adam's take. Does this tool integrate with other CI/CD tools like Jenkins? And I swear it says like Jenkins. And if you don't know, Adam is Mr. Jenkins. So I can't wait to hear what's your take.
So, okay. So I've built a lot with Jenkins in my past life, and but to answer the question, so right now at this time, Copilot to build your CI/CD pipelines. If you want Copilot to build the pipelines for you and then manage all of that, it's going to be with Code Pipeline and Code Build. So it'll automatically build those AWS native. And the nice thing about these services is you only pay for the time that you use them. So Code Pipeline, Code Build, I'm only paying for when that build instance comes up, builds my container, and then deploys it. But that's very minimal. So if you wanted to integrate with other third parties like, like GitHub Actions or Jenkins or, Bamboo or Travis or all these other tools, you can. It's just simply running the Copilot commands, right? And determining what commands you want to run to deploy. So it's not, super difficult, but it's not native at this time.
Yeah. I would say it's like you're saying, it's not built in. However, when you build a pipeline using Copilot, one of the things that you get is the I think it's the code build YAML or something that just shows you each command that's going to be running in code build. I mean, you could take that and swap it over to the slightly different YAML that one of your other CI/CD platforms wants, or probably with a lot more effort, you could swap it into some kind of weird Jenkins format that only Jenkins people understand. So
it's not exclusionary. We're not exclusive. Anyone could use Jenkins.
Whatever. Every time I needed something done in Jenkins, I would just hand it off to Adam, and I'm like, Adam, do this for me. I can't figure it out. I don't know what I'm looking at.
It's true. It's true. But it's if you really want that native experience and Copilot to build it for you, yeah, I mean, Copilot will do that with Code Pipeline and Code Build. And I would challenge to be frank, I would challenge someone asking me that and saying, why do you need to use this other tool? And if it's like some enterprise requirement or something, I get that. And that's where you do what Brent said. You kind of pick apart that build spec YAML for the code build, and you just transpose that to your other format. So otherwise, use what's native if you can.
Nice. Awesome. So I hear you have a board, Adam.
Yes.
Is it time?
This is like a Container Day first exclusive where, oh, interesting. So it's,
yeah.
How do we do this?
I gotcha. Oh,
Okay.
wait, that's not the right way. Here we go.
There
and
we
now
go.
I'm gonna rearrange one more time. Bear with me. Okay.
Perfect. Okay.
One more time.
So we can see my whiteboard here. And so what we're going to do is, okay, so we talk a lot about, the opinion that's built into Copilot, or when we talk about CDK constructs, these L3 constructs that, load balanced web service. And we talk about all these things that it builds for you. So we thought it may be cool to just diagram this and actually show you so you can see really like all the different components and the complexity that's managed by using a tool like Copilot. So what do you say? Should I get started?
Yeah.
All right. Let's do this. So we're going to start with, first of all, we know Copilot can work. We mentioned it when FA was talking. Copilot can work multi-account, multi-region. So that you just plug in and, with using the Copilot CLI, and you have those integrations. But for the sake of just a simple diagram here, which you'll see is going to get complex fast. Let's talk about all the things that Copilot builds. So for starters, when you create a Copilot environment, that's giving you a network, okay? A network that spans 2 availability zones. Okay, so we're going to do it like this. Actually, we'll do it like that. So that's that's awesome. That's a great comment. So it's going to build that network for you. If you're going with you're not importing a VPC. So what does that mean? That means it's creating subnets in multiple availability zones to give you that high availability, right? And in case anything happens, you're running in multiple availability zones, which an availability zone is like a collection of data centers, right? So now you're spanning across 2 collections of data centers essentially, right? And within that, we have to create a load balancer. So I'm going to draw a picture of a load balancer that looks like this. This is going to build a load balancer. It's also going to build an internet gateway to ensure that our traffic, if we need to, we're running in a we want to have traffic coming in from the internet to our front end service. That'll happen through the internet gateway to our load balancer. Now, again, this is just kind of the shell components. Once we start to deploy our services, so let's go down the path of our front end service, right? So our front end service, what do we need for that? We need a task definition, right? And that task definition is going to define how our containers are going to run.
Right.
Then we need to define that as a service. So we need like a service spec, a service manifest to set that up. And I'm so glad that I'm impressing Dave with my drawing skills here. It's
Frank Lloyd Wright. Wasn't he a photographer though? Wait,
he was an architect.
No, wait.
Yeah,
architect. Oh, yeah, but that would mean he's probably really good at drawing.
Yeah,
I'm bad with getting jokes. So my bad.
I lived in Arizona, and that was like Frank Lloyd Wright had a big influence there. So, anyways, so going back to this, so we've built our service definition, which points to a task definition. Now, I need to figure out, how do I get my service deployed? So Copilot's going to make sure that we meet the desired count, whatever that is. If the default's 1, we're going to have that 1 service. What color should I make this? Let's make this red. So I'm going to have my 1 service, which is going to be my container. So this is my front end service. In FA's example, this is my front end coffee shop application. So now what we need to do is figure out, how do I sync my front end service to my load balancer? To do this, we need what's called a target group. Now, this target group is basically defining, when I enter into the load balancer from the internet, or when I come in from the internet, what containers do I talk to? What services am I talking to behind this load balancer? So that is going to ensure that every time a task comes up, so if your tasks scale out and scale in, they're going to automatically register and then deregister from that target group, which is how the load balancer knows how to communicate with the front end services. So Copilot takes care of that. One other thing I didn't mention. Are y'all familiar with route tables?
Oh boy.
So this is another component that is equally as important when creating your networking, your VPC, is I need a set of instructions, which is a route table that tells me how to route traffic in my VPC. So if I have stuff running in a private subnet, I need a way to route that traffic out. And same with the front end. How do I route it out? Do I route through the internet gateway? What does that look like? So again, I'll tell you, my past life, as I've said it, and I was mocked for it early, I love being mocked. It's great. But I remember having an issue. Someone went in and modified a route table manually. And to figure that out it took me so long. And when I finally figured it out, it was crazy. I could have just probably looked in CloudTrail, but anyways.
Because like when you break a route table, it's oftentimes the traffic pattern is like, it'll work one direction, but the return direction won't work. and, figuring out like, yeah, okay, everything looks fine. I ping here, I see it happen over there. That means it works, right? Well, no, not always.
Not always.
My favorite is asymmetrical routing, where it goes up one path and then like down the other path and doesn't
right.
actually.
Yeah, the kernel is like, what's this? I didn't ask for this.
Oh my goodness. But it's just another component, right? That you have to, if you weren't using something like Copilot, you have to build and think about, right? Or,
right.
With CDK, you're using high level constructs. Oftentimes, a lot of these things are built into those for you to simplify.
Did I miss it? Have you drawn the security groups for this
No,
yet?
Brent, that was next. So,
okay, my bad.
Nope, that's okay. So that's my route table, which again defines, my routes, how they work in my VPC. Security groups. So this is another thing. In order for my load balancer to talk to my front end service, we control that with a security group. What about my front end service? Now that I introduce a back end service, how are they talking? Well, they're talking over service discovery. So I'm going to draw another service discovery here.
And that happens in Route 53.
In Route 53, right? So it's creating a private namespace for me. And also, it's ensuring that when a new service comes up, it's going to automatically register into the service discovery namespace. Now, generally, ECS has great integration with CloudMap, which is our service discovery service. So that's built in. But again, this is done for me. I don't have to think about this. How do I control access between the front end and the back end? I need security groups. The last thing I want to mention, and I'm sure there's actually more, I shouldn't say the last thing, but what about when I need to deploy?
It's early. You can't say the last thing already.
Right? I just keep saying the last thing until I just keep going. What happens if I build or have like a database here? This is this is a database. Or this is like a DynamoDB table, let's say. DynamoDB. Okay? Actually, that doesn't live in the subnet. Forget that. But so I have a DynamoDB table. The way I talk to DynamoDB is through IAM, Identity and Access Management. This is how we have the authorization to communicate from a service, a task, an ECS task, to that table. We need to assign an IAM policy to a role and attach that role to our task. Copilot manages that as well. So if I do a storage init, it's automatically going to give me those permissions and just take care of them for me. So I don't have to, manage any of that. So again, and that's through IAM. So Copilot has created all of this stuff in this beautiful diagram. And all I had to do, or going off of what FA did, FA had code. He had a Docker file. And that was it. And a Git repo. So just to show really all the complexities that are built in when having to think about this on your own, you kind of have to know what you're doing down to the kind of the root level of, or the assembly as we say. And Nathan says that a lot. And I don't know if he was the first person to say it, but I love that that comparison. So this is really like all the assembly code and logic is here. All I have to do is give Copilot those two things, and the rest is built for me.
So when I see this, I look at it and I think of all the infrastructure as code, different languages that I've worked with in the past. And I think to myself, okay, now if I have to go build this in CloudFormation, I'm going to have a bad month, right? It's going to take me a long time and a lot of trial and error and a lot of I'm going to get so many things wrong. I step it up a notch and maybe I use Terraform, and Terraform is easier. It's easier for me. It's easier to write. It's easier to read, but there's still a lot of components that have to be built. But Terraform does have modules, and so maybe some of this could be handled with modules. but then step it up another level and you have the CDK. Nathan, talk to us about, like, you know, how would you build this at a high level using the CDK?
The CDK would be a bit easier. A lot of these things, like the entire VPC with the route tables and the availability zones and everything, would actually be one line of code. You would still need to connect a few of these pieces together. But I would say the CDK is maybe a step below the abstraction level of Copilot. Copilot is very focused on the application first. CDK puts a little bit more control in your hands, but also a little more complexity.
Yeah, totally. You still kind of need to know what you're building when you're using the CDK. And then, like, I completely agree with you. One more level higher would be Copilot. And people have been asking in chat, and they ask, outside, they're just, should I use Copilot? Should I use the CDK? If I'm using one, should I switch to the other? And we talked about this in the hero panel as well, but, use what you're most comfortable with. But when I start, my starting point is actually Copilot. And it's because I don't want to have to upgrade my libraries or make sure I'm on the latest module, or like I want to hand off ownership of as much of this stuff as possible. And then if I can't fit into the Copilot model, that's when I go explore the CDK, because it's still going to give me a ton of convenience, but I'm going to still end up owning it. So, I'll trade. I want convenience. I'll take on ownership as long as I can keep some of that convenience. And that's kind of my decision making for when to choose the CDK. You're on mute, Adam?
I am on mute. Thank you. One other thing that we didn't talk about was the scheduled jobs with Copilot. So this is one area that Copilot has, again, a lot of power, where if you just want to run something on a schedule, you want to run your container on a schedule, but you want retries, you want insight into that, Copilot has this scheduled job functionality that basically will build a set of step functions for you that will run your job with retries on whatever interval you've set, and it's managed in step functions, so you have retries and a lot of really nice functionality built in. So just another piece.
Can you take a step back and just describe what are step functions? I think we might have some people in the audience who have never heard of that before today.
Yeah, so so step functions are a way to basically design a workflow in AWS. Usually it's with, I feel like I should pull up the documentation to give the exact, but it's essentially a way to build a flow, and then you can use step functions to have use their built-in retry functionality, to have the logic of the and or functionality can live in step functions. So you just write your code and you can rely on step functions to handle the retries, the decision logic, the decision tree based off of what you see fit. So it's a nice way to visually walk through that a workflow and see exactly those steps and how you want to orchestrate them.
Nice.
So
nice. So Volek the Dwarf, I popped it up on screen a second ago, but he had a great comment. I think of abstraction as a trade-off. Each level you give up control for reduction of operation effort and speed to happy path. So every level you're turning over. I don't say give up control. I say turn over control. But you're turning over stuff that you don't care to manage in order to gain speed to get to, I like your use of the phrase here, happy path. It would be helpful to know what you're trading off for each level of abstraction. And then Nathan, he mentions he's written a blog on this already. So definitely, if this is something that interests you, check it out. You can find it on the Containers blog. and it's general availability of ECS services extensions for the CDK. So if you don't know this already, Nathan was instrumental in getting the ECS extensions out to the CDK, and he's been fantastic for that.
Absolutely.
All right. Do we have any other questions? Oh, when will CDK support dynamic scaling of ECS?
So, not sure exactly what you mean by dynamic scaling. If you're referring to scaling the services up and down, it does support that. Obviously, if you want to scale your EC2 cluster, you have to create a couple other constructs yourself. But yeah, you can already do a lot of scaling stuff in CDK.
That's what I was thinking too. Yeah.
Yeah, actually, the next segment is actually more about scaling, going into more detail. So I don't want to spoil everything already.
That's a nice tease there.
Oh, right. Yeah. You're up next, and the whole thing is about scaling. So definitely stick around for that. Have y'all seen any other questions pop in that I've missed? Or do you have anything else you want to cover?
I mean, I think, I think we addressed quite a bit. I mean, I think that there was that question of, there's just funny comments in there too. Like, how many containers does it take to change a light bulb?
Depends on if it's blue or green.
Yeah, but yeah, great comments in the chat and great questions. I would just say, if you have questions, you can reach out to us on Twitter. We're here to help, and we want to chat with everyone on what they're doing and how we can help. So feel free to reach out to us on Twitter.
Awesome. All right. So up next, we actually have Nathan Peck talking to us about ECS scalability and best practices. So stick around, and we'll be right back in a couple minutes.
Moving your business to the cloud means having a vision. Owning that vision and bringing it to life means building a plan. As you build yours, it's worth remembering, modernizing your business to innovate requires investing in your people. Through cloud training, you build skills across your organization to embrace a change, a new operating model, a new mindset. You can deliver the business promise of your transformation when your workforce is ready. And that's the vision of AWS training and certification. Our comprehensive training can help your workforce innovate faster, accelerate cloud transformation, and give your business a real competitive edge. It helps inspire personal growth while driving organizational growth. It creates a culture of continuous innovation to attract and retain talent. It brings new thinking and even more opportunities for fresh ideas to flourish. Developed by the experts at AWS, our flexible training options are designed to meet the evolving needs of modern business. You give your team the vision, we'll give them the cloud training to bring it to life. Lead through learning. AWS training and certification is how.
AWS Activate is an exciting free program designed to help startups get started and grow their business on AWS. Take your business further with free AWS credits, support credits, training, exclusive offers, personal content, and more. Applying for AWS Activate is easy and only takes a few minutes. If you don't have an existing AWS account, you can create one for free. Then you're ready to apply. To begin, simply go to the Activate website and click on Apply Now. From there, you'll be prompted to sign into your existing AWS account if you're not already signed in. If your startup is self-funded or funded through pre-seed, angel, seed, debt financing, or Series A, and you have an Activate Provider Org ID, select AWS Activate Portfolio. If your startup is self-funded and not associated with an Activate provider, go to AWS Activate Founders. Next, fill out the application form providing some basic information about your startup. And that's it. You're ready to submit your application to AWS Activate. Once approved, AWS credits and AWS support credits will be added to your AWS account. You'll also receive an email from AWS Activate highlighting all your new benefits. So, sign up to apply for AWS Activate today and take your startup to the next level. For more information, visit our website.
Oh, you're on mute, Nathan.
Welcome back, everyone. As Container Day continues, we're now going to talk about Amazon ECS scalability best practices. My name is Nathan Peck. For those of you who may not know me, I'm a senior developer advocate at AWS in the Container Services organization. And prior to that, I was actually an Amazon ECS customer. So in total, I've been using Amazon ECS for almost 6 years now and have done quite a bit of scaling on top of Amazon ECS. So today I want to share some of the tips and things that I've learned over the years scaling ECS services. So the first thing I want to start out with is really a quick look at how to think about scaling with containers on Amazon ECS. And what I'm going to introduce is that in order to have good scaling, you have to have an application scaling mindset. And it really will carry through to everything else that we talk about scaling on Amazon ECS. So to set the context, let's start with how scaling was traditionally thought of when it came to scaling, and that was all around the VM instances. So traditionally, you would have a data center and you had virtual machines inside of it or physical hardware. And if you wanted to horizontally scale to have more capacity, you would launch more VMs or add more servers to your racks. And if you wanted to vertically scale, you would launch a larger VM or you would put a larger server into the rack. Now, there was a problem with this type of scaling, and that's that when you scale based around instances or servers or VMs, it really expects that the application is always going to adapt to whatever instance that it's on. So here, for example, you see in this diagram, we have an instance which has 8 CPUs and 16 gigabytes of memory. But then you have an application that is actually only using 2 CPUs and 6 gigabytes of memory. So there's a mismatch between the amount of resources that the instance has and the amount of resources that the application actually needs. So that leads to the problem that applications oftentimes don't have enough load to fully utilize the instances that they're running on. You see this when you have an application that maybe doesn't receive enough traffic, maybe occasionally it bursts or have more traffic, but it doesn't always have enough traffic to actually fully utilize a server or a VM. So all of that white space in these diagrams is actually being wasted. You can see that only a small fraction is being utilized. So one potential solution to this problem is to combine applications onto instances so that you can get better instance utilization. So here in this scenario, we're seeing 2 different applications, the orange application, the blue application, have been put together onto the instance. And as a total, we now have a more reasonable 50% CPU utilization and 75% memory utilization. So that's not bad, but we still have some problems with this setup. So earlier I said that maybe applications occasionally have a burst of activity. Well, when that happens, what we end up with is applications competing with each other for the resources that are available on those instances. So here we see an overlap between how much CPU the blue application and how much CPU the orange application actually wants. And because of that, they're competing with each other for that limited CPU resource. So containers were created as a solution to help you configure limits per application so that you can put multiple applications onto a server or into a VM, and they wouldn't compete with each other. Each of them has a boundary around the resources that it needs to reserve on that instance, and that way it won't compete with the other services when there is actually a resource constraint and both of these applications are demanding high levels of resource. But once you start to put a box around the resources that a particular container requires, you start to realize that in this scenario, the VM is no longer the unit of scaling. Instead, the application container is the actual unit of scaling, and the resources that that application container needs is what we're scaling up and down on. So this is what I mean by having an application-first mindset to scaling. And container orchestration is something that helps you enable you to have that application-first mindset. And the reason why is because it allows you to focus on the application by treating the instances and VMs underneath as generic capacity. So here's how that works. When you have an orchestrator such as Amazon Elastic Container Service, you can specify your application that you want to run and the resources that are required, such as 1 CPU and 2 gigabytes of memory. And then you can specify how many copies of that application you want to run. Then separately, you can also give Amazon Elastic Container Service a collection of EC2 instances to use as capacity. These EC2 instances don't have to be all the same size. They don't even have to be all the same generation. They don't have to have the same amount of CPU or memory. They can just be a random collection of devices and CPUs and memories. And you tell Amazon ECS, I would like you to run these many copies of my application, in this case, 4 copies of the application, on this collection of EC2 instances. And what it does is Amazon ECS looks at all of the available capacity from all of the servers that you've given to it, and it finds a solution to place containers across those EC2 instances to fulfill your overall request. So here, there's 3 different types of applications of different sizes that we've told ECS we want to run on this collection of 4 instances. And you see that it's found a solution to place these applications onto the instances in a way that they'll fit and be able to share the resources without overlapping with each other. So this is really the job that the ECS does. It allows you to start thinking about scaling as, let me think about the applications first, and just think about the capacity, the servers, the VMs as capacity that I provide under the hood, but I don't have to worry about it as much anymore. So added to that, there's a new paradigm as well, the serverless container. And AWS Fargate is a prime example of that. AWS Fargate lets you run containers directly. You no longer have any EC2 instance to worry about. So with Fargate, what happens is you say, here's my application container that I want to run. It takes 1 CPU and it takes 2 gigabytes of memory. And I would like you to run it. And Amazon Elastic Container Service actually goes to AWS Fargate and says, I would like you to run 4 copies of the container. So then AWS Fargate runs those containers directly. It doesn't have to have EC2 servers anymore added to the cluster. The way that works is AWS Fargate launches each of the containers that you want to run into its own isolated micro VM. And that micro VM is actually sized specifically for the needs of that container. So here you see, rather than having large EC2 instances that have a larger boundary and multiple applications within that boundary, instead you see each of the application containers has its own micro VM that's sized perfectly for that container. So with this new serverless paradigm and with the existing capabilities on EC2, we have a new way to think about scaling. And that is, you don't think about scaling in terms of VMs or EC2 instances. We think about scaling as an application-first operation. So there's 2 types of scaling that we might think about. The first is vertical scaling. Vertical scaling is when you want to increase the size of an application container to give it more resources. And the second is horizontal scaling. That's when you want to run more copies of the application container in parallel in order to do more work. In general, vertical scaling will often allow the application to serve a request faster, and horizontal scaling will, in general, allow the application to serve more requests overall because they're distributed across more copies of the application. So we're going to talk about these 2 categories of scaling, starting with vertical scaling. So with vertical scaling, there's 2 ways to think about it. One way is think about it as improving the quality of service for that particular container. And the second is how much work can that particular container get done. Vertical scaling allows you to have more work per application container. So when I want to vertically scale my application, the first step is that I need to identify what resources the application container actually needs in order to function. And there's different dimensions that these resources might go on. So here, for example, you see CPU, memory, storage, network bandwidth, and some machine learning workloads may actually require GPU as well. So all of these are independent dimensions along which the application may require a certain amount of that particular resource in order to function. So first step is making a list of all of those resources that you think the application is going to need in order to function. And then the second step is identifying how much of that resource is needed to define this performance envelope within which you would expect the application to function well. And the goal of that performance envelope is actually to define constraints for the container. And with that envelope, we can make assumptions such as if demand for a particular resource exceeds the envelope that I've defined, then I know application performance is going to suffer. So in this case, we define the envelope for the application, but we see that the application's real demand for CPU has exceeded the envelope. It's outside of the envelope. And at this point, I would expect that the application should be impacted. There would be perhaps slower response time. There might be errors. There might be timeouts. Something bad is going to happen if the performance envelope is exceeded. But how do you actually figure out the right performance envelope for an application? So there's two key tools that you can use. The first is load tests. So with load tests, what you do is you send requests to your application, and you want to send a lot of them in order to stress the application. There's a couple different levels of load tests that you can use. One thing that I really like to start out with is a simple tool like Apache Bench or Hey. With these tools, what you can do is you can just point them at the domain for the application and send pure HTTP requests to a particular endpoint and measure how many concurrent requests you can send out and how many requests overall over a certain period of time. But in the long run, I found that if you really want to load test your application, you need a little bit more than that. You need a way to actually simulate real user agents using your system. And what I mean by that is, if you think about how a real user uses a system, they often sign in, they sign up, they sign in, they start creating resources in the system, maybe they edit things, they delete things, they make real API calls that mutate data, that call out to databases. You can't truly load test a system using plain HTTP requests to like a web server. You have to actually simulate the real API requests that a user would make. And so what I found is that load tests work best when you think about it as how many of these real user agents can I spawn? And you create a script which simulates a real user navigating the application, doing all the steps that a real user would, from signing up, signing on, and making real API calls. And then you see how many of those user agents you can run concurrently inside of your load test. So once you have those load tests started, you need to measure the results of the load test, and that's where metrics comes in. So ECS comes with default CloudWatch metrics that you can use as a starting point. It will gather up statistics on how much CPU and memory the application might be using at any given point in time. And you can also optionally enable deeper level of metrics with Container Insights. So Container Insights is going to gather up stuff like networking I/O, and you can also optionally add CloudWatch agents to gather up stuff on disk I/O and any of the other dimensions that you might have inside of your performance envelope. But what you're going to want to do is gather up all these metrics into some place where you can graph them, especially graphing them over time as a load test starts out and a load test ramps up gradually. We want to start with a low level of traffic and then gradually increase it to the highest level of traffic that we expect the application is probably going to break at, and see how those metrics function over time as that load ramps up to the max. So when you do that, you're going to get some interesting graphs that you can use as a learning point to figure out how your application is performing and scaling. And let's look at some of those graphs. So here's an example graph of metrics over time as a load test ramps up. And so we can see that these metrics are for CPU and for memory. And we see that one of them is much higher than the other. And it kind of flattens out at 100%. So that means that we ran out of that resource first. That resource actually reached the max of 100% CPU that we were actually able to get out of our compute infrastructure, and we never max out on memory. So what this is telling us is that the workload is primarily CPU bound. It's a type of workload that consumes more CPU than it does memory. And so as requests come in, eventually the CPU becomes completely saturated. It's unable to answer requests, and the quality of the service probably suffers at that point, but we never actually run out of memory. So this tells us one micro optimization we might be able to make is considering in the performance envelope, perhaps add a bit more CPU and a bit less memory, because we're not actually reaching the point where we're utilizing the memory as much as we are the CPU. Here's another type of graph you might see. So this one looks weird. It looks like the CPU is actually going over 100%. It's going up to 125%. So what's going on here? Well, this one is actually specific to EC2 instances. You won't really see this in Fargate, but you will see this if you're running on a EC2 instance, or if you're running maybe an ECS Anywhere instance on premise. So by default, Docker allows a container to utilize spare CPU capacity on the instance as long as that capacity isn't needed for something else, isn't needed for another application running on the box. So what that'll show up as is CPU consumption actually going over 100% up to 125%. In some cases, I've seen even in extreme cases like 400% CPU utilization. Now, this is a danger sign. It's a warning sign, because it means that your application may have been functioning pretty well during the load test, but it was actually only functioning well because it was using this spare unreserved capacity within the cluster. And what's going to happen is if you add another application, or if you try to horizontally scale by launching more copies of your application, now there will actually be something that wants to reserve that CPU utilization that's currently being burst into. And that CPU utilization is currently being used for burst capacity is going to go away, actually. And then the service will actually be forced to go from 125% down to 100%. So this is a dangerous situation, because it can actually cause a situation where your performance initially seems to be good, but then as you scale to try to fix a performance issue, your performance will actually tank. It will get worse initially as you scale, because of the fact that the service was only functioning properly on burst capacity. So be careful when you see this. This is a good sign that you may need to adjust your scaling policies to react faster, or to be more responsive to scaling, so that way you don't go too far over into burst territory, because that can go terribly wrong. So here's another type of scenario. This is burst being used properly. So in this scenario, I see that when the application starts up, it needs to do an initial bit of work. Maybe it needs to download some files. It needs to do a little bit of setup work before it can start really processing requests. And so it initially bursts to 125%, but then it settles down to below 100%. This is good. This is what I want to see. This is containers using the burst capacity efficiently, but not relying on it for an extended period of time. And then this is another type of graph that you might see. You might see the CPU and memory utilization actually flatten out below the max. So here I see CPU is flattening out at roughly 75%. Memory is flattening out below 50%. But the response time for the application is actually skyrocketing. It's going up and up and up. So what's going on here? Well, there's some type of bottleneck in the application, and it's not the CPU and it's not the memory. There's something that the application requires. Maybe it's network I/O, maybe it's disk I/O, maybe it's another downstream service that is depending on, like a database or another downstream API. And the response time was actually skyrocketing because of that other resource. Most often this happens with a database. The database is overloaded because it's handling too many queries. So if you see this, this is not an issue that you can actually fix with scaling. I can't vertically or horizontally scale out of this scenario. I have to actually fix application code. So that might mean optimizing my database queries, It might mean optimizing the size of the downstream database that I depend on, or maybe optimizing disk bandwidth or network I/O in order to achieve scalability with my system. So keep your eyes out for this particular issue as well. And then this one right here is a classic that I've seen many times. As the load test ramps up, we see the CPU flattens out at roughly 75%, but memory keeps on rising, and it rises in almost straight line. So something is going on here. It's really bad. It's called a memory leak. And so in this scenario, every time the application is serving a request, it's actually keeping some data in memory, and it's not getting rid of that data. It's just accumulating and accumulating and accumulating it. And this type of issue, it cannot be fixed by scaling. You can't vertically or horizontally scale yourself out of a memory leak issue. What's going to happen is memory will keep on rising until it reaches a point where it consumes all the memory. The application will crash at that point. The only way to fix this is to fix the application code. You cannot have scalability with this type of scenario. So keep your eye out for that, because this is something where you need to go back to application developers and say, we need to fix this, and we need to fix this fast. So the end goal of all of this load testing and metric analysis is to create a performance envelope that fits your application needs. And ideally, it also provides a little bit of extra space for occasional bursts of activity. So maybe you know that occasionally there'll be a burst of traffic, or the application will need to work on one particular transaction that is heavier than the others. Like, let's say a user logging in and it needs to hash a password. There's a couple of things to keep in mind as you're defining the performance envelope. The first is that there is no such thing as a standard size for an application. A lot of times people come to me and they say, Nathan, how big should my application be? Is 1024 CPU enough? Is 2 gigabytes of memory enough? And what I tell them is, don't think about it as standard sizes, because there is no such thing as standard size for an application. Each application that you run has its own needs and its own performance envelope. Some may require more CPU, some require more memory, some may require more network bandwidth, but you need to find a unique performance envelope for each application. Don't try to stuff every container into the same performance envelope. And the other thing is, these performance envelopes can change over time. So as you add features or modify how features work to optimize things, the performance envelope may change. So here we see application A version 1 has high network bandwidth needs. But then in 1.01 version, the network bandwidth actually was reduced because we had this new feature to gzip the responses. So we're compressing the responses as they go out of the server. And that reduced the amount of network bandwidth that was needed before, but it increased the amount of CPU. So a lot of times as performance envelopes change, you'll need to adjust the different resources that are available. Additionally, as you migrate to new EC2 instance generations, you may also need to adjust your performance envelope. And let me explain why. If you look at the C4 instance class compared to the C5 instance class, EC2 instances, the C4 instance actually has a 2.9 gigahertz processor, while the C5 has 3.6 gigahertz sustained processor speed. So in that scenario, an application, as you migrate it from C4 to C5, may not actually require one whole CPU anymore, because the new CPU is actually much faster. Maybe the application now only needs 75% of the CPU. So the key thing to remember between the performance envelope of the application changing with feature releases and new EC2 instance generations is that load testing, it has to be ongoing. You can't do it as a one-time thing and then say this will be static forever. You have to consistently be load testing and adjusting and tuning the vertical scaling. I want to talk a little bit about vertical scaling limits before I move on. And the vertical scaling limits is going to define how far you can vertically scale. So with ECS plus EC2, it's fairly flexible because you can create any arbitrary task size that'll fit onto the EC2 instance. And when it comes to storage, you can adjust the EBS volume attached to the EC2 instance in order to adjust the scaling of the storage. For ECS plus AWS Fargate, there is a different limit. So for CPU, the lowest you can go is 1/4 of a CPU, and the highest you can go is 4 CPUs. And half a gigabyte of memory or up to 30 gigabytes of memory. And then ephemeral storage can be up to 200 gigabytes. So keep in mind these vertical scaling limits as you consider the platform that you want to use for compute. But at this point, let's talk a little bit more about horizontal scaling now. So with horizontal scaling, the goal is to have more application containers to spread the work across. So we've already found a good performance envelope for vertical scaling, but now we want to spread more of that work across more containers. So in general, horizontal scaling should always be based on aggregate resource consumption metrics for the service. And as the resource consumption metric reaches a certain threshold, we say the resource consumption is too high, so I want to scale out by adding more tasks. Or if the scaling metric is too low, we say it's too low, I want to scale in by shutting down some tasks. So ECS integrates with application autoscaling to automatically scale your service. It takes the aggregate metrics for the service, the aggregate metrics trigger an application autoscaling policy, and then ECS responds to that policy by adding or removing tasks according to what the policy asked for. Now, one pitfall I want to highlight that's very important is to evenly distribute the workload across your tasks to avoid hot tasks and cold tasks. I most often see this happen with WebSocket requests or other applications that have really long-lived connections that serve a lot of work over a long-lived connection. What can end up happening is you have one client or one connection that is doing a lot of volume over the connection versus other connections are much lower traffic. And what that ends up with is you end up with hot tasks that are hitting the resource limits while other tasks are underutilized, they're cold. And the danger there is you can end up with aggregate metrics that still look good. It looks like the resources are within bounds, and it doesn't look like there's any need to scale, but the reality is behind the scenes, some of your tasks are extremely hot and they're suffering. So for HTTP in specific, make sure you use a load balancing ingress that will evenly distribute the traffic across the containers that are available. When this is working properly, what you'll see is all of the containers will actually be roughly in sync with their resource utilization, rather than having some that are hot and some that are cold. So horizontal scaling, it should be based on the resource that the application runs out of first when you load test. And with most runtimes and web workloads, what I found is this is almost always CPU. There are some exceptions. Sometimes it's network bandwidth. But in general, most applications run out of CPU first these days. So let's talk about a couple alternative ways to scale. So this is a current one. Like, why not scale based on number of concurrent requests? So this can work well when you're first starting out, and in fact, it's something that we have built in as an option inside of AWS App Runner. And the general strategy is let's start with the number of requests per period at the load balancer, and let's take and divide that by the number of requests per period that we think a task can handle, and then that'll give us the number of tasks to scale to. So this scaling approach, like I said, it can work at small levels, but as you scale out, I would not recommend this approach. As you move on to managing your own infrastructure, you're going to realize that this scaling approach assumes that all requests are equal, and that's not true. Oftentimes, especially if you have a monolithic application, you may have some requests that are orders of magnitude heavier in terms of resource consumption than others. And this also assumes that app performance per request doesn't change over time, and that's also not true. There are situations where as the number of requests increases, the performance per request actually decreases. So in some cases, as the database becomes more burdened, or as even as programmers actually change the code that executes when a request happens, they may optimize something, or they may introduce a new feature that introduces a performance issue. You end up with a situation where your scaling for a number of tasks to scale to doesn't work anymore. And this situation can go bad really quickly. So I wouldn't really recommend this if you have large scale, unless your application is extremely stable, you have microservice environment that everything is super uniform. Let me highlight another pitfall for scaling, and that's scaling based on response time. So this is also not a good metric to scale on because response time isn't necessarily linked to the application, and scaling won't necessarily fix the response time. So in particular, if you have an inefficient code path or a really large request that takes a long time for some reason, that can skew your overall response time and make it look like you need to scale when you don't actually need to. Conversely, you may have performance issues, but you're serving a bunch of really light requests that respond extremely quickly. And these light requests bring down the average response time and make it seem like performance is good when actually you have performance issues. And then finally, you may have a downstream service or database that's overloaded, and it's contributing to really long response times. But if you were to respond to that by scaling out the application tier, it won't help the situation. In fact, it may actually make it much worse by launching more copies of the application connected to an already overloaded database. So this can also be a very dangerous metric to scale on. So you should always scale based on the metric for the real resource that your application runs out of first. And when it's working properly, you'll see basically a sawtooth. It goes up and down. When it reaches the high point, a new task gets launched and it reduces the aggregate utilization. If it reaches too low, it'll stop a task and it'll go back up. Always give the service a little bit of headroom in case there is a burst of activity and your scaling can't respond fast enough. Now, there's three different types of horizontal scaling you can use, three different types of strategies. The first is a target tracking policy. So this is the easiest type of scaling to set up. You give it one number and you say, try to keep the aggregate resource consumption near this number. And it'll scale up and down automatically to try to keep it close to that threshold. Downsides is this can be a little bit slow to respond sometimes, and also expects that your resource utilization metric is going to respond proportionally when you add and remove tasks. That's not always the case. The second type is step scaling. So with step scaling, you define your own custom bounds and you say, if the resource consumption reaches this level, add this many tasks or this many percentage of tasks. If it reaches this level, remove this many tasks and this many percentage of tasks. So this is great for giving you the most control over how your infrastructure responds to scaling. And then the last type is schedule scaling. So with this approach, you specify specific times during the day that you would like to scale up or scale down. This is great for predictable traffic patterns like batch traffic overnight, or services are only used during work hours, but it's not good for handling unexpected traffic spikes, and it's not good for gradual traffic trends, like if you're still signing up lots of new users and your traffic is gradually increasing over weeks or months. So we talked about horizontal scaling, we talked about vertical scaling. Let's talk about the cluster capacity scaling, because as you launch more containers, what you're going to need is you're going to need more compute capacity to actually run those containers. So the first thing is to know is that AWS Fargate makes cluster capacity easy. With AWS Fargate, you don't have to worry about EC2 instances and how much capacity. Instead, you just get tasks running automatically. And there's two limits you should be aware of, though. The first is that there's 1,000 on-demand limits, on-demand tasks, and 1,000 spot tasks by default. But this is a soft limit, so you can talk to support if you would like to have more AWS Fargate tasks running. And then for EC2, it's a little bit more complicated. You have to actually launch EC2 instances to host your tasks on. And the default limits are like this: 2,000 EC2 instances per cluster, 5,000 services per cluster, and 5,000 tasks per service. So yes, that does mean you could actually technically launch 25 million tasks per cluster on ECS on EC2 without opening a support ticket. Now, if you do need more than that, you need more instances probably to run 25 million tasks. These are soft limits, so you can open a support ticket to get these limits raised even more. The last thing I want to introduce is capacity providers. So this solves the problem of how do you manage the EC2 capacity for your container workload as you scale the number of containers up and down. ECS actually comes with capacity providers out of the box, Fargate and Fargate Spot. You can just associate them with the cluster if you want to launch tasks. And you can optionally create EC2 capacity providers that launch EC2 tasks automatically when needed. So the way they work is capacity providers track the total reservation by all the different types of application containers that are launched in your cluster to come up with a total reservation metric. And it tries to keep that reservation metric within bounds that you specify. So here's how that works. I tell ECS I would like to run 10 copies of my container, ECS says, okay, I'll launch those 10 containers. The capacity provider says, I see that the cluster reservation is exceeding 75%. So I calculate that I'm going to need to launch 2 more EC2 instances in order to maintain a little bit of headroom inside the cluster. And then it talks to the EC2 auto-scaling group to actually launch those 2 more EC2 instances. So remember that your target capacity could be any number between 0 and 100. But in general, you want to keep enough EC2 instances so that the overall reserved capacity doesn't get too far up below or above. And you want a little headroom in case there's in case you need to scale up quickly, or you want to do a deployment and roll some tasks over. Capacity providers, they also manage the cluster scale-in. So if I have tasks running on an instance, it'll lock that instance and say, don't stop it. Only stop an instance that is currently unused and doesn't have tasks running on it. And last but not least, you can have multiple capacity providers. So here I can say, I would like to run 6 copies of my container and distribute 3 to Fargate and on demand and 3 to Fargate spot. So the way this works is you can specify a base and a weight. The base is the initial baseline number of tasks that you want to place into that capacity provider. And then the weight is, once the baseline has been filled up, what's the ratio that I want to distribute to different capacity providers? So here's a couple examples to better explain how that works. So here's a strategy to fully utilize my reserved EC2 instances first. So I put those EC2 instances that are reserved into one ASG, auto-scaling group, and I say, launch 50 tasks, so 50 base on this provider, and then the weight of 0. So stop putting new tasks on this above 50. So that'll fully fill up that EC2 auto-scaling group. But then I say, after that, utilize this other EC2 auto-scaling group, base of 0, weight of 1. So don't launch any tasks on this provider initially, but then after that, launch 100%, 1 out of 1 of every new task on this provider. Here's another strategy. If I want to minimize the cost of traffic bursts. So I say, I would like to launch a base of 100 tasks onto a Fargate on-demand capacity provider. And then above 100, launch 1 new task for every 3 spot tasks. So here, we're initially going to launch 100 on-demand tasks. And then above that, we're going to distribute 1 task to on-demand and then 3 to Fargate spot. So this will allow me to increase the quality of my service as I scale up at a discounted rate by launching 3/4 of it actually onto Fargate spot instead of on-demand. So just to summarize everything I went over, some things to remember. First of all, scaling container deployments, it has to start with an application first mindset. Second of all, use load tests to identify the right performance envelope for your service. And then third, when you're doing your performance tuning, it's not a one-time thing. Plan to keep the performance envelope updated as you add features, optimize code paths, and as you upgrade the compute infrastructure that you have underneath in your platform. And then third, for horizontal scaling, base it on the aggregate resource metric that your application runs out of first when you're load testing. Your goal is to keep a sawtooth that keeps that resource utilization metric within reasonable bounds. And then when it comes to the capacity to actually horizontally scale onto, default to thinking about using AWS Fargate first if you want that easy, worry-free capacity. If you do want to manage EC2 capacity more yourself, ECS Capacity Providers is there to save the day and help you launch the correct number of EC2 instances as capacity to run your containers across. So I know this has been a whirlwind of scaling tips. So if you have further questions, you can chat with me on Twitter at Nathan K. Peck.
Awesome. Thank you, Nathan. That was a ton of great information, and we got a lot of really cool comments in the chat as well. So I think there's a lot of good takeaways. So up next, we're going to have Aaron join us, and he's going to talk to us about AWS Proton and how it's being used today. So hang with us, and we'll be right back.
Hey, it's Adam and Brent, and we wanted to let you know that if you're looking for more live or on-demand container content, you should subscribe to our YouTube channel.
Head on over to youtube.com/containersfromthecouch and also check out our website at containersfromthecouch.com. Thanks.
Thank you. Good.
Yeah, I think
You
that was
feel good about it?
Yeah,
All right.
I feel pretty good.
Containers let you package your code so it can run anywhere. Before, you had to provision and manage servers, often requiring complex infrastructure to run your containers. With AWS Fargate, you can now run serverless containers, so you don't have to manage any servers. Fargate can quickly launch tens of thousands of containers and will seamlessly scale to meet your application's compute requirements. Live the Zen life and let Fargate take care of your containers so you can build powerful apps today. Learn more at aws.amazon.com/Fargate.
Feeling stuck to your old guard database provider with big price tags, high lock-in, and punitive licensing terms? Break free with AWS Databases, giving you the scalability, performance, and availability of commercial-grade databases at 1/10 the cost. AWS Databases are fully managed, giving your team more time to build applications. Hundreds of thousands of customers have saved time and costs by moving to AWS Databases. Join them. Gain database freedom at aws.amazon.com/databases/freedom.
Startups at every stage face challenges, whether it's finding the right technical guidance, building or scaling their business, or balancing time and resources. With so much to accomplish, startups need an easier way to find the right resources for their specific needs. Introducing the AWS Activate Console. The Activate Console is designed to help you through every step of your startup journey. With the console, you can explore the recommendation feed, which delivers personalized content just for you and your startup. By matching the most relevant content for you based on your startup profile, interests, and usage of AWS services, the recommendation feed saves valuable time by bringing the right resources directly to you. The console also features a built-in cost and credit summary, providing visibility into your AWS credit awards, balances, and bills, so you can make informed decisions while maximizing your AWS credit spend. With an added notification feature to alert you of pending credit exhaustion, you're always informed and in control. You'll also find the Tech Hub, which provides real-time updates on the health of your AWS environment, recommended AWS support services, and links to AWS technical support, so you can solve your tech problems quickly. Plus, the console showcases a wide variety of exclusive offers, discounts, free trials, and other startup-friendly perks from trusted organizations and software vendors that can add valuable tools to your startup. With the AWS Activate Console, you'll have the resources and tools you need to build, launch, and grow your startup on AWS, all in one place. Take your startup further. Experience the Activate Console today.
All right, welcome back. And joining us now, we have Aaron Wishnick. And Aaron, tell us a little bit about yourself.
Sure. Yep. I'm Aaron Wishnick. I'm a software engineer here at Amazon. I'm based out of the Seattle office, and I helped to launch Proton, which we launched at last year's reInvent.
Nice. So I understand you have a presentation. You want to talk to us about Proton.
That's right.
Sweet.
All
Already
right.
with the jokes in chat, by the way. AWS Proton pairs nicely with AWS Neutron and AWS Electron.
There you go.
I like to say Proton's keeping it positive.
There you go. I like that. I'm going to use that now. All right, great. So yeah, today I'm going to be talking to you guys about how we built AWS Proton. As I said, we launched at the last reInvent. We went into preview. So give you a little bit of an overview of the talk. I'm going to talk about the challenges that we face as cloud users. Then I'm going to give a brief introduction to AWS Proton as a product, and then how we're trying to address those challenges. We're going to spend the bulk of the time deep diving into the actual architecture of the system. Finally, we'll discuss some upcoming features, and then we'll do Q&A at the end, but also, you know, as it's been going today, just go ahead and put your questions in and we'll try to address them as they come in. So what are some of the challenges that we're seeing in the cloud today? Cloud sprawl is a major one. Within AWS alone, there are over 200 services, and there's so many more outside of AWS. So keeping a well-maintained cloud is definitely a challenge. And then related to that, with all those options, it's really easy to find yourself in analysis paralysis, weighing all of your different options that you want to choose to solve your problems. And we're seeing actually that organizations are spending a lot of repeated effort on analyzing for, you know, very similar projects that are going on within the organizations. And then once you've actually finished your analysis, you've decided on the architecture you want to go with, then it's time to actually start building that system. And, you know, we're seeing majority of people, they're provisioning their resources using infrastructure as code, but it can be really difficult to get that right. There's a lot of configuration, a lot of choices. And so it can be challenging to be confident that you've made the correct decisions, especially if you're working in a new space, which with the rate at which the space is growing, all areas of the cloud are growing. We're often working in new spaces. And, you know, tools like the CDK, that's made it a lot more pleasant to work with infrastructure as code. You know, you get all the nice higher level constructs that build things for you, but even still, you can end up writing a lot of code. For example, the CDK code for the AWS Proton product is several thousand lines. And then finally, application delivery isn't done once you've delivered it. It's an ever growing thing. The cloud's evolving every day. And so it's really important to be able to keep your entire tech stack in line with those advancements. So AWS Proton is a product that is aimed at addressing a lot of these problems and aiming to help you keep a well-maintained cloud. It provides organizations with the ability to curate a collection of blessed architectural decisions known as templates, and then also to keep track of the applications that are actually running those templates in a centralized location. So at a high level, templates are a combination of CloudFormation files in which you have actually extracted parameters out using Jinja templating language. And then there's a schema file where you actually declare those parameters for instantiating the templates. The engineers responsible for creating and maintaining these templates can not only share them with other engineers within their team, they can also keep track of who's using the templates. And if they make updates to these templates, they can either notify the users or they can actually just go in and update them, the users themselves. And then on the flip side, engineers who wish to use the templates now no longer need to concern themselves with CloudFormation at all. They simply provide those inputs as declared in that schema file that I mentioned by way of a much smaller YAML file known as the spec. Templates are split up into two different types. So there's services and there's environments. Services are most closely related to the application that you would be trying to build, like a web service. And then environments are where those services are deployed, and they may contain shared resources like a VPC or an ECS cluster. So that's kind of a really high level overview of the product. And we've done a few talks in the past that give a deeper discussion about it. And so we'll link to that in the chat. All right, so now let's take a little bit of a closer look at how all of this is accomplished. So as of today, AWS's Proton is made up of 3 microservices. There's the API web service, which is this one over to the left in this diagram, and that's primarily responsible for serving as the authentication layer, and then also as a proxy service to the 2 other backend services, which are in the top right, we have the template management service, and in the top bottom right, we have the template deployment service. And as the names imply, template management service, that's the service that's responsible for maintaining those templates that you're registering within AWS Proton. If you publish new updates, all that's happening within that system. And then on the bottom, that's the system that's actually responsible for provisioning those templates and interacting with your CloudFormation. And we're going to take a closer look at a number of these components, but a couple of things that I want to draw your eyes towards first. So we, in the past talk, we talked a lot about ECS Fargate. We're a big customer of ECS Fargate. All of our web services run in that. And then we also use Lambda for some of our asynchronous workflows. So we are a fully serverless application. Another interesting thing to note is that each of our microservices, they run in separate VPCs, and they also actually all run in their own AWS accounts. And we're going to talk in a second about why we do that. Data persistence, that's split across S3 and DynamoDB. And then finally, every service that we have is publishing information to CloudWatch. So as I mentioned before, each of our microservices is running inside of its own VPC and its own AWS account. And there are a couple reasons for this, namely deployment safety and the enforcement of least privilege. By isolating a microservice to its own account, it reduces the possibility that deploying to a service inadvertently impacts any of another service's resources. This could be something really simple, like accidentally deleting maybe a database that one service's CloudFormation stack is managing, but another service is directly relying on, or something more subtle, like maybe consuming account limits in a way that these two services that you want to be scaling independently now get coupled to one another. And then for the topic of least privilege, the concept of least privilege is that when an actor is performing actions inside of your cloud, they have exactly the permissions that they need and no more. And this is really important, especially when you're operating on customer data, which we are. And so, for example, if we look back to the diagram from the beginning, we had the template deployment system, which is responsible for provisioning those CloudFormation stacks. And that means that we, as AWS Proton, need to be able to assume a role into that customer's account. The template registration system, however, it doesn't need those permissions. And so there's a strong benefit to isolating that access to assume a role in a customer's account solely to that template deployment system. So that, for example, in the event of a breach, maybe in the template registration system, it wouldn't be able to take actions in the deployment system. And of course, we never anticipate a breach occurring, and we take all appropriate safety measures to prevent that. But part of security is making sure that you prepare for every possibility. So application deployments is a highly asynchronous process. I'm sure many of you are users of CloudFormation. You know, you click to provision a CloudFormation stack, and it can take minutes, hours. It can be a while. So it would make sense that AWS Proton as an application management system would have some asynchronous workflows. So we have two of them. We have the one for each microservice. For the template registration system, that's where when you provide a new template bundle to us, we're going to retrieve that template bundle from your S3 bucket, perform some validations on it, and then we're going to persist it in our systems. And then the other one is obviously the template deployment system, where we're compiling the spec file that I mentioned before that declares the inputs to a template, and we combine that with your template itself using Jinja, and then we provision that rendered CloudFormation template into your account. And then obviously, the workflow includes waiting for the provisioning to finish, and then retrieving any necessary outputs from the stack. And so both of these asynchronous workflows are implemented using step functions in Lambda. And I think I heard Adam give a brief introduction to step functions in a couple more talks ago. But just to reiterate, step functions is a fully managed AWS tool for declaring workflows. And so we really like it a lot. It's really easy to add, remove, change the order of tasks that execute within these workflows. And so, obviously code is ever evolving, and that applies to these workflows as we add a new functionality to it. And so we get a lot of flexibility with that, declarative way of creating these workflows. And then similarly, the lambdas, works well with that kind of development process. And then the last thing about our asynchronous workflows is that in general, asynchronous workflows can be more susceptible to failures than a synchronous call, and the fact that more time passes throughout the workflow for something unexpected to occur. And then when an asynchronous workflow does fail, it can cause resources to be left in bad state if the failure wasn't handled gracefully. And so to be able to handle any unexpected failures and attempt to remediate the situation, we have step functions publishing events to AWS Event Bridge, which is just like an event bus service within AWS. And then we then consume those events, we inspect them for specific failure scenarios, and then like a certain failure scenario we might be interested in is a deployment was going on, the workflow terminated in the middle of it, and the resource was still in an in-progress state. And then we would want to try and get that into some sort of terminal, likely a failed state. So as I mentioned before, data persistence is an important part of the application development, and we have two different types of data that we store within Proton. We have these files that customer provide us, either the bundles or the spec files. Those are stored in S3. And then the metadata about the various Proton resources. So, that could be information about the templates, template name, location of where the template is stored in S3, specific version information. Similarly, in the deployment system, we have information about the deployed resources, the environments. As I mentioned, we retrieve those outputs from your stacks and we persist that. And so all of that metadata gets stored in DynamoDB. Both are obviously super popular products and well-loved, and we feel the same way. And then again, since all of this is customer data, we want to make sure that we're properly protecting everyone's data. And so all data is encrypted by default using KMS. And then we also offer additional customer managed encryption options as well. So as I mentioned, we're fully serverless. And so why are we fully serverless? And to discuss that, obviously we heard a lot about, the difficulties of managing it in the previous talk, but just to reiterate, prior to the introduction of serverless technologies, building and scaling an application was a significantly more painful process. Scaling for peak could potentially require requesting new hardware months in advance. Then once you had the hardware, it's your responsibility to monitor it. If a host goes bad, you need to replace it. It's quite a lot of effort spent. EC2 has done an amazing job of managing a lot of this for you today. But even once you're on a host that is definitely healthy, there's still a lot of management that has to go on there. You need to manage the software that's on there, make sure it's all in line with the development environments that you're using, and you need to manage the deployments to that and so much more. And so with serverless, all of this pretty much goes away. Both ECS Fargate and Lambda handle the job of monitoring the health of your instances. They automatically replace them when you need them. If you need, when you're ready to perform updates, they manage all of that for you. And so it's just a much more seamless process. Similarly, scaling is a seamless process. And Lambda, it'll continually scale until you hit your limits, which you can then request increases on. And then Fargate supports either auto scaling of tasks, or you can manually set those tasks if you want and increase that number as needed, which is, super easy configuration. So all around, serverless, if you can make it work with your application, will save you a lot of operational pain, and I would definitely highly recommend considering it. And so then the next question is, which serverless technology is right for you? And the reality is there's really no perfect answer to this question, and a lot of it comes down to preference. And so for us, we kind of have it split up into two categories. We have our web services. These are long-running services. They might have a lot of dependencies that require a lot of initialization for their clients. Maybe there's some caching involved. And so we want to be able to gain the benefits of not having repeated cold starts for that initialization. And then obviously the benefits of being able to cache if needed. And so, in those cases, we prefer to leverage Fargate since the tasks are only terminated when either they need when we're ready to perform an update with a new image, or if if they start to malfunction and Fargate ECS detects that. And then additionally, we found that with the development process and writing the code, web services have the capability of kind of having more complex business logic. And so, and that business logic can't always be broken down into completely small, isolated pieces of code. And so it's helpful to have this fully built application inside of a single container that can quickly be spun up for testing purposes. But then, there are some times where you are running small isolated tasks. And as I mentioned before, that's kind of what we see with step functions. We have these workflows that perform a lot of individual responsibilities, always in the same order. And these tasks don't necessarily require an amount of resources. They're not doing a lot of complex logic. And so we liked the simplicity of just managing these functions, these Lambda functions inside of the step functions workflow. And we actually found that, when it sort of reframes your mindset when you're actually developing, and it helps you to, in this specific case where like workflows benefit from small isolated logical components, it helps you to sort of think more about how you want to isolate that logic. And then obviously it's easy to test these small isolated tasks in isolation before you need to test the entire workflow. And so the last thing that I'm going to touch on in our architecture is monitoring.
I love this every time it comes up.
Yeah. It's a very important aspect in application development. In order to offer the best possible experience for our customers, we want to be notified of a bug before it even impacts them. And we handle this through continuous integration testing, through canaries that are constantly running against our systems, but also by emitting these metrics about all the behaviors that occur throughout the entire system. And we're using CloudWatch for that. Metrics, they include API failures, dependency failures, latency, call numbers, and a lot more. And one particularly interesting metric that I kind of like to talk about is it's like a customer experience metric, which can easily be overlooked when you're really hyper focused on, are things failing? Which is, we're tracking the overhead added by AWS Proton onto deployment times. So, without AWS Proton, you have your CloudFormation stack, you provision it against CloudFormation. That's an instantaneous call for you. So we want to make sure that we're minimizing the time between when you call to create an environment or a service and when Proton actually makes that call to CloudFormation, to make sure that we're not spending too much time before then and causing a negative customer experience. And then finally, all of these metrics are connected to alarms. Alarms have varying degrees of severity to alert our on-calls of potential issues, which they will then address. So that pretty much sums up the architectural deep dive. So what's next for Proton? Very soon, we're going to have cross-account environments, which has been a really highly requested feature from our customers. It's generally considered in AWS practice to split up at minimum stages like beta and prod, but even applications across multiple accounts. Again, we talked about in the past, even within Proton service itself, we've split up all the individual microservices into separate accounts. And of course, that applies for the stages of those services as well. And again, that's to enforce that deployment safety and the enforcement of least privilege. And so with this feature, customers will be able to deploy from a single AWS Proton management account to many environment accounts. And then in turn, services that get deployed to those environments will also run inside of those environment accounts. Additionally, we launched initially with support only for CloudFormation as the provisioning option, but we want to start adding in all the tools that you guys know and love. Terraform, Kubernetes, CDK are ones we're eyeing initially. And then similarly for CI/CD options. Today, only code pipeline is usable, and we want to invest in enabling more options there as well. And of course, there's a much longer laundry list of features that we plan on adding and we're excited about. You can check out our public roadmap if you want to learn more. And if you don't see anything on there that you want, we monitor that roadmap actively. So please put in requests there. So that's about it. Thanks for listening.
Awesome. Thank you, Aaron. And we've had a couple questions come through chat that I want to call out, but one of them was, how does Proton relate to Copilot? And the way I like to think about it, and Aaron, you correct me if I'm wrong, but I like to think of it as AWS builds Copilot for the end user, the operator, whoever it is that needs to run their service. But what if you have an organization within your company that wants to build a customized experience that they can then stamp out services and offer up that customized experience to other service teams. So it's like an internal customized Copilot, so to speak, that the company gets to own. Is that a good summary?
Perfect answer.
Nice. Awesome.
Thanks, Brent.
Good job. I'm so proud of you.
I don't know. I try. They keep letting me come back to work, so I think I'm doing okay. There was another funny one that, where was it? It was, I love the longer I procrastinate building a solution, the more AWS developers have already built what I need. I applaud your support of my ability to continue to get lazier.
We're always supportive of being lazy. That's the best way to approach software development as far as I'm concerned.
Totally. Yeah. And I know it's funny, it's humorous, but at the same time, pay attention to our roadmap. Aaron brought it up. We've mentioned it throughout the day. There's a containers roadmap. There's a Proton roadmap. So whatever you're interested in, go to that service team and look to see, do they have a roadmap? And if you see something on it, especially, if it's being worked on, don't spend your time on it. Let us go ahead and take on that responsibility and solve that problem for you. And then if you don't see it on the roadmap at all, go ahead and open an issue, put it on there, and explain your use case. And then you might be writing some code to work around whatever that issue is for you. But just look forward to the day when you'll get to delete it, like Adam mentioned earlier. We love deleting code.
Absolutely. And can I just say, Aaron, that was really cool to see kind of the internals, under the covers as to how y'all approach this and how you built things out, taking advantage of serverless technologies, manage less and focus on the code, right? That's how we deliver features faster to customers. So super cool to just get the inside scoop. Thank you for that.
Yeah.
Awesome. So up next, we're going to take a little bit of a turn, and we're going to talk to some AWS employees about what it's like to work at AWS, because there might be some of you out there in the audience that are thinking, I think it'd be cool to work there. I could join the team. So I'm going to go ahead. Let's say goodbye to Aaron, and thank you. And
Thank
then
you.
we are going to add in Asha, and if we can get NRH back on video and Deepak to turn on his camera, we'll add him back in as well. Awesome. So the gang's all here.
I am not a useful sample set for this, by the way.
Well, I mean, if you put on your manager hat, of course, that's one conversation we can have. What are you looking for to hire, and what's the, what are the roles and that kind of thing. But I'm also curious, just, we were all new employees at one point or another. Who has a good new employee story? What can you tell me about what it was like day one to work here?
I think Deepak is the newest, so I think Deepak should have to go first.
Oh, yes. Awesome.
New employee story, day one. Day one, my laptop was broken. So I don't want to start on that note. I'm looking for a good example. But
Every
when
day
the
is
laptop
day
was
one, Brent.
broken, sorry, go ahead, Nick.
I knew that was going to come up. This is my 1000th day one.
It's always day one.
Brent, I would say that, like starting, I had, what was nice is I had some time to ramp up and really like kind of build up my familiarity with the services. And, that's one thing here. You come into the team, every role's different, right? I'm just speaking for my role. In my role, I get to talk a lot and build demos, which is really fun. So I guess not much has really changed, but there's that time to just on ramp and learn and really immerse yourself in everything that you want to immerse yourself in around the service. So for me, that was really awesome starting on this team. I had so much fun.
For me, I was early in the containers organization, and I think of it as early anyway. And I got to really get to know the team and kind of the thinking behind how we do stuff. And over the course of time, we've launched so many services, and it's really just sort of reinforced the thinking and like how we decision make based on the customer. And it seems like it's magic, but at the same time, it just seems like, why doesn't everyone do this? It just seems so obvious.
So here's the story I have. Now that I had a moment to think about my day one, not on the spot, off the spot for a few seconds. So I had a really good welcome that I didn't expect from a senior leader in the containers. I don't want to name names here, but the senior leaders in the containers PM team reaching out to me, hey, see that you joined. Here's a list of links you probably want to read up on, understand how we write press releases, understand how we write working backwards docs, how we write MBR. So stuff you want to know about. That was really useful. A lot of Amazon work life is about writing docs, reading docs, and it's very effective. You get to crystallize your thoughts, and getting that training, everybody has to go through that learning process, no matter, because I haven't used this skill as much in other companies. It was more of slides. So that was a nice warm welcome and a useful set of links for me to go and read up on. I found that very helpful. They were not even in my management chain. So it goes to show how nice people are around here.
That's really cool. Asha, what about you? And you're on mute, by the way.
Can you hear me now?
Yes.
I have a mute unmute. I'm forever challenged on that aspect, especially after our virtual lifestyle. But my date was almost 7 years and a month ago, so I can't really remember it. All I know is I've aged quite a bit, not necessarily due to Amazon. I think it's more because of parenthood. But nonetheless, I think probably the most unique thing that I remember and the most memorable moments of my time at Amazon is I think you really have a lot of ability, autonomy, and ownership to drive impact that you want for your customers. It's one of those places where the best way you learn is by jumping into the ocean, whether you know how to swim or not. But you do get a lot of support, to help you find your way. And I think one of the challenge, I did not start in the containers org. I actually started in the solutions architecture org. And I think when I moved into the containers org, to echo what Deepak was saying around docs, I'm the type of person who I like to take a doc, read it, and I marinate on it. And that's when I get my thoughts and creative juices flowing. But I think it's one of those things at Amazon, you become really, really quick at it, where you just read docs, it's a ton of information and ideas, and you discuss it with people on your team. And I think that's the reason I think that's probably a really good way to do it, is because you're getting a ton of different perspectives right from the get-go. as opposed to kind of going into your own shell and kind of thinking through things. So I feel like that's been a huge differentiator for us, and a really good way that we can drive impact not only for the business but for our customers and our own impact in our own ways.
That's awesome. So I know we're growing as an organization. I know we're hiring. What are we looking for? What are the hot jobs that we're looking for people to fill?
I mean, Amazon's hiring for everything right now, Brent.
Of course.
A couple things off the top of my head. We are, of course, always looking for great engineers of every stripe, flavor, color, etc. We have a couple of things going on in my organization that are worth calling out. And the first thing I would do is like shout out to the East Coasters. We are hiring very heavily in New York and New Jersey. So for folks that are looking for a little change of pace, please come see me about some fun challenges that we have going on the East Coast. We do Proton on the East Coast, which you just heard Aaron talk about, amongst other things. We're also looking for front-end engineers. So there's a bunch of stuff across ECS, Proton, etc., that really is like very sophisticated user experience problems. And that's a pretty big challenge today, and it's only going to get more challenging. Like there is a real art to making the like power and complexity of the cloud simple for people to navigate, to interact with, and to use. And to do that, we really need great front-end engineers. And so we're pushing pretty hard on front-end hiring right now.
Awesome. And you mentioned East Coast and some localities, but a couple questions have come in. Are there any worldwide remote positions, and does AWS hire remote workers?
The answer to that is kind of. So first off, there's not a single answer to that for AWS. AWS is a large organization, and different teams are approaching, let's say this like new world of post-COVID work in different ways. I can say that for my organization, we very much believe in the principle that software engineering is a team sport. There aren't a lot of there's not a lot of like software engineering work that is impactful to our customers and our businesses that can be done by individuals. And so I don't think anybody's looking at the next year as we're getting everybody back into the office 5 days a week. But we do think that it's really important to be able to bring people together for collaboration, for brainstorming, for building trust in that team. And so we tend to shy away from full remote. We want people to be able to commute to the office where the rest of their team is located. But we're not looking at like full return to office certainly for the foreseeable future. But I would also just say, I think everybody's still figuring this stuff out right now. I think whatever I say today is likely to be a little different 6 months from now and a little different after that. So, across the industry, we're in pretty new territory.
Yeah. And I would even add to what you said, reach out, don't eliminate yourself from consideration over something that trivial, because your choices might change. You might consider moving, or if a particular listing that you're interested in doesn't end up being a good fit because of distance, a different listing that you weren't aware of might be a terrific fit and might be very open to remote. So definitely reach out. Don't let that be a barrier. Asha, what kind of positions are you looking for?
Yeah, so I think our team, my team rather, we lead go-to-market for ECS, Proton, Copilot, a lot of the services you must have heard about today. And what we typically do is, if you think of the go-to-market team, we're kind of the field and customer-facing arm of our product and engineering teams. We sit in the path of customers' field, right in between them and product and engineering. And I think what I think what we're looking for is, essentially someone who is a technologist who has operational experiences in distributed systems, container deployments, and workloads, and as well as the container ecosystem. And the key thing is the ability to think at scale. What are some of the mechanisms you can put in place to scale adoption of the business? Our main charter is to grow the business and help our customers, have impactful businesses running containers on AWS. And however, which way we can figure out trends, patterns, things that we can capitalize on to help our customers and to scale adoption of the business is really key to what the go-to-market team works on. And we're chartered with building a long-term business. So we're not, I don't want anyone to think that they've got to achieve a certain amount of business in a particular year. It's really building a huge business at scale, via strategic oversight of a go-to-market plan that you build and you own, as well as coordinating kind of the incubation and launch of new services that come out within the AWS container portfolio of services. And of course, I think the most important aspect is to be able to help customers be successful using our container services and driving those wins. And I think, if I could just summarize kind of the critical competencies, it would be a passionate technologist, someone who can earn trust with developers and operators, and also have experience with impactful customer interactions and be able to work with a number of different stakeholders internally within AWS as well.
Awesome. So we had a question come in. What about junior developers fearing the interview process? And I just want to broaden that just a little bit and throw it to Deepak. And just more broadly, just talk to us a little bit about the interview process itself. What is that like? Not necessarily just for junior developers, but for all of us. Uh-oh.
Okay. All right. There you go again. The magic of Shine.
Right.
Great question. I did quit it though. You shouldn't hear it anymore. What I love about the interview process at Amazon, in fact, having been somebody who's done that recently, is that there are no trick questions. There are no puzzles, at least on the product management side that I can speak to. It's all about customer obsession, how you handle defining products. It's a lot about your own experience. So if you just look at your past, all the stuff that you've accomplished, and take the time to write down why you've done what you've done, I think you're already just as prepared as you can be. Certainly in the PM, like I said, other companies that I've previously interviewed with, you'd probably go through some sort of puzzles as if they're supposed to test for intelligence on the spot. I don't adhere to that philosophy. I believe in customer obsession and building products that delight users and thinking strategically about where the product and the space are going. And that's certainly how Amazon thinks as well. You can see our leadership principles on the website. That's usually what our interview process is. And when a recruiter reaches out to you, they handhold you. They'll give you all the examples you need to get through the process, and they'll coach you as well. So,
I would tag one thing onto that, which is so Amazon is pretty unique in certainly my career, and I think in the industry, in that we talk a lot about things like leadership principles and tenets, and it's not just talk. We take those things very seriously, and as an example, we evaluate candidates based on the leadership principles. That's sort of the lens that we use, and that's across WWSO and PM and engineering and everybody. So you could take that as intimidating, or you could say that there is a cheat sheet out there called the Amazon Leadership Principles. And if you can do some studying up on those principles, it'll provide some good guidance for your interview process. I also think it's important to really look closely at those. And an interview process is a two-way street, and you're as much looking for an employer that is aligned with your values, and that's going to be an exciting and engaging place for you to work. And I think if you go through the leadership principles and those are exciting and engaging to you, you're going to have a great time at Amazon.
Well said. Sorry, didn't mean to cut you off.
Oh, it's all right.
I'll tack on one thing to what Nick and Deepak said. I think one of the things that you want to keep in mind when you're interviewing with Amazon is be able to dive as deep as you possibly can in your responses. We're really interested in understanding kind of the core of what you specifically did, what outcome and what impact did you specifically drive. So I think a lot of times, candidates sometimes come in and they stay high level. Don't fear to go deep, right? Just go as deep as you possibly can. And if we need to pull you back, we will. But I think having more context, more details, the challenges you faced, how did you overcome it, and what impact and outcome did you actually drive, really tells a tight story about your experience and how you think, and it provides a platform for really good discussion.
Awesome. So this has been really great. Who do we reach out to find job listings or just more information about working at Amazon? Is there a link that someone can post, one of our moderators can post in chat? Amazon.jobs, if I'm remembering correctly. There we go. Thank you, Nathan.
So Brent, before you wrap up, there were a couple of questions in the chat that I really wanted to get to.
Go for it.
One of which is the cat's name is Quincy. Somebody asked. I have to, as a cat person, I have to cover that. Two is there was a good question about I think how is AWS taking on DEI engagement and prioritizing that effort in leadership positions?
Thank you.
And technology verticals that are typically white male dominated. So that is an excellent question and a very important one. So there's not a simple single answer to that, and obviously this is a very challenging and very important topic. I can say we work very closely with recruiting and sourcing to ensure that the candidate slate for any position that we have at Amazon has a diverse set of candidates in the pipeline. We obviously get into more challenging territory the higher up the sort of the higher up the leadership ladder you climb. That is just an unfortunate aspect of numbers and the system that we have been living in for a long time. But we work very hard internally to ensure that diverse employees and diverse candidates get fair and equal access to leadership roles. We make sure that those candidates get great mentorship and great sponsorship internally. And as somebody responsible for a large organization at Amazon, I can tell you that, my performance is determined based on, my ability to attract, retain, and engage a diverse group of people. So we do take that very seriously.
Awesome. Very cool. Where can people reach you? LinkedIn, Twitter, what are your preferences? And are you readily available? Do you want people reaching out to you directly?
Absolutely.
That's a trick question.
Right? You have to say yes.
LinkedIn, since you asked.
Yeah, it's the best way.
Okay, cool.
I prefer the Twitter. I think LinkedIn is a little bit too insidery, but
I'm kind of the same way. If you have something that you sent me on LinkedIn, I check it, like once every couple of weeks or so. I'll get to it, but hit me up on Twitter. I'm a bit faster there as well. Well, thank you all for joining. And up next, we're actually going to talk to Carmen Puccio, and I hope I said your last name right. And we're going to talk about Docker Compose and the integration that exists between that and ECS. So thanks everyone for joining. I'm just going to drop you out. I'm going to bring Carmen in.
Hey everyone, can you hear me okay?
Yeah, we got you.
Awesome. Awesome. Thank you for having me. I do appreciate it. How's your day been so far, Brett?
Whew, it's been a good one. It's been a long one, but a good one.
Yeah. I was sitting backstage, and so before I started, I had to tell the story. The interesting new hire story. I couldn't help but just reflect back on my time.
We all have them, right?
It was funny because I had been here a week and I flew home from Seattle, and within probably about a day, and my manager warned me about this at the time, he left for paternity leave. So I was basically a lone wolf. But the one thing that I would say is, like, there are so many resources internally at Amazon that were willing to help me during that time because he was essentially out of pocket. So it was interesting to hear their perspective, but I couldn't help but reflect back on mine, even though it was like 4.5, 5 years ago. So it's still remember it to this day. So
that's awesome.
Yeah.
I don't see a screen share from you, by the way.
Yeah.
And
Nope. I'm going to start it. Yeah. Going to start it right up. And you should see this one. I'll move this over.
Got it.
You should see a GitHub repo, right?
Yeah.
Okay.
Twitch, tell us if that font needs to be a little bit bigger.
Yeah, and I can definitely do that. Okay, cool. All right, so with that said, I'm going to just jump into this. We're here to talk a little bit about the Compose integration that we did with Docker and ECS. I have some slides. I don't necessarily want to make this slide heavy. I'd rather it be a conversation. And at the same time, like, I build a couple of demos. I can't promise you that they'll work. They worked once, so I go by the mentality: if it works, then ship it. So we'll have a little fun a little bit later on, and we'll do some demos. But with that said, let me just bring this up, and we'll do just a quick flyby on the slides. So just real quick about me, you've probably seen me bounce around in various different talks here at AWS. I'm currently a senior manager within the AWS program, our partner program for containers. I also run our serverless teams, and what that essentially means is we're working with our technology and consulting partners to essentially adopt and integrate their solutions and their offerings with, whether it be AWS container services or serverless services. Before this role, I was the principal solutions architect within the container partner team. I was also part of the mass migration team here at AWS when I first joined. And then prior to that, I was a global infrastructure architect over at the Associated Press. So little background about me. And at the same time, like, it was awesome to hear NRH call out the East Coast and New Jersey aspect of things. I am out of New Jersey, and I work out of.
I was picking up a little Jersey.
Yeah, I've been told I have that accent, right? So I definitely work out of our Jersey City office, and you also see me bouncing around sometimes in Manhattan as well. So with that said, I don't really want to talk about this slide. I just wanted to put it in here for folks when they look at it offline. You should know the benefits. Like, you're here today, you're excited about containers. But what I wanted to do here was talk a little bit about like my personal journey and how this all led to this integration. I think back to my time when I was a customer and what I was doing in my prior role before joining AWS, and essentially I was responsible for moving a lot of workloads over to the cloud. We were primarily a .NET shop, and at the time, like the container ecosystem and Microsoft and Windows support wasn't necessarily there, but like the concept of Docker was tremendously exciting to me. So I was always just investing my time and efforts on the side into that space, and for all the reasons that you see here. But like, I look back on how we used to do things, and it was very much, standing infrastructure up with CloudFormation templates, very EC2 based, user data scripts, trying to get all that bootstrapping in place. Eventually, we got to a point where we're doing like an Omni pipeline to speed up our deployments. But the thing that was troublesome in all of that, it was a lot of time and investment that we spent to spin up just simple little, web applications or whatever it may be. And then to get the developers onboarded with that process was very challenging, right? So the one thing that people love about Docker and they love about containers is it just works, right? Like, it doesn't necessarily matter from environment to environment, like that it works on my machine, mentality is very much a real thing. And I think back about how we used to try and get our developer teams to onboard with processes. Like, we were using configuration management tools, we were using things like Vagrant, and it's almost, I don't want to say it's a waste of time, but it is a waste of time for them to focus their time and efforts learning those things. They should focus on the application and to get the application out in a clean and consistent manner, right? So again, the benefits of containers, it really tells that story as to why I saw it then, and I saw it as essentially a value add that I wanted to adopt. But if you fast forward to my time joining the AWS, I was on that team working very much in the same vein, where we were working in a lift and shift scenario, very much focused on EC2, again, keeping my thumb on the pulse on the container ecosystem. A position opened up where I took on a role of partner solutions architect with Docker. And during that time, like, collaborating with their team, trying to figure out how to make things easier for two things. One, to make containers easier to run on top of AWS, but two, how can we essentially make it easier for customers to use Docker? Is there a seamless experience that we can build? And that essentially got us to where we are today and what we're here to talk about. It's the integration with Compose and ECS. And we picked ECS for all of the reasons you see here. But, brainstorming back in, I want to say we started these conversations in late 2019, early 2020. And we started thinking, like, what could we possibly do to make this a clean integration, an easy on-ramp? Docker has this vibrant community, a huge ecosystem of developers that are using their tool. What would it take to make it essentially an easy button to get those workloads into AWS? Because realistically, not every developer has AWS experience, and maybe if they do, maybe they don't understand the constructs of running with it within ECS. And is there a way that we can basically make that mapping? And that's what led us down this path of saying, okay, let's figure out how we can make that essentially that easy button. And moreover, we targeted for the first version, we targeted Fargate because, again, we wanted to think about it in a managed perspective. A developer shouldn't necessarily have to worry about managing compute or fine-tuning things that are very much infrastructure related. Let them focus on their application, as I was talking about before. So for the first iteration, and I'll get into the feature set, but the first iteration, we definitely targeted the Fargate, the AWS Fargate platform. We subsequently did launch with ECS a little bit later, but that was our thought process during that time frame, which gets us into what did we pick as essentially that shim? Hopefully most of the folks on today's presentation, they know about Compose. I shouldn't have to go super deep here. Like, think of it again as that way of defining and running multiple, Docker applications. You're specifying, as you can see here, in YAML format, and you're using the CLI to essentially do things like, hey, I want to build my container. hey, I want to essentially stop my container, or maybe I want to scale it, whatever it may be. You're defining all of that inside of this YAML file that allows you to essentially run these apps. And originally, at one point, I think it was developed for only Linux. It now obviously supports Windows and Mac OS. And again, like, because of the popularity, developers, they have a huge developer base, the portability of the Compose file, and the fact that the Compose spec is open sourced. We saw it as essentially a natural way to create that shim. So if you think about how could we actually take these applications and get them up into ECS, we decided that we would create this shim using Docker Compose. Under the covers, we're using CloudFormation to instantiate workloads up in AWS, and I'll go into all of this. So here's the super quick flyby, and again, we'll jump into a demo in a second. You're essentially doing this all through a context, and I'll show you how this works in a second. But by default, you're using your local Docker context to build images locally, and if you want to switch to the cloud, it's as simple as just moving to a different context. And that context picks up your AWS credentials to get the workloads instantiated and up and running. And then from there, it's these exact same commands. It's everything that you're used to doing locally on your machine. So you could do things like up, down, logs, so on and so forth, just in that natural, clean experience. But instead, you're interacting with the cloud. To my point before, it now works on top of ECS, while originally it was on top of Fargate. And at the same time, the thing that's actually kind of really, really cool about this that I like, and I'll go into this as well, is you can export these files as CloudFormation. So when I said it instantiates the workload using the CloudFormation API under the covers, it also gives you the ability to export it out if you want to take it and tweak it and do other things with it. And I'll show that to you as well. So what does it really look like? I'm just going to fly through this really quick. So here you can see just I have a simple Docker Compose goes up, and you're curling localhost. But the question that you have to ask yourself, and what we had to figure out, was what does that look like from the resource perspective? How do we stand up things like VPCs, the cluster, task definitions? Task definitions, they can be complicated. They can be big, right? How do we create those mappings? And moreover, what about the security perspective? When you're thinking about interacting with AWS resources, maybe it's a bucket, maybe it's a queue. How do you actually get the IAM permissions associated with these workloads when Compose doesn't necessarily have any knowledge of IAM or the constructs of it? So we had to work our way through all of these resources and figure out what that essential mapping would look like. And at the same time, what would good look like? What is a good starting point, if you will? And here's a quick flyby on, and we'll go into this when I jump into the console. But this is what that example application is essentially instantiating behind the scenes. You can see here it's creating a VPC. You see the Fargate cluster. You see the front end service communicating with the back end service. We're using Cloud Map and just the native service discovery within ECS to have the two services communicate with each other. And then to my point, we're attaching an IAM role that allows you to do things like push logs up to CloudWatch, or maybe you have to pull the image down from ECR. All of that is essentially handled for you out of the box in a batteries included model. And it also wraps things around with, from a security perspective, with things like security groups, and creates load balancers for you in terms of handling ingress. So by taking that exact same Compose file that I just showed you a second, which was probably about like 6 lines of code in a YAML file, you get all of this as a reasonable default. But obviously, you probably want to change all of those things, and that's what we're going to go into now. So I'm going to hop into a demo, and we'll start with just the first example, right? So I'm just going to switch to that simple little Compose file. So if you look at this Docker Compose YAML file that I was talking about before, it's the exact same thing, right? So this is what was inside of the slide. If I just do a Docker Compose up, it's just pulling it from Docker Hub, creating a network. And if I do a quick little curl on localhost, right? Super exciting, nothing fancy, right? But at the same time, now you're a developer and you want to essentially ship this to the cloud, right? You want to actually get this up and running. Let me just stop this for a second. While this is stopping, I'll go to a new screen. So
While you're doing that, we had a question come in that I thought was pretty cool because it made me think of something I hadn't thought about in a long time. It was from the Tech Guy 21. How would I test locally, especially if using some AWS services? I was looking for something equivalent to AWS SAM experience.
Yeah.
And while I was trying to remember, someone else answered, I've used this with some success, and they linked to Local Stack.
Local simulation. Yeah, this was added post GA. So we went GA with all of this in November, right around the reInvent timeframe. But yeah, basically, it's a very good question. Like if you think about it, and I have it up here on my screen as well. I don't know if you can read it, but a lot of times people need to look at things locally, right? You want to test locally before you go up into the cloud. And using essentially the local endpoints, you have the ability to do so. So super cool functionality, and more than anything, I think it's a great statement that folks are putting feedback into the repo, the Compose CLI repo, about the things that they'd like to see, and they're building based off of that, right? So working backwards from customer demand, and I'll link to the Compose repo for other ideas. But obviously, this is one that we didn't think about, right? So when we went for GA launch, this was not included, and obviously it was launched, shortly thereafter. So cool. So when I was talking about the contexts, right? So hopefully you can see my screen. Maybe I can make the text a little bit bigger. Here's just the default context that's going on inside of my machine, right? So I'm interacting with the local Docker daemon running on my Mac. But if you wanted to do essentially, a context, this is a brand new installation, you wanted to create something, it's as simple as just doing this. Right. And what it's going to do is it's going to give you some choices, right? And I'm just going to pick my existing profile, and I already have a couple of profiles, and this is your AWS profile, right? This is attached to your CLI. So if I pick this one, I now have, this context created locally on my machine.
Can we zoom in one or two notches?
Tell me when I can make this full screen, and I can just kind of flip-flop back and forth.
That should be good. I'm waiting to hear back from Twitch. We'll see.
Okay. But as you can see here, like we have this net new one, right? So if I go and I say Docker use Docker context use, right? You're now switching, and what'll happen is if I go and I go back to this window over here, which has my application, right? So the application is shut down, and I'll make this bigger again, right? So if you look, the Compose file is no different. It's the exact same thing, nothing fancy there. But if I do a Docker Compose up, what'll start to happen here is under the covers, it'll start to instantiate that workload up in AWS, right? So what it's basically doing is it's starting to synthesize that CloudFormation template, and using the CloudFormation API, it's starting to create things based off those reasonable defaults that I was talking about earlier. This will obviously.
I'd blow it up a couple more times.
Okay. How's that?
Whoa.
that might make the visualization a little weird, but that's okay, because I was going to
the worst time to ask, didn't I?
No, I was going to switch to the console anyway, so it's okay.
Cool.
Let me minimize this. All right, so if I go to the AWS console, and I'll definitely make sure the view is big here, Brett.
Awesome.
So what you're seeing is essentially a stack getting created, right? And if you look right here, and this is one that I already created just in case we had some problems with all of this. But what you're seeing is essentially the resources going. It's typical CloudFormation, like nothing different than what you would typically see. But as you can see here is the template that is predefined for you. So while this spins up, I wanted to jump over to a pre-existing stack so I can just show this to you in real time. So because we're limited here. What'll happen is if I go over and I go over to things like ECS and I take a look at the demo, you'll see that front end back end service that I was talking about. You'll also see that there's a task definition created for you. And for example, here's the backend task definition with all of the settings essentially mapped for you. To my point before, things like execution roles are handled for you. Memory and CPU are also done for you. And I'll talk about how we can tweak all of that. And at the same time, interestingly enough, if we go over to the cluster itself and we go to the task, you'll see the service discovery piece is handled for you. So the DNS and everything is wired up. It's all ready to go, right? So if I was to sit it here and I was a developer, it's like, okay, maybe, I want to know how to interact with my application now. Sure, you could go crawling around inside the AWS UI, but at the same time, if I go over to, just real quick, I'll go to here. And if I do a Docker Compose, oh, sorry, let me just switch one thing here. So what'll happen is it'll actually give you the information about your running containers, but it'll also give you your load balancer information as well, right? So you don't necessarily need to go crawling around inside the UI to find that information. And then if I just did as simple as before, if I just did a simple curl on that, I get the running workload, right? It's essentially the exact same thing, but now it's instantiated in AWS with those reasonable defaults, which is super cool.
Let me ask you a question. It came in through Twitch, but I'm going to try and find it to pop it up on screen. Actually, I don't see it. But the question is how to switch to EC2 launch type. Did you specify that somewhere?
Yeah. And so by default, it's Fargate, right? So switching the launch type is essentially, again, it's a spec inside the compose file, right? So what I can do is I can share out as part of this. I'll share out the various different examples. And I think I even have one up here. So for example, like here's how you would define GPUs, for example. So like they added this support as well. So obviously you need to use EC2 instance type for GPU type workloads. So it's the exact same thing. You're doing all of this inside of the compose file, but what you're doing is you're specifying these new mappings, if you will, that they've put into the spec, which actually gets into a really great topic. And like I wanted to touch on this as part of the talk. If you think about it, like the reasonable defaults while all of this is going is great. But at the same time, like most people will graduate past that very, very quickly. And this is where the concept of extensions come in. And if you think about it, like here's a simple example. Things like VPCs or things like load balancers or things like clusters are probably going to exist somewhere in your organization. And at the same time, because the Compose CLI integration needs AWS permissions with your local account to instantiate those workloads, your AppSec teams might not allow you to create those types of things. Not every developer is allowed to create a VPC, but they might have a VPC that they're pre-provisioned, right? So we have the ability to import things into the Compose spec. And when you instantiate a workload with a Docker Compose up, defining things like XAWS VPC or cluster or load balancer, essentially what the Compose mapping is going to do when it creates that CloudFormation template, it's going to synthesize that in. And instead of creating net new, it's going to ref an existing resource. Obviously, as you spin things up and down, when you tear down, you're only going to tear down the things that are part of your Compose file. Any pre-existing things will stay behind, but it's an easy way for you to actually jump to that next level, if you will. So again, we have a whole bunch of these, and I just wanted to highlight all of them. And these are obviously, still growing, but the key ones that to mention, again, like the VPC one is a big one. The XAWS role when you're thinking about pre-provisioning, maybe an IAM role. But the one that I wanted to double down on, and I wanted to showcase the power of it as part of this demo, is the CloudFormation piece. And what's interesting about this is if you think about it, like AWS is iterating on ECS and Fargate and all of our services at a tremendous pace. And this is obviously an open source project that we're a part of and the Docker team actively maintains. But there's always that edge case where we want to basically jump on board with the latest feature, for example, or maybe something's not necessarily supported yet inside of the Compose spec. How can we work around this? So the Docker team over in Europe actually introduced a concept of this overlay or this extension for CloudFormation, and we call it an overlay. And what it essentially allows you to do is through the Compose spec, you can instantiate things inside of your stack based off of CloudFormation. Right. So again, the whole goal of this wasn't necessarily for developers to go and learn CloudFormation. We were trying to figure out that easy button, but eventually there's that tipping point. And our workaround for this, and it's probably easier if I just show it to you in practice. Our workaround for this was essentially to create inside the spec this setting, if you will. Right. So here is another example application. And this is just a simple little .NET application. And by default, if I would have spun this up, this application would have failed because health checking would not have worked. Because if you read the Compose spec documentation, an ALB by default will go to just /, right? It'll just go to the root of the target group. And a lot of people usually have things like /health, or in this case,
I think I lost your audio, Carmen.
How about now? No?
Sorry, it must be me. I'm going to fix myself. Keep going.
I was going to say, yeah, I was like, I didn't hit mute. No, but to my point, like some people have /health, / whatever it may be, but they also have a lot of other things that they need to predefine, right? They need to set these things. Maybe it's the status code, whatever it may be. So our way of going over this is by adding this CloudFormation overlay. You can then fine tune anything inside of the Compose file via CloudFormation. So in this simple example, this is literally based off the CloudFormation spec. This is how you would set a health check path inside of CloudFormation. And what happens is when you do a Docker Compose up, the integration will essentially synthesize, see that this has been defined, and then overlay it into the template. And I think the easiest way to show what I'm talking about here is if I do Docker Compose convert, right? You'll see the template that gets created, right? And if I had something specified, like what I just showed, and I said, overlay it, you would then see those objects overlaid inside of the CloudFormation file itself. So it gives you that tremendous flexibility that says, okay, the reasonable defaults don't allow me to get what I need done, or at the same time, the overall, the extensions, they're great, but I need one step further. This is essentially that step further. And what I'll say is that the last piece, and this I can't promise this will work, but we'll play with it anyway, right? We'll do the Docker Compose CloudFormation extensions as part of just like, let's try something net new, let's try something fun, right? So if we go back to that file that I was showing before, and I have it up in Sublime Text here, right? So here's that exact same file.
That's got to be bigger.
Yeah, for sure. Yeah. So wouldn't it be cool to do something like ECS exec? I was actually thinking about this morning. I was like, wouldn't it be cool to show ECS exec? We know it's not supported with the integration. To those who didn't see the launch, it was a couple months ago. It gives you that ability to exec into a running container. A lot of times you have to basically do some debugging. And even though you should be admitting to standard out and standard error and capturing those logs downstream, you might want to go in and check and see if a config is good based off your deployment. So ECS now gives you the ability to do that. And moreover, now you have a way of doing that inside of Fargate. So I was thinking, like, how can I actually pull this off in this integration? And the CloudFormation overlay is essentially the way of doing it. So the way you would do it, and it's as simple as this. I'm just going to paste this in. Bear with me. Right. So it's the same Compose file, but I've added two things, and it doesn't necessarily look super complicated. Hopefully you can figure it out. The first thing I've done is I've attached a role, right? Remember when I said that we pre-provision an IAM role for you? And that IAM role is usually the task execution policy that allows you to do things like pull things down from ECR. If you read the documentation for ECS exec, these are the permissions that you essentially need to add to your running tasks in order to be able to exec in your containers. And then moreover, how to get the logs out. Because one of the cool features of it is it allows you to shoot out the commands that people ran when they were inside that container. And then lastly, again, the compose spec has no concept of essentially ECS exec. How do you do that? Again, the CloudFormation overlay is the way to do it. And you can see here, I'm basically saying for the front end service, which is, up here, the front end, just set these properties. And this is the default. This is the way that you turn it on inside of CloudFormation. So by saying this, and then doing a simple Docker compose up on the exact same stack will instantiate that workload with ECS exec running on it. And just to prove that, it works, if I do a convert here, and if I do, you'll see right here. So when we scroll up, and bear with me while I find it.
No problem. This is just reinforcing why it's better to do it using the Docker Compose spec than it is to do it using native CloudFormation.
Yeah, like I would have had to wrote all this CloudFormation, but in essence, like just by setting those 2 lines of code, now it's integrated into the template, right? And by doing a simple Docker Compose up, it will now update that existing stack. It'll turn on all of that logging. It'll give my tasks the permission that they need, so I can go in and essentially exec into my containers. And let's try it. So it's gonna take a couple of minutes. So let's hop to the one that already has it, right? So I think it's still running from earlier today. Like it should still be good. So here is, let me just back out so I make sure I'm in the right place, because again, live demo stuff. So here's the front end service. So if you remember, I turned it on for the front end. I turned it on for the cluster as a whole. The cluster needs the permission, as does the individual services and tasks, right? And if you look here, the task essentially has an ID. And the way that you interact with this is such, right? So let me just get this and let me open up the terminal. And I have the command over here because I would never remember this. And the ID is F79. Yes, it's F79. So what's going to happen? All right, so you can see right here, this is how you would instantiate an SSM connection into that running container. So here's the task ID, here's the container that I want to hit, here's the command that I want to issue, and it should work, right?
Boom.
And if I go in here and I do something, silly like touch, I don't know, like temp/test.txt, and maybe if I try and do like, I don't know, let's say, oh, no, somebody likes.
That's good. I was gonna shame you if you had Vim inside your
somebody liked
container.
So anyway, but like you see here, I'm now inside of that container. Like if I do an ls on like etc/nginx, because this is an nginx container, you'll see I'm exec into that Fargate container. And if I get out of here, what's super cool about all of this, and if I go down to the logs, so again, all of the logs are wired up for you. I did nothing special here, right? All of this was wired up with the reasonable defaults with the integration that I was talking about. And if I check out these logs over here, and I go to CloudWatch and it's thinking about it, right? And I look at my log group, these are the logs for obviously the application itself. And this is the health check just going off and off and off. But if I go back a layer and I check out right here, here's the SSM logs for the commands that I just ran. And if I refresh, I'm assuming my new events should be here, or it's going to make a liar out of me. Oh, no, here it is right here. Yeah.
That's awesome.
Yeah. So again, like super powerful stuff that you can actually overlay your templates with this integration and get to that next level inside of your environment. And there's a wide array of options. Like I can jump in based if anybody has questions. Like we can do things like secrets, load balancing, roles, storage. To my point before, changing your task size, like it's all configurable. But if you get blocked with an overlay, or I'm sorry, with a compose extension, you can always use an overlay as your next step. So curious if there's any questions, but other than that, that was essentially where I wanted to go with this, Brent, was just to show some of the simplicity and at the same time the power as well.
That's a fantastic example and a great demo. One of the questions from a while back was actually, since you mentioned it, about, does this work with EFS if you wanted to build storage into your container?
It does. And this was also one of the requested features. Let me just kind of bring this up again as well. So there's multiple ways of tackling this, right? So you could see it right here. This is a simple example. And again, like all it's saying is like, I need a volume. By default, it'll give it to you, right? With reasonable defaults. But again, you need to tweak things, right? And this is where it gets kind of cool. So you have the ability to basically say, like, I want to set some options, right? And maybe it's lifecycle policy, or maybe it's provision throughput. All of this is native, right? So you don't need to go down the CloudFormation overlay route with this. You can just do it natively within the tool. And moreover, if you needed to, you could do it with an existing volume. Because a lot of times maybe it was created out of band, and the whole point is you kind of want that thing managed by something else. You would just reference it as part of this, and obviously you could interact with it with your containers. The one piece about this is, if you decide to have the compose integration instantiate the volume for you, as you turn your tasks down, by default, it'll leave it behind, right? Because most likely people are doing things like persistent storage. Maybe they're putting a database, like a Redis database or something like that. When you spin that stack down, that EFS volume will be left behind, so subsequent tasks can take advantage of it and pick up where it left off.
That's cool. Very cool. Someone else asked, does the user invoking that execute command, was what he was referencing, need SSM access to run that?
So the SSM integration you're referring to, the person who's instantiating in, so he would obviously need higher level privileges as well, right? So it's controlled down at the task. So you're basically saying, I'm allowing this task to essentially be executed into. And then at the same time, in terms of like who I am, that's just native AWS CLI, like whether it be describe instances or execute SSM command, you would need that privilege as well as a local developer to be able to go in and auth into that running, Fargate task.
Awesome. And then we had a couple, like there was a question asking, is there a supporting blog post? And Tim answered the question. So I'm popping that URL up on the screen. Then
there's a really good one, if we can find it while we're chatting here, like Massimo did one as well, around CI/CD and all of this. So if not, I can find it maybe and just post it while we're sitting here and chatting.
Okay, awesome.
That's the one you just had on the screen, Brent.
Oh, okay.
The automated software delivery using Docker Compose.
There it is. Perfect.
Awesome. All right, so my question, this is for me, but it's kind of a recurring theme for the day. This goes on the list of the 17 ways to run a container at AWS. How do you decide? Do I do this? Do I do Copilot? Do I do CDK? How does this fit into the decision matrix?
So it's hysterical. Like, I'll go back to my app, right? I think, the it depends model, it works, but at the same time, it's like, what are you comfortable doing? Like, that's how I look at it. So like the one application that I wanted to get into as part of all of this, and feel free to go explore it. This is that .NET application that I was talking about, and I just didn't have time to demo it. I build it every which way, right? And there's really no wrong or right for me. It's just what do I feel comfortable with? Like, I love the aspect of being able to do the simplicity of compose, right? Single command, it does everything I need and it gets things up and running. And then if I think about things like the CDK, like I love that ability to essentially instantiate all of this in code and be able to make like mini classes and things like that. So this app up here has the various different ways of doing it. If you want to run it in Kubernetes, I walk you through that. If you want to run it inside of ECS Fargate, great. And again, like, I don't think there's a right or wrong. I think it depends on what your comfort level is and where you want to start. Like, if you're a newbie and you haven't gone into the container space, why not start with the Compose integration just to get your feet wet? Like, I think that's just based off of today's demo. The simplicity is there. Hopefully it was apparent. Learn how to essentially define a container and build a container, stand it up, switch context, and the next thing you know, you're up and running inside of AWS with just an easy button. It's kind of how I say it.
Awesome. And just to kind of follow up, I don't know how to say your name, but it's been asked a couple times, does this negate the need to use Terraform, for example? And I'm going to go ahead and answer that and say, yes, sort of. But again, to Carmen's point, use what you're comfortable with. With Terraform, you're going to be building out all of these pieces, and you need to know how they fit together, how they work together, et cetera. And this is a higher level tool that you can bring to the workflow that knows all that for you and can fit all the pieces together for you. So this should be useful to you instead of Terraform. But if you're more comfortable using Terraform and you want to build using Terraform, then certainly, that's still a good path to explore.
Yeah, absolutely. Couple of quick plugs, while we're kind of wrapping it up, unless there's any detailed questions that I can address. We have a workshop. You can see it right there. Like, it was built by Anuj, the current partner solutions architect for Docker. Really awesome. Walks through things like storage and load balancing and auto scaling. Feel free to check that out. At the same time, I was mentioning like the Compose CLI. Go open up issues, talk about the things that you want to see. We're actively moderating that. There's actually a debate right now. Should we continue with the CloudFormation overlays, or should we externalize that with a file? Love to get people's feedback on that one, because it's a good debate. And then lastly, the DockerCon sessions. If you want to learn more about this, and in particular, the very first one, a customer reference that we're going to use is SiriusXM. An old colleague of mine is going to speak with Massimo on the Compose CLI integration and the things that he learned, trying this inside of his organization. So you get, the word from the customer. But other than that, like, anything that I can address, Brent, Adam, or
yeah, one last thing that I thought that Ref and Peace brings up that I realize is kind of important to point out is he asks, is this part of the Compose CLI or the Docker-Compose CLI?
So it's all one now. It's been merged. So it's actually native. So if you download the latest version of Docker, Docker Desktop, it's just all built in. So again, like, you don't have to do anything special and install it out of band. Like, it's all native now into the integration. And that was one of the GA target things that we needed to build, was to make sure that it was just easy for developers to be like, okay, I want to try this out. Let me try switching my contexts. So that's all built in if you download the latest build on your Mac.
Awesome. All right, Carmen, thank you very much. That was fantastic. I really appreciate it.
Yeah, hopefully the Jersey accent didn't kill you guys, but I appreciate the time.
It's been great.
And if anybody needs anything, feel free to reach out to me on Twitter. My handle is right here. Okay.
Cool. Thank you. Oh, I didn't mean to cut him off quite that fast. Sorry.
A little aggressive there, Brent.
Right. But then it would be weird to bring him back just to say goodbye again. Yeah. So thank you, Carmen. That was awesome. I really appreciate it. Wow. So we have reached the end of Container Day. But I feel like we talked about a lot of stuff. We went over a lot of stuff. So let's recap. We unveiled a new service in preview today, right? What was that?
A new feature, right? ECS Anywhere.
Okay. We'll call it a feature. I said a service, but
tomato.
Yeah, that's fair. Good point.
Okay.
ECS Anywhere, and so we want people to get started using that. We want people to give us feedback on that, and it's available, in all the regions that ECS is currently operating in. At least all the public regions. I'm not sure about the other ones, but definitely explore that. Send us feedback. We want to hear more about that. We also, of course, went over App Runner, and App Runner was not announced today, but what was it, last week, I think, something like that. So this is a pretty fast moving field. And so it still might be news to a lot of people that were here today. And so we want, again, try App Runner out for any of your request response services and let us know what you think about that.
And there's App Runner Workshop. If you want to run through a workshop to deploy App Runner, you can go there as well. Right, Brent?
Very cool. Yeah, apprunnerworkshop.com. Check it out.
Yep. And yeah, keep going.
I mean, no, jump in. You have to cut me off.
It's hard sometimes, No, I think we had so this is going to be, this session will be recorded. The whole thing, you can.
It is recorded. It has been recorded, and it is currently and will be available.
Containersfromthecouch.com. You should be able to see it on the YouTube page.
Correct.
And also it was posted in the chat just now. But we also had our AWS heroes on, and it was really cool to hear their experiences, their insight. Because again, these folks they're using this in the real world, and they have real opinions outside of ours. So that was cool to hear their views and feedback.
Sometimes it's hard to realize that there are opinions that aren't mine, but it's still good, right? And we had a good meeting from the developer experience, talking about developer experience. So that was a really awesome session to go back and watch. I want to go back and watch it again, actually. So that's really cool. We talked scalability. We had Massimo on to try and walk us through, how to make decisions about where things should run and that kind of thing. And
don't forget FA session, where he literally deployed a small monolith, broke it up all in the course of an hour. Added DNS certificates, all these things using Copilot. So that was super cool to watch.
That was so cool. And then, we saw the potential of what the Docker Compose integration has to offer as well. So there's just, like I said throughout the day, having choices is so nice, because there's not one single way that everyone has to figure out how to use. There are a number of ways and a number of places for you to deploy, a number of places for your containers to run, and you just choose what is going to work best for you and for your workload, for your team, for your organization. So yeah, that's awesome. All right. So if you thought this was great stuff and you want to hear more containers information as we run through it, as we try stuff out, Adam and I have a show that we like to do on occasion. We call it Containers from the Couch, and you can find it at containersfromthecouch.com, which will take you to our YouTube page. Subscribe there if you want. Hit the like button on this session if you want. And we look forward to creating more content and answering your questions and going over some really cool, minute details, as well as some really cool, new big features that we'll be rolling out.
Yes. And just, if going back, we have DockerCon this week. So check out the sessions there. If you're interested in working at AWS, working on with the containers folks, we posted some job links in the chat. Apply, reach out to us. We're glad to chat and help out. And yeah, that's it. I just thank you so much for everybody for spending the day with us. It felt like a long day, but there was so much content packed into it that I can't believe it's over. So thank you.
All right. And special thanks to our interpreters, Arthur and Stephanie. This has been awesome, and everyone has been thoroughly impressed with your jobs. So thank you very much. That's fantastic.
Thanks, everyone.
See ya.